What's going on, guys? In this video, we're going to be building a full stack application using the PERN stack. And if you aren't familiar with the PERN stack, the P stands for Postgres, the E stands for Express, the R stands for React, and the N stands for Node.js. So with the PERN stack, we're going to be building a Yelp-like application, a very simplified version of it, of course. And I'm just going to call the application Restaurant Finder. And so this is the application right here. Let me quickly walk you through the different features of this application. And so you'll see that on the homepage, it's going to list out all of the restaurants that are in the database. So we've got the name of the restaurant, we've got the city or location, we've got the price range just like Yelp does. Then we've got this rating system. And this is actually one of the more complex part of this application. I originally wasn't going to include it, but by including this feature, you'll see that we'll have to learn a lot more about Postgres databases. We'll have to learn about foreign keys and how tables interact with one another. And this rating system will be, it's a good example on how to create a reusable component through your application. So you'll see that we actually use this star rating component, multiple times through this application. But so next to the star rating component, we also have the total number of reviews this restaurant has. We have the ability to update a restaurant as well as to delete a restaurant, and we can even add in new restaurants. So let's say we wanted to add in Wendy's, and this is located in Australia. And the price range is 3 stars. We can add that, and you'll see that he gets added to the bottom of the list. And we can go in and update it. So if I went in and let's say that this is actually in New Zealand, and this is actually just a 1 for price range because it's fast food, we hit submit, and you'll see that the Wendy's gets updated to be in New Zealand. Whoops. To be in New Zealand, and it's got $1 sign. Now, if we click on any one of these restaurants, you'll see that we can actually take a look at all of the different reviews that are associated with that restaurant. So if we click on City Walk, we can take a look at the reviews for this restaurant. And so this is the detailed page for a restaurant. It's going to include the name of the restaurant, what its average rating is. So this is averaging 2.5 stars, and it's got 6 total reviews. And we'll build out this nice little card component in React to show the different reviews. And the review is just going to be made up of a couple of things. It's going to include the name of the reviewer, what his rating was for that restaurant, as well as what the review actually is. And so you can see that Kyle thinks the food sucked, and that's why he gave it 1 star. We can also make our own review, so we can add a review. Let's say Carl, and he's going to give it a 3-star rating, and his review is going to be the food was okay. Hit submit, and you'll see that after we submit it, we can see the new review. All right, guys, so that's pretty much the application. It looks fairly simple, and it kind of is, but it also is going to take a lot of work. So we have to cover a lot of different topics, both on the front end and the back end. And I was originally just trying to make like a 1-hour video, but I think this project is going to take a little bit longer than that. So just bear with me, guys. You'll get a chance to learn a lot. And so hopefully you guys can stick with me throughout the course of the video. And hopefully you guys get a chance to learn about all of the different components that make up the PERN stack. This is actually a video that I've been wanting to do for a while, just because there isn't that much material on the internet for the PERN stack. Everyone loves to do the MERN stack, however, and I just think that getting familiar with SQL and SQL-based databases is such an important skill set to have. So that's why I made this video. We're going to focus a lot on Postgres, especially early on throughout this project. And so even if you know absolutely nothing about SQL, nothing about Postgres, I'm going to walk you through the installation process. I'm going to show you all of the different commands to set up a database, to add tables, to add columns to a table, to create, edit, modify entries within the database, as well as how to set up foreign keys and things like that. So you guys are going to learn a lot. Hopefully you guys enjoy this video. And so I will see you guys there. Now, before we get started coding out our application, I want to make sure you guys understand the role that each one of these components will play within our full stack application. And so the first thing that I want to go over is Postgres. And so Postgres is going to be our database of choice. This is a SQL-based database. If you're coming from a Mongo background, it's going to play the same role as Mongo, except it just operates a little bit differently. And so this is just going to be where we store all of our data. And if you think about our application and think about what kind of data we actually need to store, there's really 2 things that we need to store. We need to store a list of the restaurants as well as a list of the reviews. So both of those things will be stored within our Postgres database. Then we have Express.js and Node.js. So these 2 components make up our backend. And so Node.js, if you're not familiar with it, it just allows us to run JavaScript on the server side. So it basically gave us the ability to not have to run JavaScript only within the web browser. And Express is just it's the most popular web framework for Node.js, so it makes it really easy to build out a web server within Node. Technically, you don't need to use it to build a web server, but it's there to make our life easier, so we might as well use it. But Node and Express, they're going to represent our backend, and we'll actually be building a REST API using both of these components. And then finally, we've got React.js, so this is going to be running on the front end. And so this is what the client is going to be interacting with, and the React.js will be responsible for sending requests to the API that we set up on the backend to retrieve data, to receive data from our database. Now, I've built out a simple diagram to kind of help piece things together for you guys if you're still having a hard time understanding the role that each one of these components play. And so basically on the left side in red, we've got React, right? So React is going to be running on our web browser. And basically what React is going to do is it's going to send various HTTP methods to perform various CRUD applications. And so, if we want to create a restaurant or write a review, it's going to send a HTTP post to our backend. And our backend is going to have all of the logic necessary to actually create a new restaurant or create a new review. React doesn't care how you do it, right? React just sends that HTTP method, and then Node and Express need to have all of the logic of performing the necessary tasks to accomplish that. And so since our data is actually stored in our database, Node will perform a few actions. It might clean the data, but for creating like a restaurant, it's going to have to then send that information to Postgres so that we can insert a new entry into our database to store that new data. And the same operations apply for the different CRUD methods. So if you want to read some data, right, we're going to send an HTTP GET to our backend. The backend is going to consult with our database to get the information. Once he gets that information, he can then send it back to our front end. Same thing applies for update. Same thing applies for delete. So this is how any full stack application is going to work. The front end just sends HTTP methods to the backend. The backend will then query the database to get some information or delete some information or insert some new information. Then once that's done, Postgres or our database will send information back to the our backend server, our Node and Express server, and then Express can then just send some information back to our client or React, and then React can update the UI so that the user gets some feedback on whether or not him creating a new restaurant or writing a new review was successful or not. All right, guys, so I think that's enough theory for now. I think it's time we got our hands a little bit dirty. We're going to start working on getting Postgres set up, installed, and working so that we can start building out our backend. In this video, I'm going to walk you through how to set up Postgres on a Windows machine. And the first thing that we have to do is download the installer, and that can be found on the Postgres website. So on Google, just search for Postgres. And the first search result should probably be the website we want. So that's going to be postgresql.org. And on this page, we want to select the download button right here, or you can select the download button at the top. And here we can see the different operating systems that it supports. And we want Windows. And then we want to select download the installer. And this is actually going to take us to a different page. So this is the Enterprise DB page. So this is where we can download the different packages to install Postgres. And you can see all the versions that they have available. At the moment, the latest is 12.3. However, if you're watching this video, you may see a higher version like 12.5 or 13. something. Just go ahead and download whatever is the latest for Windows. And so you can see here, Windows x86 64, 12.3 is available, so we'll download that. All right, so the installer will pop up and it's going to walk us through everything. So for the most part, we're just going to be hitting next over and over again. And so this is going to be the default directory installs. That's fine. And you'll see that we can actually download different components. So Postgres, the SQL server, we definitely want this. It also comes with a graphical user interface, which is pgadmin, which you may or may not want that, but I would just leave everything checked. We've got Stack Builder, and then we've got the command line tools, so we definitely want the command line tools. So for now, just leave everything checked and hit next. This is where it's going to store our data. That's fine. And then here, when we install Postgres, it's going to create a super user called Postgres. All right, very creative. And we have to set up a password for that default user that gets created. So make sure you pick a password that you can remember because we will need to use it later on. And we'll just keep hitting next. We can select the port the server should run on. So this is the default port that Postgres uses. And then just leave this as default. And so now it's going to install. It usually takes a little while, so it might take like 5-6 minutes. So I will touch base with you guys once that's done. All right, so Postgres finished installing. It's going to ask us if we want to launch Stack Builder once we close this. And we can just uncheck that because we don't want to open that for now. So we'll hit finished. We've got Postgres installed. However, we're not quite done. There's a couple more things that I want to do. And that's going to revolve around making use of a tool called PSQL, which is a command line tool for connecting to our database and interacting with it. And I want to walk you through how to use that real quick, as well as how to make a few changes to your machine so that we can use PSQL from the command line without having to actually select PSQL. All right, so let's go to your Windows, your start menu, and just scroll down and look for Postgres 12. And here you'll see all the different things that got installed, and we want to select PSQL. So this is a command line tool for connecting to your database. And with this tool, we can perform any operation on the database, like creating a separate databases within our Postgres instance. We can create tables, we can add entries and things like that. So that can all be done through PSQL. And so just select that. And what it's going to do is it's going to basically give you a few prompts so that you can enter in information about your database. And then it's going to connect to that database based off the information you provide. And so the first thing that we have to provide is the server, so the IP address or the domain name. So, you would normally put in like an IP address of like 192, or .168 or whatever, right? However, we're going to be running Postgres on our local machine. So we could just leave it as localhost, which is the default, as you can see. And that's the equivalent of doing like a 127.0.0.1, which just means we're going to connect to a Postgres instance that's running on our local machine. So we'll leave that as default, hit enter. It's then going to ask what's the name of the database that we want to connect to. And when Postgres installs, it's going to actually create a database called Postgres. So that's going to be like the default database. So we can connect to that. And so we can either hit enter and leave it as the default, or we can manually type out Postgres. However, in the future, once you actually create your own databases, you would actually enter in your own database name. And then it's going to ask for what port our server is running on. And if you remember in our install, we could specify what port we wanted to run on. The default's always 5432, so we can just leave that blank. Then it's going to ask for a username. And, going back to when we set up the installation process, we had to enter in a password for a super user called Postgres. So that's the user that Postgres created for us automatically. So we're going to connect to our database using that username for now, which is the super user. And then it's going to ask us for the password. So I told you guys to remember your password, and you can just enter it in here. And then at this point, PSQL should log into our Postgres server, and you should see a prompt that looks like this. And so this means that you are successfully logged into your Postgres server using PSQL. And at this point, we can start, making changes to our database. So that's how you use PSQL. So, just remember, you just go to the start menu, just look for Postgres, select PSQL, and then enter in the information, and then you can connect to your database. However, there's one more thing I want to do, and that is I want to make it so that you don't have to always go to the PSQL application to actually connect to it. I want to be able to actually do it through the command line. So if you open up just a standard command prompt, I want to be able to just type in PSQL, hit enter, and then do the same thing, which is connect to our database. And to do that, there's a couple of steps that we have to perform. So open up your File Explorer and go to your C drive. Oh, that's my OneDrive, your C drive. And what we want to do is look for program files, not program files x86, but just plain program files. And then you'll see that there's a folder called Postgres. And then there's going to be a folder with the version number that you've installed. So technically you can install multiple different versions of Postgres. And then we want to go into this folder called bin. Okay, and you'll see that there's a tool or a app called PSQL. And so that's basically what we were running right here. But what we want to do is we want to take this full path and add it into our path environment variable. And so that's going to allow us to run this PSQL command regardless of what directory we're in. So even from my home directory, I can just type in PSQL and it will call this file right here, or this application, and it'll start up PSQL for us. And so to do that, just search for env. And so you'll see an option for edit the system environment variables. And before we do that, just select at the top of this menu that's going to give you the full path to this file, and just copy that. And then here we want to select environment variables. And we want to go under system variables and just scroll down and look for something that says path. Select that and then hit edit. And then we want to select new and then just paste in that path we copied. Hit OK, hit OK, hit OK. And make sure that at this point you close out any command prompts that you had open. And now we want to go back to the command line. And to verify if everything works, just type in PSQL. And if you get a prompt asking you for a password, that means it worked. So at this point, it's basically trying to connect to our database using the user Sanjeev. It picked the user Sanjeev because that's the user of my machine. That's obviously not going to work because we don't have a user called Sanjeev on the Postgres database. But in the future videos, I will explain to you guys how to actually create a user and then how to actually specify what user you want to log in when you use the PSQL. But this video is just for the installation and setup process. So as long as you get this prompt, that means everything has been installed and you're good to go. To install Postgres on a Mac machine, what we need to do is first navigate to the Postgres website so we can download the installer. And so we can just go to google.com and just search for Postgres. And it should be the first result that we find. So this is the one, so postgresql.org. And here we can select this download button or this download button at the top. And you can see all of the installers that they have. So they've got one for Windows, one for Solaris, and then we want the one for Mac. And then here we can select download the installer. And it's going to take us to this Enterprise DB page. Don't worry, that's expected. And here you can see all of the different versions that we can download for each operating system. And so we're interested in Mac OS X. And you can see that the latest version it supports is 12.3. If you're watching this video in the future, you may see a newer version like 12.5 or 13.1. Just download the newest version. So here I'm just going to select download, hit allow, and it's going to download that file for us. And once it's complete, we can just select that and click on the .dmg file that it just downloaded. And you may or may not see this security warning. If you do see this security warning, just hit OK and go to your system preferences. It's kind of annoying. I don't know why Mac does this, but go to security and privacy. You're going to have to click on this lock icon to unlock it and enter in your password. And from here, you want to make sure this button's checked where it says App Store and Identified Developers, and it'll show you that Postgres was blocked from opening. So here you can just select Open Anyway, and then hit Open here. And that's going to allow us to actually use the installer. And we'll just double click on this and then hit Open and enter in our password again. Okay, and here we can just select Next. And this is going to set the installation directory, so we'll leave that as the default. And here we can actually select what components we want to install. So there's 4 components that we can choose from. First one is the Postgres SQL server. So this is the server itself, and that's really what we're trying to download. So make sure that's checked. The next item on this list is pgadmin. So this is a graphical user interface that we can use to manage our SQL servers. It's not required, but just go ahead and leave it installed. You don't know if you'll want to use it in the future or not. We've got Stack Builder and then finally the command line tools, which we'll be using. So definitely have that checked. I would just recommend leaving all 4 checked for now. This is going to be the directory where we actually store our data. So leave that as the default. And now Postgres, when it installs, it's going to install a kind of a default super user called Postgres. And it's going to ask us to input a password for that user. And make sure you remember this password because we will need to log in as that user when we first connect to our database. All right, in the next window, it's going to ask us what port we want the server to run on. So the default Postgres port is 5432. So leave that as the default. And then leave this as default locale. And then just keep hitting next. And now it's going to install Postgres. So this is going to take, I don't know, 5-6 minutes. It takes a little while. So I'm going to pause this video here and I'll touch base with you guys once that's done. All right, so it looks like Postgres finished installing, and it's going to ask us if we want to launch Stack Builder on exit. We don't, so we can just uncheck this box and hit finish. So we've got Postgres installed. However, there's a couple more things I want to set up, and that's going to be setting up a command line tool called PSQL. And this tool just allows us to connect to our database and run commands against the database and perform actions like creating tables, deleting tables, adding users, and things like that. So most of my videos I use PSQL because it's such a great and fantastic tool, and I want to make sure you guys have this set up so that you can use it as well. And to use PSQL, if you go to your Finder and just go to Applications and just search for PSQL, it should have gotten downloaded and installed for you when you installed Postgres. So if we select this, it's actually going to open our terminal for us. And you'll see that it has this prompt. So it's going to ask us, what server do we want to connect to? So we want to give the IP address of a Postgres server. And this server can, reside on, like the cloud, AWS. It can reside on another machine in the office, or it can run on your local machine. And we're going to be running Postgres on our local machine. So to connect to it, we can just leave it as a default as localhost. So just leave this blank. And so just hit enter. And so that means we're going to connect to our local machine because that's where our Postgres instance is going to be running on. Then it's going to ask us what database we want to connect to. And within Postgres, a Postgres instance, we can actually have multiple databases. And that's great because, if you're working on 5 or 6 different applications, you'll want each one of them to have their own independent database that can't, interact with any of the other databases. So each one can get their own individual database. When we install Postgres, it's going to install a default database called Postgres. And so to connect to Postgres, we actually have to specify a database we want to connect to. So we're going to connect to the default Postgres database. However, keep in mind, when we want to connect to a database in the future, we're probably going to connect directly to the database that's associated with an application we're working on. But we'll leave this blank so that we can use the default Postgres database. It's going to ask us what port we want to connect to. And so this is the default Postgres port. So just hit enter and leave that as default. Then it's going to ask for a username. And if you remember during the installation process, it did create a super user called Postgres. And that's the only user I believe that gets configured on it by default. So we have to use the Postgres user the first time we log in because there's no other users. So leave that as default and hit enter. Then it's going to ask us for the password. So hopefully you guys remember what password you used. And after that, you should see a prompt that looks like this where it says Postgres equals and then the pound symbol. And so if you see that, that means you're successfully connected to your Postgres database. And at this point, you can run various commands against your database. I just wanted to make sure you guys understood how to use the PSQL tool. Or in this video, I didn't really show you how to use it, but I showed you how to actually use it to connect to the database. And so in the following videos, when I go over how to perform certain actions, just remember to connect to your database. These are the exact steps that you want to perform. And we're almost done with this video. However, there's one more thing I want to cover. And that is, if you go to your terminal and just open up a new window, I want to make sure that you guys can, just type in PSQL and connect to a database using that method instead of having to go to this psql.sh file by searching for it. I think it's a little bit easier just to do it through the command line. So I want to make sure you have that option. And to do that, what we need to do is we first have to change to a directory called library. And then within here, if we do an ls, you'll see some of the applications we have installed, and you should have a folder called Postgres installed in there. So if we cd into that and then do an ls, you'll see that I have a folder called 12, and that's because I installed version 12. However, if you installed a version 13 or 11, you'll have a folder for each one of those versions. So navigate into whichever version that you want to use. So I only have one version, so I'm going to navigate into that. And then if we cd into bin and do an ls, you'll see that this is where the PSQL file exists. And so we want to make sure that we can access this file from any directory without having to navigate to this specific folder. And the way to do that is let's go to our home directory. So you can do that by doing cd and then the tilde. And I want to create a file. And the file is going to have basically one line that's going to exist in it. And the file that we use is going to vary depending on what version of Mac you're using. So starting in Catalina, I believe, we have to create a file called .zsh rc, I think. And if you're running on a version before Catalina, then you have to create a file called .bash_profile. But I'll walk you through how to do that. So just make sure you're in your home directory. So you'll see that little tilde. And what we want to do is we want to type in echo. And then we want to do a single quote. Make sure it's a single quote. And then type in export path, all capital, equals. And then quotation. And so this one needs to be a double quote. And we'll do $path, all capital, :/ library / Postgres. Right? It's just this directory that we navigated to. So we want to make sure we spell this with the proper capitalizations. And then from there, remember there's going to be a folder for each version that you have installed. So I'm using version 12. However, if you're using a different version, then make sure you put the proper version in. Then do /bin, then /, and then we want to close the double quotes and then close the single quote as well. All right, so this is kind of a long command, but that's what it's going to look like. And then now we have to pipe this to a file. And the file is going to exist in our home directory, so that tilde, then a /. And now, once again, guys, let me make this bigger for you. What you enter here is going to be different based off of what version you're running. So if you're running a Mac on Catalina or later, you want to do .zshrc, and then you can hit enter. If you're running on any version before Mac or before Catalina, then you have to do .bash_profile. Okay? So I'm running Catalina, so I'm going to do .zshrc, hit enter. And if you do an ls -la, that's going to show us all the files. And it should create that file that you just created. And if you're running on an older version, then you should see a file called bash_profile. And so here, now once we're done with that, we can close that out, close this out. And to just verify that it worked, let's open up a new window. And I want you to just type in PSQL --version. Okay, and if you see this, that means it worked, and you can see that we now have access to the PSQL tool from our command line, regardless of what folder we're in. So if you wanted to connect to a server, you can just do PSQL, and it's going to ask you for your password. It defaults to the username that's associated with your Mac, which we don't have a user on our Postgres database with that username. So, I mean, no matter what you put in, it's going to fail with an authentication failure. That's to be expected. But in the future videos, I'll show you guys how to set up, user. I'll show you guys how to then connect using PSQL with that new user so that it doesn't just default to this one. But anyways, that's all I wanted to cover in this video. You now have Postgres installed and set up, and you've got PSQL working. Just remember, if you ever need to connect to your Postgres database using PSQL, you have the option of going to this finder, searching for PSQL, and just running that, and then you can just enter in that information. Or you can do it through this method and just type in, PSQL-U with the name of the user. So we know that there's a user called Postgres, and then we can put in the password, and it should log us in. So either way works. Just make sure you remember how to do that. Now that we've got Postgres installed, I want to start introducing you guys to some of the more common SQL and PSQL commands. And before I do that, what I recommend that you do is pull up two different websites. The first website is going to be the Postgres Documentation. So if you don't know how to get to this page, just go to the homepage of Postgres and then go to Documentation, select Current, and then select the version of Postgres that you installed. So I picked version 12, so I'm going to select that. If you select version 13, then go ahead and select that. And so this is going to be all of the Postgres documentation. You should familiarize yourself with this page. You will be referring back to it frequently. The other website I recommend you open up is Postgres SQL tutorial. So this page has a lot of different posts on how to perform various actions within Postgres. So they go over how to query data, how to filter data. They go over SQL joins, grouping data. So they've got a ton of different posts on some of the common actions that you may perform on a Postgres database. I always refer back to this page. Generally, if I ever have a question, most likely there's a page on this website that explains how to do it. So also familiarize yourself with this page and always keep it open. You never know when you're going to need it. All right, so now let's connect back to our Postgres database and we'll start running our first commands. And so if you already forgot how to do that, just open up your PSQL application and it's going to give you the various prompts to connect to your local host database. So we're going to connect to our local host. So hit enter there. We're going to connect to the default database that got installed, which is the Postgres database. We're going to connect to the default port, and we're going to use the default username and then just type in the password that you defined for that user. And so now we're connected. And I'm not sure if I covered this already, but you'll notice that the prompt says Postgres. That's not because that's what the name of the database that we installed. That's actually the name of the database that we connected to. So when we typed in database Postgres right here and left it as default, it connects us to the database. And the prompt is always going to give us the name of the current database that we're connected to. However, we can have multiple databases running within this Postgres instance. So if we ever switch to a different database, you'll see that the prompt will change its name accordingly. All right, guys. So now with PSQL, every PSQL command is going to start off with a backslash. Okay. And the first two things I want to show you with PSQL is the question mark. So this is going to show you the different commands that you have available. And so, you can do backslash copyright to see information regarding the copyright. And, obviously there's more helpful commands and more useful commands, but these are all the commands that we have at our disposal. So if you want to connect to a specific database, then you use \C. And we can just keep tabbing through these just to see all of the commands that we have. And so anyways, that's just something I wanted to point out real quick. So if you ever can't remember a specific command, you can always type in \. However, I usually just Google it, right? It's just usually a lot quicker than, going through that list of things. But I have this text document right here. And what I'm going to do is every command that I type in, I'm going to save it in this text document just so that you guys can refer back to this a little bit later. And so I'm going to say, for help, you can do \. Okay, and so now I'm going to show you your first real PSQL command. And the command is \L. Okay, and what \L does is it's going to list out all of the databases that you have on your Postgres instance. And you'll see that I have 7 different databases. However, if you have a fresh Postgres install, you'll probably only have 2, maybe 3 databases installed. You'll definitely have the Postgres database because that's what you're connected to. And then you'll have template 0 and template 1. So these 3 databases get installed by default. The other databases that I have are just ones that I've created myself. You'll see that I have a Yelp practice. So this was just the database that's currently powering the application that we're going to build in this video. But now that we know how to list out a database, let's actually create a brand new database. Okay, so what we're going to do is to create a database, you type in the command create and then database. And then now I want you to type in the name of the database that you want. So let's just call this practice for now. Okay, and then so this is a SQL command and not a PSQL command. Every SQL command is going to end in a semicolon. So hit enter. And it should say create database if it's successful. If there was an error, it's going to print out the error. So now if we do a \L, we should see a database called practice, and we do. So let me quickly add this to our notes. So we've got to list databases, we've got \L, and then to create a database, we have create database, and then database _ name. Now you may have noticed that I typed in create and database in all caps. Technically, you don't need to do that. We can do it in lowercase as well. So if I do create database, and then I'll just call this practice 2, you'll see that it also creates the database. So you do not actually need to capitalize it, but you'll see that it's standard convention to type in the SQL portion of the commands in all caps. And that way, when you're looking at these commands, you know what part of the command is part of the SQL portion of the command and what part of the commands are like the name of the database that you want to define or whatever the user input is. And if you look at any of the documentation, right, they're going to do the same thing. So if we just select on any one of these, you'll see that they always capitalize the SQL portion of the command, just so you can differentiate between what you're inputting in and what are SQL commands. Technically, you don't have to, but it's good practice. And so now that we've created our database, we're still connected to the Postgres database. So let's actually find out how we can connect to our practice database. And so to connect to our database, if you remember from that \?, we actually saw how to do that. So if we just scroll down a bit, let's see, where did it go? Yeah, see, there's just so much output that this almost becomes unhelpful. Here we go. So \C is how you connect to a new database. And so let's give that a shot. So if we do \C and then the name of the database, which is called, what do we call it? Practice. Hit enter. It'll now say you are now connected to database practice as user Postgres. And notice how the prompt has changed to practice. Okay, and so that's how you connect to a different database. And now, since we have a new database, if I open up a new PSQL tab, we can actually connect directly to that database. So now when you input the different parameters, for localhost, we keep it the same. But for database, instead of leaving as a default database, we can type in practice. And then everything else, we'll leave it as default. And you'll see that now when it connects, it drops me straight into the practice database, so we don't have to do a /C and then change into it. Okay, so that's just something to keep in mind. If you feel more comfortable just connecting into the Postgres database than changing, you can do that. That's just fine as well. Okay, guys, let's take a quick pause from our PSQL command line. And I want to just touch on a little bit of theory before we proceed any further. And I promise this will be a fairly quick section. So within a database, we have something referred to as a table. And a table represents a subject or event within our application. So if we were building a typical, let's say we're building a e-commerce store, right? We would have a table that represents all of the users. We would have a table that could represent the products. And then we'd also have a table that represents purchases, right? So each table represents something in our application. Now, a table is made up of columns and rows, and each column represents a different attribute, and each row represents a different entry in the table. So in this example, we've got a users table, okay? And you can see that each column represents a different property of a user. So we've got the ID, so that's just something that we can identify that user as. We've got the name, we've got the age, and the sex as well. But obviously, in a real application, you'd have more fields, right? You might have one for email, you might have one for password. Anything that describes the user is going to have its own separate column. And then each row in our table is going to represent a different user. Okay, so this is the first row is going to be the user Vanessa, the second row is Carl, and the third row is George. So for every new user we add to our application, we're going to insert a new row. And anytime we want to add in a new property to describe a user, we create a new column. All right, so that's all I wanted to talk about with tables. Let's now jump back into the PSQL command line, and I'll show you guys how to actually start creating tables within our practice database. Now, to explain how to create a new table within our database, I'm actually going to navigate to the PostgreSQL page that I showed you guys earlier. And I want to actually just show you how to find the section on where to do that, because I think they do a good job of explaining it. So let's see, creating a table. Let's see if I can. So create table. So just go under managing tables and then select create table. And this is the syntax of how to create a table. I'm going to make this a little bit bigger for you guys. So we do create table, and then we give the table a name. So if we were creating a table for products or users, this is where we would apply it. And then here you define all of the different columns. So you can put in as many columns as you want, but you give the column a name, and then you give it a type. And so the type, well, to explain what the type is, Postgres has a lot of different data types that we can use for a column. And when I say data types, I mean, this is very similar to data types within a programming language, right? So Within JavaScript, right, you have integers, you have floats, you have strings, you have arrays, you have objects. These are all different data types, and Postgres supports a ton of different data types. So if you go to chapter 8 under data types, you'll see every single data type that Postgres supports. So we've got the numeric types. So there's going to be integers, floats, serials. We've got a data type to represent date and time. Super convenient. We've got one for Booleans, enumerated types. We've got geometric types. Network address types, you guys probably won't be using this, but as a network engineer, this is one of my favorite data types. And so yeah, just go ahead and just peek around the different data types that we have. It's important that when you actually model your data within the database, you pick the appropriate data type, because if you pick the wrong one, then changing this later on can be a little bit of a challenge. And so you definitely want to plan ahead and really find out what's the best data type for your application for each column. But going back to this page, so we specify the type, and then we have a whole bunch of constraints, which I'll explain a little bit later. But basically, we can add kind of extra rules to each column. Like we can say that this column must have a field or an entry, like we can't leave it blank. Or you can say that this column, has to be between the numbers of 1 and 5. So you get a lot of flexibility in the different constraints that you can add. But let's go ahead and create our first table. And what I'm going to do is I'm going to type it out in this text document first, because these commands can get a little bit long, and it's definitely going to make our life a little easier if you actually start writing it on a text file, so that you can just copy and paste it into here. And that way, if there's any typos or anything, you can just quickly update it and then copy and paste it again. Okay, and so let's create our first table, and I'm going to call this table product. So this is going to model various products within like an e-commerce store. So we do create table, and once again, you don't actually have to capitalize this part, but it's good practice. And we'll call this table products. Feel free to call it anything that you want. Then we do open parentheses. And we could separate it out into different lines. You don't actually have to put it all in one line, but it just makes it a little easier to read if you separate it out into different lines. SQL isn't going to throw an error if you do that. And remember, each SQL statement always ends in a semicolon. So let's define the different columns that we want. So you always want to have an ID column that's going to give that specific product a unique ID. So we can just do ID, and then we have to give it a type. So if we go back to the Postgres documentation, we can pick a specific type. So I'm just going to give it a type of integer. So we can give it an int type, and you can take a look at the documentation regarding that. But we have the option of small int, integer, and big int. So depending on the size that you want. So I'm just going to do int. Once again, doesn't need to be capitalized, but I'm going to capitalize it. And then you can do a comma. So this is going to be our first column. Then we put in the second column. So the second column, let's say, is going to be the name of the product. And we have to pick a specific data type that we want. And so we want a string, right? So let's see if I can find string types. And that's actually not what I wanted. Instead, we actually want character type. So to store a string within Postgres, we have a couple of different options. We've got character, we've got varying varchar, character char again, as well as text. So what I'm going to do is I'm going to use varchar. So this is a string, and we can specify what's the maximum number of characters that we're going to allow. So a name for a product shouldn't have, it shouldn't be like 500 characters long. It's not like a blog post or anything. So something like 50 characters is okay. If you don't want to set a limit, you can always just do a type of text, which is this data type right here. But I'm going to use varchar for my strings. So we'll do varchar, and then I'm just going to set a limit of 50. And then let's give it a price. So we can always give it a price. And for that data type, I think Postgres actually has monetary types, so we can actually use specific types, but that's a little complicated. So I'm just going to represent it with a integer as well. So I'm just going to call this int just to keep things simple for now, because this is just an example. And then we'll have one called featured. So if this is a featured product, this is just going to be a Boolean, whether it's true or not. Or actually, let's change this to on sale. So is this product on sale? And we're going to represent this as a Boolean. So let's see if there's a Boolean type. There should be. And so you just give it a name of Boolean. So we can just do Boolean. Okay, and so this is it, right? This is what we're going to define our table products. And so we can just copy this. And we can go back to our command line and just paste that in. Didn't look like it copied. Okay, and if I hit enter, it should then say create table. Okay, and so now how do we verify if that table actually got created? Well, to list out all of the tables within our database, we can do / and then D. Okay, so /D is going to list all the tables. So we've got one table, and the table's name is products. Okay, and let me add this to the documentation. So list all tables, going to be /D. Now, if we actually want to see the structure of that table, to see all the different columns that we've defined, we can do /D and then just pass in the name of the table we want to see information about. So we'll do products. Okay, and this is the actual table. So you can see we've got the ID field, that's an integer. We've got the name, which is a varying char with a max of 50 characters. We've got the price, which is an integer as well. And then we've got the on sale property, which is a Boolean. Now, later down on the road, we may want to modify this table. We may want to add a few columns or maybe delete a few columns. And we can do that within Postgres. And to do that, what I recommend that you do is always pull up this documentation page. And what you want to do is you want to scroll down to managing tables. And so you'll see that there's a section to add column and drop column. So adding a column is fairly simple. You just do alter table, table name, and then add column, then the name of the new column, as well as the new data type. So we can do that. And I'm going to do alter table. And the table we want to modify is the products table. That's the only table that we have in this database at the moment. And then we want to add column. And the name of the new column is going to be, we'll call this featured. And the data type is going to be a Boolean as well. Oops, ignore that. I just had a previous command in there. Okay, so now that I ran that again, we can see it says altered table, which means that the command was successful. I can do a /D and then products. And so we can verify that the changes actually took effect. And so there you go. And so now we've added a column. We can also delete it. So going back to the documentation, let's go to drop column. And we can just do alter table, table name, then drop column, and then column name. So alter table. And this is going to come from the products table. And then we do drop column. And we want to drop featured. Okay. And so if we do /D products again, we should see that it's now removed. All right, guys, we have now successfully created a table. We've been able to add a column to it as well as delete it. The next thing I want to show you guys is how to actually drop a table. And once again, we're going to take a look at the documentation. So managing tables. So there should be a drop table. And so all you have to do is just drop table and then the name of the table. So we can do drop table. Whoops, let's actually capitalize that just for best practices. So we'll do drop table and then products. Okay, and it said it dropped the table. And so now if we do a /D, it says that it could not find any relations, which means that we don't have any more tables in our database. So I think that's enough playing around with this practice database. Let's go ahead and actually delete this database and let's create a new database for our Yelp app. So to delete our database, this isn't something you're going to do frequently. Obviously, in a production environment, you won't be deleting many databases, but since we're just playing around and just using this for learning purposes, then let's just go ahead and delete it. We can do drop database. And if you don't know where I'm getting this command, always just come back to either this page or the Postgres documentation. And under the managing databases, we can go to drop database. And the command is really simple. It's just drop database and then the name of the database. So we want to drop our practice database. So if I do practice and then end it with a semicolon, you'll see that we actually get an error. And that's because it's basically saying that it says, look, you're connected to the practice database. We can't delete this database while you're connected to it. So what we have to do is we have to switch to a different database and then drop it from there. So if we do a /L, let's take a look at all of our other databases and let's just connect back to our Postgres database. And so if you already forgot how to do that, just do /C and then Postgres. So now we're connected to our Postgres database. And so now we can do drop database. Okay, and so now it dropped the database. If we do a /L again, we should see that the practice database is gone. I still have practice 2, so I'm going to delete that as well. All right, so we've cleaned up all of the unnecessary databases we've created now. Now let's go ahead and get started on creating the database for our application. So the first thing that we want to do is actually create a new database. So we can do that with create, well, I'm going to capitalize that, create database. And the name of the database, so I'm just going to call this Yelp. And we can just verify it got created by doing a \L. So we now got the Yelp database. And let's change into that database now so that we can start creating some tables. And let's think about what are the tables that we would need for our application. So in our application, right, since it's a restaurant finder, I think it makes sense to have a table for restaurants. And another table that we'll need is also one for reviews. However, we're going to handle implementing all of the review logic at the second half of this course. I want to focus on keeping things simple at first without confusing you guys. So we're just going to create one table for now, and that's going to be the restaurants table. And let's try to figure out what are the different columns we need for the restaurant table. And so clearly, I mean, if you look at the data that we have for a specific restaurant, we're going to have a name. So it makes sense to have a name column that's going to be a varchar probably. We're going to want to have a location. So that'll also be a varchar. Then we have a price range. So we can reference or represent the price range as an integer. And I guess I forget what the maximum number of $ Yelp has. It may be 4 or 5. We'll go to 5. So it'll need to have a range of 1 to 5. And, like I said, we're going to implement ratings later on. Let's take a look at the detail page to see if there's any other information. And it doesn't look like it. So I think for now, we should be able to get away with just these 3 columns. Technically 4, and I'll explain what that 4th column is. So let's get started on creating our database. I'm going to type it out on this text document right here. So we're going to do create table, and then we'll call this restaurants. Hopefully I'm spelling that correctly. And the first table is going to be an ID. So we always want to give each entry in our database or our table a unique ID. So we'll do ID, and for now we'll keep it as int. I'll explain in a second why it's actually bad to do it like this. So we do ID int. Then we want to give it a name. So this is going to be a varchar. And then I'm just going to pick 50 characters as the limit once again. Seems to make sense. Price. Not price. Location. This is also going to be a varchar of 50. And then finally, we have price range. And this is going to be an int as well. All right, so let's create that. Paste that in there, and we should have our new table. And so we've got our restaurants table, and let's take a look at it in detail. And there you go. So we've got our table for our application. And now let's actually just go ahead and add some test data into this table. Okay, and so to actually create an entry into our database, let's actually go back to the documentation and take a look at it there. I always want to keep going back here as much as possible. I know it's kind of annoying, but I want to make sure you guys understand where to look. And so we go back to this and then just look for, I think, let's just do a search for insert. This is going to show us how to actually insert data. And it's a little unusual. It kind of confused me at first, but the way you insert data is you do insert into, then the table name, and then you do in parentheses the different columns that you're going to insert data into. So technically, we don't have to actually fill in all of these fields. We can just pick a certain subset. And then you do values, and then in these parentheses, you provide the values for each column. So the first entry will map to column 1. The second entry will map to column 2, and then the third entry will map to the third column. So let's actually figure out how we can do that. So we're going to do insert into, and then we want to insert this into the restaurants table. And let's fill in, let's say we want to pass in a value to each one of the columns. So we're going to do ID. And we'll do name, location, and price range. And the values we're going to assign to it, we can now pass in the values. So the ID, let's just give it some random number for the ID. So I'll just do 123. Then we have to give it a name. So we'll call this one McDonald's. The location, this will be in New York. And these need to be strings, by the way. And then we have the price range. Oops. Value the price range, we could just pick some number, so 3. Okay, so let's copy this. Let's paste it into our terminal and see if this works. Okay, and if you see insert 01, that means it successfully inserted, an object into the column, into the table. So we can do, actually now we have to figure out how we can actually view all of the data in our tables. So to actually view the data within a table, we can do select star from, and then the name of the table, restaurants. And I'll explain what this command does, or what each aspect of this command actually does. So if we just do that for now, all right. And so you can see that this is our entry in there, and you can see all the values that we passed in. So 1, 2, 3, McDonald's, New York, and 3 as well. So we have successfully inserted a row into our table, and we can do this again. So now if we change up some of the values, let's just increment this by 1. Let's change this to, let's say, I don't know, Pizza Hut. And then the city, this can be Vegas or something. And we'll say the price range is a 2. Okay, so now if we do that same command, select star from restaurants, you can see that we now have 2 entries. So let me explain what this command, or how this command works. So this asterisk right here is probably what confuses you, because it kind of makes sense to select from and then the name of the table that you want to list from. The star implies what columns that you want to see data for. So when you do an asterisk, it means that you want to see every single column. And you can see in the output that we actually do get every single column. But let's say, we don't actually care about most of these columns, because in a real world application, you could have, 20, 30 columns. You may not want to see all of those columns in the output. You may just want to see the name and the price range. So if we did select and then passed in just name, comma, price range, and any other table that we wanted to see, we could just do that and then do from restaurants. Right? And so it's the same output as before, except now it just prints out the 2 columns that we have requested here. So that's how the select command works. It's pretty simple. Most of the time, just for this project, we're probably just going to do a select star from restaurants, because we only have fields that we always want to see. So you'll see me do that, but keep in mind that you can always just print out the columns that you're interested in. So there's a couple of issues with the way we set up the table, and I can easily give you an example of some of the mistakes that we made. So as an example, I'm going to insert a new row into our table, and I'm going to do insert, like we normally do, into restaurants. And then here, I'm not going to give it an ID or a name or a location. I'm just going to give it a price range. And then here we can just pass in the values for the price range, which will be a 3. Actually, I'm going to make this a 12. And then print that out. So it inserted it into our database. And if we do a select star from restaurants, let's print that out. Now, I want you to tell me, what is the issue with this entry, right? This is a useless entry, right? All it has is a price range. It doesn't have an ID. It doesn't have a name. It doesn't have a location. This is a useless entry. I don't even know what we would do with this within our application, right? And so Postgres gives us a option to make sure that certain columns always have data passed in when we create a new entry, right? And so obviously it makes sense that when we create a new entry, that entry has to have a name. Without a name, it's useless. And, location, I think with an application like ours, I think we would want to make location required. Price range, we probably want that required, but, that one we could leave as not required. And then ID, you shouldn't ever set up a database where you actually have to pass in the ID. Instead, what you want to do is you want the database to automatically give each new entry its own its own ID. So those are the two main issues that I see, and let's go ahead and actually fix those now. So what we're going to do is we're going to drop the current table that we have because it's just all wrong, and we'll do drop table. And let's go back to this command right here to create the table, and I'm going to show you how we're going to fix this. So the first issue is the ID, right? We want Postgres to give the new entry a ID automatically that's going to be unique for each entry. And we can do that fairly easily by passing in the type as big serial. So there's a type called big serial. And what this is going to do is that it's basically, it's an integer, or it's a big int technically, but each time we create a new entry, it's going to increment it by 1. So the first entry we enter into the database, it's going to have an ID of 1. The second entry will have an ID of 2, and the third entry will have an ID of 3. So it's automatically going to increment it for us, and it's going to ensure that each entry into our database gets a unique ID, and we don't actually have to pass it in as a field. Then the second thing that we want to do is we want to add in a constraint. So this is going to be the first constraint that I'm going to teach you guys, and it's called not null. What this means is that we cannot have a blank ID. So the ID always has to be set no matter what. And this not null constraint is going to get passed to all of the 3 other properties because we always want to have those have a value. It just doesn't make sense to have any of those columns be empty for any of our entries. So we'll do not null. It's going to ensure that none of these can have a null entry within the table. And we'll do not null. And not null here as well. All right, so let's copy this. Let's paste that in there. And now let's create a few entries. So we'll do insert into, and we want to insert into restaurants. And we're going to pass in, we no longer have to pass in the ID because Postgres is going to handle that. We just need to pass in name and location and price range. And the values, we could just pick some arbitrary values. So we'll do Wendy's again. And we'll do Denver, the city. Price range will be 3. Okay, so let's do that. Okay, and so now if I do a select star from restaurants, we should see it got added. All right, and we do see it got added. And notice how it gave it an ID of 1. Okay, and if I just run that same command just to put in a new entry, you'll see that it gave it a 2. So it's just going to keep incrementing it for us so that we don't ever have to pass in the ID. And it's going to ensure that each entry has a unique ID. And that's just because we chose to use big serial and not integer. Now, let's see if the constraints that we passed in, the not null constraints, actually work. So I'm going to remove the name. And we can verify if this allows us to actually input something into our database. And so you can see that now Postgres throws an error. It says null value in column name, and it violates the not null constraint. So this is just basically telling us you need to have a name, or I'm not going to allow you to, insert a row into our table. So we can add that back. And this time I'm going to remove the location. And this is going to get updated back to the name. So now we're just passing in the name and the price range. So if I hit enter, we should see the same exact error, except now it's saying that the column location violates the not null constraint. So our not null constraint is working. However, there's still one more issue. If I try to, let me go back to the one where I have all 3 values. So this should work. However, if I change this to a 7, it still adds it into the database. Right? And there's no need for us to ever have a 7 under the price range. That just doesn't make sense for our application. It only goes up to 5. So what we need to do is we need to add a extra constraint to the price range. So let's go ahead and drop the table. And by the way, guys, if you want to make a change to a column, we can do that with a specific command, but I want to just keep things simple. So we're just going to drop the table and just recreate it with the proper constraint. All right, now that we've dropped the table, let's add a constraint to the price range. So we already have one constraint, which is the not null, which makes it required. But now we want to make sure the price range is between the values of 1 and 5. And this is actually really easy to do. You just type in check, and then you say price underscore range needs to be greater than or equal to. That is not the greater than sign. So greater than equal to 1, and price underscore range needs to be less than or equal to 5. So this is going to ensure that the price range is always between 1 and 5. And I don't know what just happened there. So let me reopen up PSQL. Okay, and so now we've created the table, and looks like the text is small again. Let me make that bigger for you guys. And so now if we do a /d and then restaurants, you'll notice that you actually see a lot of extra information. So under nullable, you'll see that these are all not null, which means that they're required. Then you've got this next val. So I guess this is just part of us using the big serial. So this is how it kind of handles the logic of automatically incrementing it. But you'll also see the check constraints. So we added a constraint saying that the price range has to be greater than or equal to 1 and less than or equal to 5. And so now if I go back up to my previous command where we inserted, it looks like I've lost it. So we'll do it again. So now we want to insert into restaurants, and we're going to pass in the name, the location, and the price range. And then the values, they're going to be set to, let's just do Wendy's again. Location, this can be Miami. And now if I try to pass in a price range of 7, this should ideally throw an error. And it did. So it says new row for relation restaurants violates check constraint. So it says that, this did not meet the constraint or this specific constraint. So if we run that same command again, but this time pass in a value of, let's say, 4, it should get inserted. So that just verifies that our constraint works. So it looks like our table is almost done. However, once again, there's one more thing missing. And that's that each table has what's referred to, each table has what's referred to as a primary key. And a primary key is just a way for us to uniquely identify a entry within the table. So in our case, we want the primary key to be the ID. So the ID is what's going to uniquely identify our product. Oh, sorry, not our product. I'm looking at our restaurants. But the ID is supposed to represent a unique restaurant. But it doesn't necessarily have to be the ID column that we specify as the primary key. If we're building an application that, let's say like a loan or a healthcare application where we have the user's social security number, we could use the social security number as a primary key because we know that's always going to be unique. No two users can have the same social security number. Or email, we could technically use email as a primary key because we know that two users can't have the same exact email. So you could choose any field or any column to be the primary key, but generally, we usually just keep it as the ID as the primary key, and I think that makes sense for our application. So to tell Postgres to make ID as our primary key, all we have to do is just type in primary key. So let's drop our table again. And paste this in. Okay, so it created our table. Interesting thing though, if you do a /d, you'll notice that we actually have 2 entries now. So we've got restaurant as well as this restaurant's ID sequence. That's just because we did the big serial. So it creates this extra table, but you can just ignore that for now. Just know that we just have one real table. And if we do a /d now on restaurants, we should see that there's actually a couple of things that got added. Actually, just one thing, and that's this restaurants key. So when you add a primary key, Postgres actually creates an index on that primary key. I don't actually want to explain what that is now because that's a little bit outside of the scope of what I want to cover in this course. It's a little bit more complex, one of the more complex topics within Postgres. So for now, just know that whenever you add a primary key, It technically does cause Postgres to create an index, but the only thing that you need to focus on is that the primary key is just a way to uniquely identify an entry within our database. Now that we've got our Postgres database set up, it's time to move on to our backend server. So we're going to be using Node and Express to build out a RESTful API. And the first thing that we need to do is install Node.js. So if you don't already have Node installed, just navigate to this link right up here and select the latest features button. So it's going to automatically detect what operating system you're on. So as long as you select the latest features one, you may see a newer version, but that's okay. Just go ahead and select that and just run through the installer. Just keep hitting next, leave everything as default, and Node should install properly. And once you've got Node installed, we want to find a directory to house all of our code. So I'm just going to make a new folder. And you can do this in My Documents. You can do this in My Downloads. It doesn't matter where you do it. Just pick some folder where you like to store your code. I'm going to call this project Yelp. And once you create that folder, what you want to do is I'm going to open that folder up in my text editor. So I like to use VS Code. If you want to use another one like Atom, feel free to do that. So here we can then just open up that folder. Now within this folder, the way that we're going to actually structure our project is that we're going to have two different directories. We're going to have one for the client-side code, so all of the React code, and then we're going to have one for the server-side code, which is for Node and Express. So I'm going to create two different directories. One's going to be called client, and the other one's going to be called server. Now we need to open up our terminal and navigate to this server directory. So you can either go to your usual terminal, whether you're on Windows or Mac, or if you're using VS Code, we can use the integrated terminal. So we'll just do new terminal. And what's nice about this is it drops us right into our Yelp folder. So now we can cd into server, and make sure you go into server and not client. And we want to do npm init-y. And after you do that, you should see a package.json file. And if you see that, then everything's good to go. And we want to install Express now. So we can do npm install Express. And if you look at the dependencies inside the package.json file, you should now see Express and then whatever version of Express it downloaded. So when you do npm install Express, it's going to download the latest version. So once again, you may see a different version, but that's okay. Now, when we did npm install Express, it did a couple of things. It also created a package-lock.json as well as the node modules folder. So this is the actual, these are all of the node modules that got installed when we did an npm install Express. So this is all the code for Express as well as all the dependencies for Express as well. Now that we've got Express installed, let's go ahead and create our server.js file. And the server.js file is an important file because it's going to be the entry point into our backend application. So this is going to be responsible for creating and initializing our Express app and actually starting it up and listening it on some port that we define. And so the first thing that we need to do here is that we actually want to import the Express app. So we'll do const express equals require, and then we're going to require Express. And now we need to create an instance of our Express app. And that's pretty easy to do. All we do is const app equals Express. So we created an instance of an Express app when we stored it in a variable called app. And now we can tell our Express app to listen on a specific port. And so we can do that by doing app.listen and then specifying what port we want to listen to. So usually in most of the tutorials, they do port 3000. So you can just do port 3000. I think right now I have my React app listening on port 3000. So I'm just going to pick a different value, but feel free to pick any value. It doesn't really matter. So I'm going to do 3005. Okay. And the second thing that you have to pass into app.listen is a callback function. So once our Express server actually starts up, what do you want it to do? Well, we're just going to console.log, server is up and listening on port 3005. Okay, let's save that and let's actually start our application. So if I do a node, and make sure you're in the server folder because that's where this file is, we can just do node and then server.js. And you'll see that once we run that command, it'll print out that console.log. So it's going to say we're up and listening on port 3005. And you'll see that the console kind of, or sorry, not the console, the terminal kind of hangs, right? We can't actually enter in any commands. So that's normal, and that's because the Express server is actively up and running and listening, so we can't actually enter in commands while this is happening. Although, if you do need to enter in other commands, you can always just open a new terminal, and so now we can start typing in, whatever commands we want to. But to actually stop our web server, you can just do a Control-C, and that's going to stop it. And I want to make a quick modification. So instead of hard coding this value, I'd rather store it as a variable. I'm going to call that variable port. I'm going to define that variable right above it. So we'll say const port equals 3005. I'm going to change this to a template string. And we'll just pass in the value of port so that we can see what port we're listening on. All right, and so now if we do a node server.js, it should once again say servers up and listening on port 3005, but now we're no longer hard coding the value and we're storing it as a value of port. Now, before moving on, there's one last change I want to make, and that is that I want to actually use environment variables in our application. So it's not necessarily good to even just hard code this as 3005 because when you're in your development environment, you may be using port 3005, but in your production environment, you may use a different port number. So it's always good to use environment variables so that you can automatically get those port values updated accordingly. And so there's a package that's really helpful for managing environment variables. And that package is called .env. And so we're going to install this .env package. It's really easy. All we have to do is npm install .env. So I'm going to stop our web server. We're going to do npm install .env. And we have to import it. So importing it, you just copy this line right here. And I'm going to put this at the top of our application because we want to import this before we do anything else. And within our server directory, we want to create a new file. And this is going to be the file that's going to store all of our environment variables. And we'll call this .env. So don't forget the dot. And so here we can define all of our environment variables. So I'm going to create one called port. And it's standard convention to name your variables with all uppercase letters. So I'm going to call this port. And I'm going to set this to some value. What port do I want my Express server to listen on? Let's say 4000, just to make it something different. And then here, what we can do is when we define port, we can say that instead of saving it as 3005, we can say that port equals process.env.port. So what this means is that, actually, I forgot to capitalize port. Okay, and so we're storing the value of port to the environment variable that we define here. So now if I save this and do a node server.js, it looks like it's saying that it's undefined. So something happened, but most likely it's just because I forgot to hit save all. So now if I do a node, once again, another error. It looks like I'm already using port 4000 in my on my computer, so we're going to have to change that. I'm going to change this to 3006. Not a big deal. So now if I do node server.js, we are listening on port 3006. But we can go one step further and we can say that if for some reason we don't pass an environment variable, we're going to give it a default value for port. And the way to do that is by doing 2 vertical bars and then just saying, I want this to run on port 3001. Okay, so now if I save this, if I run this again, you'll see that we're listening on port 3006, and that's because our environment variable called port is defined here. However, if I delete this and save that, close out my server, and now run this, it now says that it is listening on port 3001. So all this command is doing is it's saying that if this environment variable is defined, we're going to set port to that value. However, if it's not defined, we're going to set port to 3001. Now that we've finished the basic Express server configuration, we need to start building out our API. And we're going to start writing out our first couple of routes. And in Express, we're going to have a route for each one of the common CRUD tasks. So we're going to have one for creating a restaurant. We're going to have one for retrieving a restaurant, as well as retrieving all restaurants. We're going to have one for updating and one for deleting. And to define a route in Express, the first thing that we have to do is reference our Express instance. And our Express instance is stored within the app variable. So we do app, all right, and then we have to specify the HTTP method this route is going to handle. So we can do get, we can do post, we can do patch, we can do put. So we've got a lot of options. I'm going to just focus on the get method for now. So this is going to be, this route's going to be used for retrieving either a restaurant, an individual restaurant, or a list of restaurants. And then there's two parameters that we have to pass in. The first is the URL. And so the URL is the URL that the front end is going to send a HTTP request to. And we can call this whatever we want. You can choose to lay out the URL however you want. So we could technically call this, let's say, get restaurants. Now, this is technically a bad naming convention, and I'll explain that in a bit. But right now, I just want to explain how to set up routes in Express. So this is going to be our URL. And if you don't really understand what this URL is doing, basically, we know that our server is running on localhost, which is kind of like our IP address in this scenario. However, when we deploy it, it's actually going to get deployed to a specific IP with a domain name. But the front end, when they want to send an HTTP request to this route, they would go to HTTP or HTTPS if we have that set up, / localhost, and then the port our server is running on. So we know our port is 3001. So we'll do port 3001. And then the route here is / and then get restaurants. Okay, so anytime we get a get method towards this exact URL, it's going to hit this route. Okay, and so the URL is the first parameter. The second input argument is going to be a callback function. And this callback function gets two parameters. It gets the request and the response. So when we actually receive that HTTP request, it's going to be stored within this request variable. And then the response we send back will be stored in the response variable. And so this is just going to be a plain old arrow function. And for now, we'll just do a console.log. And we'll just say retrieve, or how about get all restaurants. We'll hit save. And, one thing to point out is after we make a change, what we'll have to do is we'll have to stop our server and then we'll have to start it again. And you'll see that that's kind of annoying. That every time we change something, we're going to have to stop and start our server. However, there is a package that automatically does that for us where it'll detect a change in our files and it'll automatically restart our server. And that package is actually called nodemon. So to set that up, just do an npm install nodemon. And once that's done, if you check your package.json, you should now see that nodemon is a dependency. And what we need to do is within the package.json, we're going to create a script. So right now there's just one script. It's a test script, and we can remove that. And I'm going to call this start. So this is going to be the start script. And we're going to specify the command that needs to run for our start script. And what we need to do is we type in the word nodemon and then the file. So server.js. So this is kind of the equivalent of doing a node and then server.js, except instead of just doing it with plain node, we're doing it with the nodemon package, which will automatically restart our application every time we make a change to one of the JavaScript files. So let's do a save all. And now what we want to do is npm start. So instead of doing a node server.js, we're going to do an npm start. And so this is just a script that we just defined, which is this start script right here. And it's just going to run this. So it is the equivalent of doing a nodemon server.js. So let's do npm start. And it's going to start our server. And you'll see that there's a few extra outputs from nodemon. But let's just test to see if that actually worked. So I'm just going to do, just add any line, any extra line of code. So I'll just do a console.log test or something. And then when you hit save, notice how nodemon restarted. And we can even see the output of console.log. So this is just there to make our lives a little bit easier so that we don't have to keep stopping and starting our server. It's going to automatically handle that. But going back to the route that we set up, let's actually test this route to see if it worked. And we can test this fairly easily by going into our web browser and just navigating to that URL that we defined. So remember, it's going to be at localhost port 3001, or if you're choosing to use a different port, then make sure that you use that correct port. And then we're going to have this at get restaurants. And then let's hit enter. And you can see that now it says get all restaurants. So when we send that get method, it hit this route, and then we printed out this console.log statement. However, not very practical. We actually want to send a response back to the web browser so that they get a little feedback that they actually were able to access that URL. So we can change this. And like I said before, this callback function has access to the response object. So we can do a res and then .send, and we can send back something. So I can say, these are the restaurants. And so now, when you do a refresh, we get that message back saying these are the restaurants. However, we're just sending back text, and I don't like that. That's actually what we're not going to be doing for a API. An API normally sends data back in a JSON format. And so with Express, we can actually change this send argument to a JSON. So res.json, and we can pass in a JSON object. And so here, you can put in whatever data you want. So let's say we're going to have a status of success, and then how about a restaurant field that's going to include a name of a restaurant. So we'll call this McDonald's. So now if we go to that, you can see that the response now comes back in a JSON format. And that way, once we actually build our React client, the React client will receive it in a JSON format so that he can easily parse the data. Now, using this web browser to actually test our API is not very practical because we can send get methods. However, sending like a post or a put or a patch method just with a plain old web browser is not going to be very practical. And we haven't actually built out our front end to actually test out our API. So what I recommend that you do is install a application called Postman. And so this is a tool that's used to test out APIs, and it's great for development purposes, especially when your front end hasn't been complete or you plan to start working on your front end after the back end is done. And it basically allows us to construct any HTTP packet that we want. So, we have access to various methods. So we've got all the HTTP methods. We can do a get, post, put, patch, all of them. And we can specify the URL. We have the options of passing in a body. So if we're posting data back to our backend server, then we can add some extra data. We can set up headers. We can set up authorization. So there's a lot of flexibility. You can really construct any HTTP packet that you want using this tool. So if you don't already have that, just Google Postman. It's a free application, and just download it. So you should be able to download it. I believe it's probably available for pretty much all platforms. So whether you're on a Mac or Windows, you should be fine. And so once you get Postman installed, let's just quickly do a test and just open up a new request. And so we're going to define a new request from scratch. And first we have to specify our HTTP method, and we're going to do a get method because we only have a route for a get method at this point. And we're going to send it to that same exact URL we pointed our web browser to. So localhost :3001 / get restaurants. And so now if we do a send, look at that. We got our JSON response back with the static success and restaurant McDonald's. And notice how the status is a 200. And so Express by default is going to send a status code of 200. However, we have the option of changing the status code. And we can just change that onto the response object. So we can say res.status and then just pick whatever status code you want. So if you wanted to send a 404, and then just make sure you do a dot after that, we'll save it. And then let's send another request. And now you'll see that we got the same response, except our status code is a 404. And so that's how you change these status codes within a response in Express. Now, before we proceed any further, I want to walk you guys through how we're going to set up all of the routes for our various CRUD operations in our application. And so what we've got here is a table that's going to show you what all of the different CRUD operations are and the different HTTP methods that are associated with them, as well as the URLs for those routes. And so if we want to retrieve all of the restaurants from our API, we're going to send a get method to /API/v1/restaurants. Now I chose this naming convention because I think it's nice that whenever you're setting up an API, to append the word API into the URL so you know that this URL or route is for an API in your application. The v1 is just to signify that this is the first version of our API. It's nice to provide a versioning number within the URL so that, if you decide to make, potentially breaking changes to your API, you can have all of your applications or customers that are still using the version 1 of your API still use those version 1 endpoints, and then you can have a separate version 2 endpoints running simultaneously. So it's better to do it like this. However, once again, it's up to you guys. If you guys prefer not to do that, then you don't have to, but it does give you some extra flexibility if you do plan to make changes down the road. Now, if we want to retrieve an individual restaurant, we're once again going to send a get method. However, the URL that we send to is going to be /API/v1/restaurants, and then this :ID. So this references kind of like a variable. So this whatever comes after this / is going to be the ID of the specific restaurant we want to retrieve information for. So think of this as just a variable. It's called a parameter, a URL parameter, but that ID can technically be any value as long as it's an ID of one of the restaurants we have in our database. For our create operation, so when we want to add a new restaurant into our database, we're going to send a post method, and we're going to send it to /API/v1/restaurants. For updating, we're going to do a put. Technically, we could have done a patch, but I'm going to be using a put operation in this application. And we're going to send it to /API/v1/restaurants. And then we have that same :ID that we had for retrieving an individual restaurant. So if we want to update a restaurant, we need to tell our backend, what restaurant do we want to update. So in the URL, we're going to append the ID of the restaurant we want to update. And then lastly, we've got the delete operation. So when we want to delete a restaurant from the database, we're going to send a delete method, and we're going to send it to /API/v1/restaurants. And then once again, we're going to have that :ID so that we can tell our backend which restaurant we want to delete. All right, so hopefully this made sense. I think this is a little bit nicer structure than having, /get restaurants or /delete restaurants or /update restaurants. We don't have to have all of those individual names because all of these require different HTTP methods so that we can just always use these /restaurants for almost all of them. So now that we have a good understanding of how we want to define our routes, let's set up the skeleton for all 5 routes, and then we'll worry about implementing the actual logic for that in a couple of videos down the road. So let's, we've got this get method already, so we'll keep that, and then this will represent get all restaurants. And if you recall the URL that we want to go to for that, that's going to be /API/v1/restaurants. And then this is just going to return a list of restaurants. So we'll just hard code some values. McDonald's, maybe Wendy's, and so on. And this is going to be a status code of 200. And in fact, what I actually want to do is I want to tweak this a little bit. Instead of just storing it under restaurants, let's store it under a data field. I think this is just a nicer way to to structure our response back to the front end. So the front end knows to always look for the field in the payload that's called data, and then it's going to know where all of the data is going to be stored. So then here, I can take this and just move that up to here. So I think that's a nicer way to structure that. Let's quickly test this out. I'm going to delete all these old ones. And guys, what I recommend that you do is actually create a collection so that you can save all of your different requests. So we'll make a new one. I'm just going to call this Yelp. And I can just delete this for now. And under Yelp, we can just click on this and click add request. And let's give this a name. So we'll say get all restaurants. And then we'll do save to Yelp. And so we've got this method right here. And let's define our URL. So that's going to go to http://localhost 3001/API/v1/restaurants. Okay, and we can save this. And now let's try. And there we go. So we got a response back, and you can see we got a status of success. And within the data property, we've got restaurants and then the list of restaurants. And the status code is a 200. Okay, so we've got get all restaurants done. Now let's tackle getting an individual restaurant. And so once again, this is going to be a get method. And the URL is going to be API/v1/restaurants. And we have to do the same thing. So we have to do :ID here. So this is telling Express that there's going to be some value that gets appended at the end of this URL. And we don't obviously know what the ID is going to be ahead of time, and we need to be able to support the IDs for all of our restaurants. So we can't hard code a value. So we're just saying to Express by doing : and then ID, we're telling it it's a variable and it can represent any value. And then finally, we'll do our this is what's called this callback function is actually referred to as a route handler. So for our route handler, once again, we get the access to our request object as well as our response object. And what I want to do here is I want to do a console.log, and I want to log the request object. And now if we save this, let's first of all, let's create a new request. I'm going to say get one restaurant. And we'll copy the URL from the previous one. And then let's just put in some random ID. So I'll just do like 1, 2, 3, 4. And let's send. And let's see what happens. We have printed out the request object. So let's take a look at the request object. It's going to be fairly big. And I'm going to see if I can find what I'm looking for. And here we go. There's a property called params. And so remember, this value right here is a URL parameter. And Express is automatically going to take that and store it within an object called params. And you'll see that the ID is a value of 1, 2, 3, 4. And you might be wondering, well, how did Express know that this is an ID? Well, if you look at the URL, we call this variable ID. So if we change this to, let's say, restaurant ID or something, or any other value, this params is going to get updated and stored under the value of whatever we put here, so restaurant ID. And we can just double check that. And I'm going to actually do a rec.param so we don't have to look through that entire list. And we'll save that once again. And I'm going to send another request. So we'll send, it's going to hang because I'm not actually sending a response back. And it looks like it printed out everything once again, which is not what I wanted. Let's see if I can find the params again then. Yep, here we go. So here's the params. I don't know why it didn't print out. I must have not saved it. Okay, so now if I do it, there we go. So now it just prints out the parameter, and you can see that it got updated to restaurant ID, and that's because we changed what the variable name is up here. So this value is going to be matched in here. So now we know which restaurant the user wants to retrieve. Okay, but we don't actually have our interaction with the Postgres set up with an Express. So right now we're going to stop here for the get restaurant, and we'll move on to the update and delete real quick, where we're just going to set up these basic route. And so we'll do update. Oh no, we'll do create a restaurant. And so this is going to be a post method. So we're going to do app.post. And it's going to be the same URL. Okay, let's save that. And let's figure out how we can actually send data to the Express server from the client. And so normally the way you're going to send back data from the client is you're going to add the information in the body of the payload. So if you go under body and then select raw, and then we want to send JSON, we can now add in data in a JSON format. So let's say we want to provide the name of the restaurant that we're going to create. And remember, JSON, the keys also have to be wrapped in parentheses, or sorry, quotations. So the name can be Taco Bell. And the, what other values do we need? Name, location. That's going to be, we'll just say New York. And then the price range, that's going to be 4 or something. Doesn't really matter. And so let's remove this console. Well, actually, let's keep that there for now, but we're focused on creating a new restaurant. And let's just do a console.log rec. And we'll save this, and let's see, how we can actually, retrieve this data that's in the body. Okay, so we sent that, and it didn't work. Well, first of all, we don't actually want to modify our get one restaurant, so let's delete this, and let's actually cancel that and create a new request. I'm going to call this create restaurant. And I'm going to just add this to the body real quick because I have it in my copy buffer. So we want JSON and then paste that. And then let's copy this URL and delete the end part. And this is going to be a post. So let's send that and let's see what it looks like. So let's see if we can actually find where that data is stored. It's a lot of output. Let's see. If you look through it, you probably won't find it. And that's kind of by default. So it might be somewhere in here, but there's actually a better way of actually retrieving that data. And to actually explain how that works, I actually have to explain something that's called middleware. So I'm going to pause this video for now, and I'm going to explain middleware in the next video. And then that's going to allow us to be able to take all this data that's in the body and then, use it to create a new entry within Postgres. Now I want to explain how Express middleware works. Now I want to explain how middleware works in Express. And before I actually show you guys that, I want to go over how we actually handle requests and response within Express. And it's fairly simple, but I built out this simple diagram. On the left side, we've got our React or our front end. And then on the right side, we've got our Node and Express app. So normally the front end is going to send a request, and that request is going to hit our Express server. An Express server will then look for a route that matches the URL of the request, and then it'll the route handler for that URL or that callback function where we pass in the request and the response is going to perform a certain set of actions, and then eventually we're going to send back a response to React. And so that's how a normal Express app works. However, we have something called middleware, okay? And middleware is a very simple concept. There's nothing magical about it. But what middleware does is that when we receive the original request from the front end on our Express server, the middleware will actually receive that request first. He can then perform certain actions, and then he can then send that request down to the route handler, who will then perform whatever actions he needs to, and then he can send a response back. So that's why it's called a middleware. It sits between the request and the response. Technically, every route handler is also a middleware. So that's just something to keep in mind. But we basically just have this extra function, and a middleware is nothing more than a function, okay? So there's a function, it's going to receive the request, and then it's going to forward that request out to the next route handler. And the great part about middleware is we can string as many middleware as we want. So if we wanted to have, our first middleware who will receive the original request, and then he can send it to another middleware, and then he can then send it to, 5, 6 other middlewares, and then eventually it'll get down to the route handler, and he can send the response back. And I want you guys to keep in mind that the middleware has access to the original request as well as the response object. So he can perform any action that our route handler can. So if he wanted to send back a response, we can do that in the middleware. If we want our middleware to actually drop the packet, we can do that as well. So there's a lot of flexibility with middleware, and it's something that is a core concept of Express, and you'll see that setting up middleware will actually help reduce your code if you use it properly. All right, guys, so let's actually define our first middleware. And for middleware, what we want to do is we want to go to the top of our server.js file and define it right beneath where we define our Express instance. And to create a middleware, you just do app.use, and then you pass in the request and the response object. So middleware gets access to both of those, just like any one of our routes would. And keep in mind that actually all of these route handlers, they are technically middleware as well. They're just the last middleware in the chain of middlewares. So in our application up to this point, we just technically had one middleware, and that's this route handler. However, now we're adding a second piece of middleware. And so we're just going to pass an arrow function. And for now, we're just going to do a console.log and just say, yay, our middleware ran. All right, and so let's save that. Let's go to our get all restaurants request, because we know that that route works properly. And let's just do a send. And you'll notice that we actually don't get a response back, and Postman just kind of hangs. And so let's take a look at what happened and why it's hanging at this point. And if we take a look at the output in the console, you'll see that our middleware did in fact run. So Express gave that request up to the middleware, but for some reason, it doesn't look like we sent a response back from our route handler. So let's troubleshoot this a little bit further. And let's just do a console.log here just to see if our route ran. And so we'll say route handler ran. And I'm going to save this again, and we're going to send another request. All right. And so if we take a look at the console, once again, we see our middleware ran, but we did not console.log this line right here. So it looks like for some reason or another, our middleware is not passing the original request down to our route handler. And this is expected, and that's because the middleware has to be told explicitly to send the packet or the request to the next middleware or the route handler in this case. And the way we actually do that is by passing in another argument, and we get access to the next function. So the next function tells our middleware to send the request to the next middleware or to the final route handler. And all we have to do is just say next. So now if we do a send again, you'll see that we get a response back. You'll see that it hit our middleware, and you'll see that our route handler ran. So it looks like everything's working. That's pretty much it, guys. Middleware is that simple. All it is just a function that receives the request and will send it to the next middleware or the final middleware, which is known as a route handler. Now keep in mind that the order or the place where you define your middleware is very important, because just like any other program or application, Express is going to read from the top down. So when it receives a request, it's going to look for the first route or middleware that matches that URL. And so if we take this middleware and we just move it down beneath all of our routes and paste it in there, we'll do a save and do a send. We get a response back, and we see the route handlers ran, but the yay, our middleware line did not run. And that's because we never actually hit our middleware. And that's mainly because when that request comes in, it comes into this route, the /API/v1/restaurants. And so it matches this URL or this route, and then it just sends a response back, and that's it. So it never actually makes it to this middleware, which this middleware doesn't actually match a specific URL. It matches all requests. So all requests can technically hit this, but Express matches this first, so it just makes it to here, and then we send a response back. So we never actually sent it to this middleware. And that's why you want to define your middleware at the top, so that Express will send it to this middleware, and then he can then send it to the next middleware or the next route. And like I said in the previous section, we can actually create more than one middleware. We can put in as many as we want. So if we copy this, we can then basically just print out something else. We'll say this is our second middleware, and save that. And so now if we do a send, you'll notice that we've got yay, our middleware, and then this is our second middleware, and then it goes to our route handler. So it's all sequential. So if I took this and then just moved this to the top, what do you think is going to happen? Well, now the order got flipped. So this middleware, which says this is our second middleware, ran first, and then yay, our middleware, and then finally our route handler. All right, guys. So that's middleware in a nutshell. Keep in mind that all we're doing right now is just console.logging, but within this middleware, we can do anything that we do within our route handler. So if I delete this middleware real quick, I can show you something really, really cool. What we can do is, if it hits this middleware, we can just say, we can actually send back a response. We can do res.status, and let's send a 404 or something, and then we'll just say .json, and then say status fail. So now if I hit save, hit send, you can see that we've got status equals fail. So from the middleware, we can actually send a response back to the user. That's how powerful middleware is. And we can even drop the packet. So obviously by not having that next function defined in here, if we just remove this and then hit send, oh, I forgot to save, right? We never send a response back because we don't call next and we are effectively dropping a packet. So that's one way you can actually just drop a request. And so once again, just to reiterate, I know I've said it many times, but anything you can do in a route handler, you can do in a middleware. Now, technically with middleware, just like with packages, you don't have to write your own middleware. There's actually a ton of third-party middleware that you have access to. And I'm going to show you guys how to use the third-party middleware. It's a very popular and common one. It's called Morgan. It's just a simple logging middleware. But if you don't know what Morgan is or how to install it, you want to go to npm.js.com and then just search for Morgan, and it's going to take you to the page for Morgan. And let's actually install Morgan. So it's very easy. You just do npm i Morgan. So let's stop our server. We'll do npm i Morgan. And then we import it just like any other package. So here they're doing var, but we're just going to do const because it's kind of the standard convention nowadays. We'll do const and then paste that in there. Actually, we can move that up to the top where we, whoops. I'm going to move that right there. Okay, and it's going to give us an example on how to use it. So this is how you define the middleware. So you just do Morgan and then you pass in the specific property. And so in this case, they use tiny, but we have got a lot of other options. So if we want to do, dev, short, tiny, common, you can choose those, but that's just going to determine how we actually log out the specific information. And but to use a third-party middleware, it's very simple. It's just like a regular middleware. You do app.use, and then we call Morgan, and then we pass in whatever option. So let's say we want to print out, actually let's start off with tiny just to see what it looked like. Okay, and notice how I'm not passing in next, and that's because Morgan's already, when you work with third-party middleware, they'll already be configured to actually call the next function, so they'll automatically call our next middleware. So let's save that. Let's start up a server, and let's get Postman to send a request. Okay, so it looks like it went through. And then notice Morgan is sending out this nice little log message. So it tells us it's a get method to this specific URL. We sent a response of 200, and then I guess this is how much time it took to actually send out that response. So 3.344 milliseconds. If we change it to dev, you're going to see a nicer output, a little bit more informative, and they color code it. Well, it's the same exact output, but they color code it as well. So it's a nice little tool to have. I like having this middleware whenever I am working on a project. However, really just the purpose of this video was to show you how to use third-party middleware. And once again, you can add as many middleware as you want. So if we wanted to add in our own custom middleware after this, we could do that as well. And, doing that is the same thing as, how we've done it before. So rec res next, and then just make it do whatever you want it to do. So, console.log something, and then make sure you call next. Okay, so now we've got two middleware. So if we send a request, we should see, we should basically see the information. So something, and then we've got that middleware as well. So guys, I know I kind of went on a little tangent regarding middleware, but the reason I wanted to do that is because I wanted to talk about the original problem that we're trying to solve, and that is when we actually go to creating a restaurant, right? If you go back to our create restaurant request, you'll notice that we're sending data in the body, and we need to find out a way so that we can actually retrieve that data from the body. And the way to do that is by using a built-in middleware that comes installed with Express. And so that middleware is called express.json. So let's delete our 2 middleware that we have. We don't need that anymore. And let's define our express.js middleware. So to use that, you do app.use just like any other middleware, and then you call express.json. So this comes built in with Express, but what this middleware is going to do is very simple. When we send a request, it's going to take this information that's in the body of the package, of the request, and it's going to attach it to our request object. And it's going to attach it under the property called body. So let me comment this out real quick. And under post, let's do a console.log rec.body, just to show you guys that this doesn't actually exist, this property on the request object. So now if I do send, you'll see that it's undefined. So there is no body property. However, once we uncomment that and set up this middleware, if we do a send now, look at that. We've got our body stored as a nice, convenient JavaScript object. So not only does it store it on the body, it takes the JSON that was sent from the client and it converts it into a standard JavaScript object so that we can manipulate it however we want to. And so at this point, that's as far as we can get with creating a restaurant. Let's move on to update and delete. We're just going to define the skeleton of those routes. Once again, we're not actually trying to implement the logic yet because we've got a whole section on how to actually, interact with a Postgres server with Express. And so until we actually learn how to do that, we're just going to define the skeleton of our routes. All right, so we've got the 2 GET requests. We've got the create, which is a post. Let's move on to update and delete. So for update, this is going to be a, update restaurants. This is going to be a app.put. There's going to be a put method, and the URL is going to be /API/v1/restaurants/ and then remember the variable, which is going to be ID. So this is going to let Express know which restaurant we want to update. And then we've got our callback function. And let's just do a console.log rec.params.id just to make sure that we are receiving the ID. Save that. Oh, it looks like I made a mistake. What happened here? And I don't know why I did it like that. We just need a comma right there. Okay, and so now let's create a new request. Date restaurant. And the update restaurant is going to be pretty similar to create restaurant, where we're going to have to pass in the new values for that restaurant within the body. So I'm just going to copy this and paste it into the update request. And once again, we go into raw and then JSON. Okay, and so since we're using a put method, that means we have to pass in all of the fields, right? We can't just update individual fields. We have to pass in all of the fields to update the restaurant. And the URL is going to be, for the most part, the same, except we're going to have to pass in the ID. And so we'll just pass in an ID of 1234 for now, hard code it. And let's also console.log the body as well. So rec.body. So not only should we get the ID of the restaurant we want to update, but the values that we want to update that restaurant for. Okay, so let's hit send and let's take a look. And it looks like the body did not get attached. Oh, wait a minute. I realized what I messed up. So this is still a GET request. But that also reminds me, it looks like we had changed something on the GET request, and this should move back to ID. And let's make this an update or a put. Now we get the ID as well as all of the fields. All right. And I realize we haven't been sending responses back for all of these, so let's actually configure that as well. So for a get method, we're going to send a res.status. It's going to be status of 200. And we're going to send it back in JSON format. And I'm just going to hard code some dummy data. So we'll do status as success and data. And then we'll have a restaurant field. And then that's just going to be, some hard coded restaurant for now. And then for creating a restaurant, this is going to be for the most part the same. The only difference is that we're going to send a different status code. I believe it's 201 that we want to send, not 2001, 201. And then for the update, we're going to send, we're going to do the same thing. And we'll send a status of 200. And then now finally, let's set up our delete. Well, actually, let's save this and just test all of those out again. So if we do an update, okay, that worked. If we do a create, that worked. And that's going to be a 201. Make sure get one restaurant works as well. 200, perfect. And then get all restaurants. Perfect. All right. And so finally, the last route that we want to define is the delete. So we'll do app.delete. URL is going to be API/v1/restaurants. And then once again, we got to have that ID variable. And we want rec and res in our callback function. And we'll just do a res.status. And we'll send a status code of 204 for a delete. That's assuming it's successful, of course. And with the delete, since we're deleting the restaurant, I'm not sure if there's any data that we need to send back. So we'll just say status and then just send a status of success, but there's no actual restaurant to return because we just deleted it. Okay, so let's create the request for our delete. And then make sure you save all of your other requests as well. Okay. And so delete, this is going to be a delete method. And let me copy the URL from previous one. All right, let's send. And we got a response back, 204, no content. And yeah, so it looks like even though we told it to send a status of success, because it's a 204, I guess what happens is Postman automatically removes like the body. It removes the JSON that we sent it back because it's 204, so we don't actually get a chance to see it. But know that we are in fact sending that data and everything is working just fine. All right, so we've got all of the routes in place. In the next video, we'll figure out how to actually talk to our Postgres database from our Express server. In this section, we're going to configure our Express server to connect and talk to our Postgres database. And so once we get that set up, we can then, from Express, run various SQL queries that we normally could only do through the command line. And the way we're going to do this is by using a library called node-postgres. And so you can actually navigate to this website right here to see all of the documentation. This is the main Postgres library for JavaScript, and I highly recommend you use this one. There's a couple other ones, and they work fine as well, but this is probably the most popular one. But to actually structure our project, they have a couple of guides on how to do that. So I recommend you go to this link right here, Express with Async Await, and it's going to show you how you want to actually structure your project. And they recommend that you configure a folder called DB. And this folder is going to contain all of the information on how we're going to connect to our Postgres database. It's a nice way of organizing our project. We don't want to just throw everything into the server.js file. It's already cluttered enough. So it's best to move all of that stuff into the DB folder. And so we're going to create a file called index.js, and it's going to have just this code right here. And so we're going to create a new pool. So this is how we're actually going to connect to our Postgres database. And so let's go ahead and do that right now. First of all, let's actually install PG. So do we do npm install? And then PG. So that's going to install the node Postgres library. And from there, within the server directory, we're going to create a new folder. We're going to call this DB. And within there, we're going to create a file called index.js. All right. And, for now, just copy this. Okay. And I'll explain what each line means in a second. But basically, we're importing the PG library, except we are destructuring out just the pool object. That's all we care about. And then we're going to create a new pool. So this is actually what's going to connect to our Postgres database. And then we want to export this. And this one looks a little funny. And I don't know the best way of explaining this, but I recommend just for now, don't worry too much about it. But we are exporting the query object, and then basically just passing in this function that does a pool.query. And so if you look at the example below, this is going to show you how we can import this index.js file into any of our other files like our server.js. So all we do is we do const db equals require, and then we import the db folder that we created. And then all we have to do to actually send a query is do db.query, and then you just pass in the actual SQL query that you want to run. So that's it. It's actually pretty simple. But the one thing that we have to do before we can actually start running queries is to pass in information on how to actually connect to our Postgres database. So we have to give in the user, the IP of our server. We have to give in, what specific database within our Postgres instance we want to connect to. And so if we go into this connecting section up here, it's going to show us how to do it. So we can do this through the environment variables, or we can just hard code it like this. So we'll start off by hard coding it, and then I'll show you guys how to change that over to environment variables, because that is the recommended way of doing things. Okay, and so we'll go into index.js under our DB folder. And what we want to do is within our pool object, we want to pass in these values. So we can just copy this for now. And I have no idea why VS Code put parentheses around everything. A little weird. Oh, I know why it did that. Hold on, let's delete that. And we're going to be passing in an object with all of those values. Okay, and so we want to change the user, because remember, we always use the Postgres user to connect to it. However, if you created a new user, go ahead and use that user. And we're going to connect to localhost. The database is going to be called Yelp, right? Because if we go back to our command line, we created a database called Yelp. Password, whatever password you used, put that in there. I used my favorite password of all time, which is password 123. And then the port, I forget what's the default port for Postgres. It is 5432. All right, and so now we can save this. And if we go back to the documentation and go back to the guides, we can see how we can import it. So we just do const db equals require, and then the folder that we just created. So let's go to server.js, and we'll import it right at the top. However, our DB folder is in the same directory as our server.js, so we just want one dot. That means current directory. And notice how we don't have to do /db/index.js. When you do /db, it'll automatically look for a file called index.js, so you don't need to do /index.js. Although I don't think doing this will break anything, so you don't. But I just wanted to point out that's why we don't actually have to use the index.js. All right, and so now we have access to the DB object, which is, I forget what it is. It's the pool.query. And so if we go to get all restaurants, we can actually just test that out real quick. So just keep taking a look at the example, and we have to do db.query and then the query. So we'll do db.query, and then let's pass in the query, which is going to be select star from, and then let's actually go back to our database real quick. And let's do a /d. I forget what the tables were called. So we've got one called restaurants. So we can just do, just like a query on the command line, we can do the same thing through Express, but we would do select star from restaurants to print out all the restaurants. And so I've got one restaurant. However, if you don't have a restaurant in there, You may want to add one just for testing purposes. So you can do insert into restaurants. And then we're going to pass in the name, the location, and the price range. And then the values are going to be, we can pass in, I don't know, Taco Bell. And location can be San Fran. And the price range can be 3. Okay. And don't forget the semicolon. That should insert it into there. So now if we do a select star from restaurants, we should see at least 1 or 2, depending on, what other data you previously had. So now we do a select star from restaurants. It should do the same exact thing that we just did from the command line. However, we want to actually store the result into a variable. So we'll do const, I'm just going to call it results equals db.query. Now this is going to return a promise because this does take a certain amount of time. So when we're dealing with promises, I prefer to use the async await syntax. So we can do await. And then if you haven't already done so, make this route handler an async function. So by default, it shouldn't have been an async. So just put an async up there, and that's going to allow us to use the await feature. And then we can change this console.log if you still have it to results. So we can take a look at what our results look like. And then don't forget to do a save. And don't forget to start back up your server. And now if we pull up our Postman and go to get all restaurants, hit send. Let's take a look at what the output looks like. And so the console.log result, you can see what the result looks like. So we've got the Wendy's and then the Taco Bell. I don't know why I got wheelie formatted. I think it's just because of the width. But so that means it's working. We have successfully made a call to our database and retrieved some data. And I think that's almost a good stopping point. However, what I don't like is the fact that we are hard coding values into our code. So if we ever commit our code into GitHub, well, we've now exposed our password to everyone. So let's use environment variables moving forward so that we don't actually have to hard code our password into our code. And to do that, let's just go to our documentation for Postgres. And let's go to connecting. And it says that we can use these environment variables. And so we've already set up our .env file. So we can just copy these and just paste it into there. Remove the backslashes. And then remove the weird spacing. And just fill in the information accordingly. So this is going to be Postgres. This is going to be localhost. This is going to be my password. Postgres database, this is going to be called Yelp. And then what was the PG port? I forget. 5432. And the nice part about this is that, you're probably thinking that we have to change this to, process dot, env dot, what was it called? Was it, I think it was user, PG user. Right, and that would work just fine. However, the PG library automatically knows to look for these exact environment variables. So we don't actually have to put that in there. We can just remove all of this. Remove the object. We don't need that because right now it's just an empty object. Save that. Let's do a file save all. And let's run our request again. Oh, it looks like we got an error. Password authentication failed. What happened here? Password one. I think I just forgot to do a save all. So let's delete that once again. Save that and let's do another send. There we go. So it worked. And now we should see under the rows property of the result, we should see the 2 different entries that we have in our database. All right, guys. So we've now got Express set up to talk to our Postgres database. We can now start working on the logic of performing the various CRUD operations in the next video. Okay, guys, so now that we've got our Express server connected to our Postgres instance, we can now go ahead and actually configure all of the logic within our routes. So we're going to start off by implementing the get all restaurants route. And this is the one that we actually used for an example in the previous video where we're actually doing the db.query and then doing a select star from restaurants. So this one is already almost done. But just to recap, we had to make this an asynchronous function. And then what we do is we do an await, and then we call db.query. So this is what will actually send the query to our Postgres instance. And then we're storing the result of that into a variable called results. And let's quickly go back to our Postman, and let's send another request just so we can see what the output looks like. Okay, and if we take a look at the outputs, we'll see that within result, all of the data is stored in a property called rows. Okay, and so that's going to return an array of all of the restaurants. So when we actually go to send our data, right now we've hard-coded it into just 2 different restaurants. We actually want to return that result. So I'm going to change this. We're going to delete this real quick. And we're going to say, well, first of all, I'm going to make this plural because we're getting multiple restaurants. And I'm going to say we're going to return results and then rows, because we want the rows property, right? Because that's where all the data is stored. And one more thing. For APIs, when you're going to return a list of something, it's always best practice to add an extra property onto our JSON response, basically listing how many results were actually returned. So we're going to create a property on this called results. And we'll say results.rows.length. So that's going to get the length of this array right here. And don't forget the comma. And so let's save this and let's test this out. And it looks like we got an error. So let's see what happened. And so one other thing, we're getting this unhandled promise rejection warning. And so with Express, what you want to do is anytime you have async await, you want to wrap that in a try catch block. So we'll do try and then catch. And basically we're going to take this output and we're going to move it into the try block. So we're going to try and make that call to our database. And if all of that's successful, we can also move all of that into the try block. Okay, and so we're going to try and connect to our database, and if it works and we get a result back, we can then send a response back to the client. However, if there's an error, you get a lot of flexibility in what you want to do when there's an error. Usually you want to do like you want to send a response with like a status code of some kind of error, like a 500 or something like that. But just to keep things simple, we're just going to console.log whatever the error is, right? And so we're passing that error into a variable called ERR, and then we can just console.log that. So let's give that a shot. And we're still getting an error. So rows is not defined, it looks like. Let's see what results.rows. And yeah, stupid me, this should be .rows. So that's what the error was. So now if we do it, there we go, guys. So now it returned all of the information that's stored in our Postgres database within the restaurants table. And so we've got 2 entries. We've got the Wendy's and the Taco Bell. And so that's all we have to do for the get all restaurants. That was a really simple route. The next one we're going to tackle is the get an individual restaurant. This one's a little bit more complicated because now we have to search for a specific restaurant based off of the ID. Okay, guys, so now in this section, we're going to implement the get an individual restaurant route. This one's going to be a little bit more complex, but if you recall, what's going to happen is that we're going to embed the ID into the URL. Okay, and so we can then retrieve what the value of the ID is by referencing rec.params. So let's just do the get one restaurant, and let's just quickly test that out just to refresh your memory on that. And so when we do that, you'll see that it prints out the ID, or it prints out all of the parameters. And in this case, we just got one called ID, and that's going to be based off of this variable. And so now that we have the ID, we can then query our database to retrieve a restaurant with that specific ID. However, I haven't actually taught you guys how to search for a specific restaurant based off the ID, but that's very simple. So just like a normal query where we would do select star from restaurants, we can then pass in a where, and then you can say where ID equals 1. So this is going to look for a restaurant whose ID equals to 1. So let's test that out. And so that returned Wendy's, and we know that that has an ID of 1. If we wanted to get the restaurant with an ID of 2, we can do the same thing and just put that as 2. It's as simple as that. So you just do where, and then you specify the column and then the value that column should have. So you can technically match on anything. So if I wanted to find a restaurant whose location equals New York, I can do that. And you can see it returned the Wendy's because that has a location of New York. And we could do the same thing with any restaurant that has a price range of 4. So price underscore range equal to, or we'll do 3 just to mix things up. And so that's going to return the Taco Bell. And, you know, if we had multiple restaurants with a price range of 3, it would return all of them. I only have 2 restaurants in here, so we don't actually see that. So that's something to keep in mind. However, when we search on ID, we know that that ID is unique and that only one restaurant can have that specific ID. So when we do where ID equals X, we know that we're going to get one individual restaurant. All right. So we know that when we do rec.params and then we grab the .id property on the params, we should just get 1, 2, 3, 4. So let's just quickly test that out again. Do a send. And so now it prints out 1, 2, 3, 4. Perfect. All right. And so now what we can do is we can do the same try catch block that we did on the get all restaurants. And within here, we can do const results equals, and then we're going to do the same thing. So await db.query. And then we're going to pass in the query. So if you recall our query, let me pull this up again, is going to look like this. So select star from restaurants where ID equals, and then we have to pass in the ID. So let's see how we can do that. So we've got the ID stored in rec.params.id. And so your first thought is to probably do a template string, right? So in JavaScript, you can do backticks, and then we can say select star from restaurants where ID equals, and then now we can do $, and then we can pass in rec.params.id. So this is going to take the value that's stored in this variable, and it's going to pass it into the string so that we do where ID equals, and then, 1, 2, 3, 4, or whatever value we're passing in the URL parameter right there. Okay. And, this will technically work, and I'll show you guys that real quick. And let's make sure we pass in an ID that actually exists. So we know there's an ID of 1. We'll save this. Oh, looks like I made a mistake. Await. Okay. So since we're using the await syntax, we have to make this callback function asynchronous. Okay. And now let's do a send. Yep, and I realized I forgot to update what the response is going to look like. So we're storing the result in this variable called results. So let's just do a console.log results just to see what that looks like. We'll do send. And the result is this massive output once again. And the data is going to be stored within rows. So rows is always going to return an array. However, since we're querying for an individual restaurant, we're always just going to have one entry in that array. So where we want rows, we want results.rows, and then we just want the first entry in the array. So we can just do that. Now let's send it again, and let's check the output, and there you go. We get an object with all of the fields for that specific restaurant. That's exactly what we want, and we can return that by passing that into here. So we can do results.rows, and then 0. Now let's do send. And I butchered something. Let's see, what did I break? Okay, so I see my mistake. So this response needs to actually go within the try block. All right, because the reason is this variable is being defined within the try block. So outside of the try block, we don't have access to results. So let's copy this. We can remove that console.log. Save that, run it again. And there you go. We got the restaurant that has an ID of 1. If we try 2, we should get the Taco Bell. Perfect, guys. However, there's one thing that I want to highlight, and that is this template string. What we did here is very, very bad. This is actually going to make you guys vulnerable to SQL injection attacks, and it's never recommended to use any kind of string interpolation or template literals within your query. Instead, what we want to do is use a parameterized query. And Node.pg, the library that we use, supports that out of the box. And so if you want to read up on that, if you go to the query section, it's going to explain, the same thing, right? It's never good to use any kind of string concatenation of any kind. It's going to lead to SQL injection attacks. So you want to use a parameterized query. And hopefully they gave us an example of what a parameterized query looks like. And did they? Oh, yeah, I think it's up here. Yep. So this is what it's going to look like. Actually, this is a little confusing. I'm just going to show you guys real quick how to do that. So what we want to do is, within our query, it's going to look like just like it was before. And we're going to do select star from restaurants where ID equals. And this is where it's going to look a little goofy. But we're going to pass in $1 and then a 1. We'll do $1, okay? And so this is kind of think of this as a placeholder. So, whatever is this $1, when we actually go to send the query, we're going to replace it with the ID that we actually want to use. And how do we pass in the value? Well, you pass in a second argument into the db.query, and this is going to be an array. And we pass in the value that we want to replace this $1. So we're going to do rec.params.id. So when we actually go to make this query, we're going to take the first item in this array and pass it into the $1. So when we actually send that query, it's actually going to just look like select star from restaurants where ID equals, and then instead of $1, we're going to pass in rec.params.id. So that's what the final query is going to look like. It's going to look exactly like the original query, except by doing it through this method, which is called a parameterized query, it prevents us from being vulnerable to SQL injection attacks. So always use this format. Never, ever use string interpolation. And guys, another thing to point out is that you can pass in as many, as many of these placeholders as you want. So remember I said that if you did instead of star, you can actually pass in the columns that you wanted. If you wanted just the name column, right, you could put in name. However, you could also just put in, let's say $2, and then you would, in the second entry within this array, you would then pass in name. Okay, and so that's going to take the name and pass it into this 2. So the first item in this array gets passed into whatever is $1. The second one is going to get passed into whatever is $2. So if we save that, let's give that a shot. And it looks like I messed something up. Maybe I just want... I'm not sure why that gave an error. But don't worry too much about that. We'll come back to that later. Just leave that for now. And we can remove name. Save that and just hit send. And you see that we get the restaurant output. Okay. So guys, once again, just to reiterate, we're going to use this format moving forward. The only magic that's really happening is whatever's stored in $1, we're going to replace it with whatever's in the array. The next route that we need to wrap up is the create a restaurant route. So this is going to be a post route. And let's go ahead and run that request again, just to kind of remind you guys how that works so far. So we'll go to create a restaurant, and notice in the body, we're going to send this JSON data that includes the name, location, and the price range. And because we have our middleware, this express.json middleware, all of those fields that come within the body will get attached as a JavaScript object onto rec.body. So if we hit send again, right, we can see that all the values show up on rec.body, which I'm console.logging. So we've got the name, the location, and the price range. So now that we have that data, we can then go ahead and create an entry in Postgres. So just like before, we're going to do the same thing. We're going to take a try catch block. And we're going to make a query to our database. So we'll do We're going to store it in results, just like we always do. And we'll say this is going to be an async await. So we'll do await and then make sure our function is an asynchronous function. And then we do db.query. And then let's pass in our query. So we want insert into restaurants. That's a table we're going to insert into. And we're going to insert in the name, the location, and the price underscore range. And then the values that we're going to pass in, whoops, what did I mess up? This should not be closing there. And the values that we're going to pass in, this is where we're going to do the parameterized query again, because remember, we don't want to actually pass in the rec.body directly. Instead, we want to do $1, $2, and then $3. Okay, and so we will then, as the second argument into the db.query, we'll then pass in an array. And the array is going to contain the value for $1, $2, and $3. So the first value that we pass in will get pushed into $1, wherever that is in the string. The second one will go into $2, and the third one will go into $3. So the first data that we have to pass in is the name. So we can do rec.body. And we're going to get it as name as well in the object. So we can do rec.body.name. The second one is going to be the location. So we'll do rec.body.location. And then finally, the last one is going to be the price range. And then make sure to close that out. And remember, we want to take the response and move it into the try statement. And if we get an error, we're just going to do a console.log. And let's actually take a look at what the output looks like. So we'll do a console.log results. Okay, and so go to create restaurant. Let's give that a shot. Okay, and I've hard-coded the output from the response to just say McDonald's. So it looks like things worked, but let's take a look at the output. And if we take a look at the output, you'll see that, normally all that data that gets returned would get put into rows, but we have no actual data. However, we do see that we did insert one row. And if we actually go to our Postgres instance and just do a select star from restaurants, you'll see that we now have a third entry, and that's that Taco Bell in New York. So why did we not get any output, right? We normally in a API, when you create something, we want to send back the newly created restaurant so that the front end can update the UI accordingly. Well, I mean, if we just take a look at how Postgres works, and let's actually just insert one through the command line. So if we do insert into restaurants, and then pass in name, location, and then price range. And the values, let's just give it some dummy values. So let's just say this is Cheesecake Factory. Location is Dallas. And then price range is 2. Look at that. When we insert anything, look at that. Postgres by default doesn't actually return any data. And so that's what's ultimately causing us to not retrieve any data within Express, is because Postgres doesn't send it by default. So to actually retrieve the data, or to make Postgres actually output the new restaurant that we just created, it's very simple. All you have to do is just do, returning star. I believe that's what it is. And look at that. So when we created a new entry, it then returns that new entry. So returning, and then star is just basically saying, return the new restaurant that you created and return every single column. However, if we create a new entry, change up a few things real quick, we'll just change the city to Houston or something. And let's say when we create a new restaurant, all we need to do is return the ID. then you can do that, and then Postgres will return the ID. So at the end of the day, the only thing I want to highlight is you need the returning star. So let's go back to our code and change this to returning star. And so now if I save that and then send that data again, and if we take a look at rows, we can see that rows now has the information regarding the new restaurant that we just created. So we can change restaurant, and we can pass in results.rows, and then we want the first and only element because we're creating one restaurant. It's just going to return one object each and every time. Save that, and let's send this data. And there you go, guys. We've now created a restaurant through our API, and we've returned that data back to the front end. Okay, so now let's move on to updating a restaurant. And the first thing I have to do is show you guys how to update an entry within Postgres. So let's do a select star from restaurant, and let's just find a restaurant that we want to update. Okay, so let's update this last one. So the Taco Bell with an ID of 8. And to update an entry within Postgres, what we have to do is we type in update. Makes sense, right? Then the name of the table, so that's going to be restaurants. Okay, and then now we have to pass in the values that we want to set. So we've got a couple of fields. We can choose which fields we want to update. We can update 1, we can update 2, or we can update all of them. So as an example, I'm just going to show you how we can update all of them. What we do is we do set name equals, then the name. So right now it's Taco Bell. Let's say we want to change this to, what's another restaurant? We'll call it Red Lobster. Then you do comma. Then we can pass in the new value of the location. And that's going to be in Miami. And then we pass in the new value for price range. And that's going to equal 1. Well, let's do 2 to be realistic. Okay. So far, so good. However, we actually have to tell it what's the ID of the entry we want to update. So just like we did with searches, right? If you remember how we did a search for a specific entry, let's see, where did I do that? I guess I may not have showed you guys that, but we just do the where, right? We would do where ID equals, and then you pick the ID. So we do 8. So just to reiterate what's happening, we look for an entry with an ID of 8, right? And if it exists, we're going to set the name to Red Lobster, the location to Miami, and the price range to 2. So keep in mind, we don't actually have to update every single column. We can just update one column if we wanted to, but in this example, I'm going to update all columns. So wrap that up with a semicolon, hit enter, and I clearly butchered something. Oh, I misspelled restaurants. Okay, and it said it updated. So if we do a select star from restaurants now, and look at 8, we can see that it changed to Red Lobster, Miami, and 2. So that's how you update an entry within Postgres. So knowing that, let's actually work on our route now. So once again, this is going to be an asynchronous function. We're going to need our try-catch block. A lot of repetitive code when you're working with APIs. And then we'll do catch, error. And if there's an error, we'll just console.log it. And we're going to do const results equals. And then we want db.query. And then we're going to pass in the string. So we do update restaurants. And here we're going to set name equal to. And so remember, all of the values that the client sends is going to be within the body, just like it was for creating a restaurant. It's the same thing. So we're going to have it attached to rec.body. So here we can't obviously use string interpolation. So just like before, we want to use the $1. And then for location equals $2. And then price range is going to equal $3. And then we can pass those values into the array. We can do rec rec.body.name, rec.body.location, and then rec.body.price_range. Also, one thing to note though, if you notice when we updated this entry, we did not actually return the newly created object or the newly updated object. So same thing with updates as we the same thing that we had to do for creating a new entry, we also have to do for updating an entry. We have to do the returning star. So let me just update it with the same exact values that we currently have. And we'll just do returning star. And so now it returns the new object. Okay, so we will add at the end of this. Well, first of all, we forgot to pass in where ID equals, and then that's going to be $4. And that value is going to be stored in rec.params.id. Okay, so this is just going to tell Postgres which specific restaurant we want to update. And remember that value is going to get passed into the parameters with the ID property because that's what we stored it as in the URL. Okay, so let's save that and let's move our response up into the try block. And let's console.log the results just to see what it looks like. And let's make sure there's no errors. Okay, so we'll send. Oh, we forgot to go to, yeah, I'm in the put. So what happened here? Okay, let me pick a value of a restaurant that I know exists. So 8. And I think you guys already know what I did wrong. I forgot to put a weight here. Now if we send, now we do get an output. And it did not return anything. And what happened? Why did it not return? Oh, we forgot to put returning star. Okay, let's send that one more time. And this is the output, and there we go. So we've got the updated entry, and that's going to be stored in rows, and then we can just grab the first element in that array because there's only going to be one element. So under restaurant, we will change this to results.rows and then 0. Remove that console.log. And let's test that one more time, but let's change the name or the city to be London. We send that. Looks like everything worked. Let's check in Postgres. Well, actually, first of all, let's make sure the response looks good. Taco Bell, London, perfect. And then we'll do select star from restaurants where ID equals 8. And there you go. The location changed to London. Okay, guys, we're almost done with our API. There's just one last route that we need to tackle, and that's going to be the delete route. And so let me quickly show you guys how to delete a entry within Postgres, and then we can just implement the same exact query within Express as well. So to delete an entry, we just do delete from, and then specify the table that we're trying to delete from, so restaurants. And then here we just have to specify some kind of match criteria to pick, which specific entry we want to delete. So we're always going to be deleting based off of the ID. So we'll do where ID equals, and then pick an ID. So we'll just delete this Taco Bell with an ID of 8. Okay, and so now if I do a select star from restaurants, we should not have anything with an ID of 8, and we don't. So that's all we have to do to delete it. And we don't need to do a returning star because we just deleted an entry. There's nothing to return. And so once again, we're going to do the usual. We're going to make this an asynchronous function. And we're going to add our try catch block. And then we'll do const results equals db.query. And once again, we're going to pass this in as a variable, and we'll say we can get the ID from, as usual, the rec.params.id. Okay, so that's going to once again come from there. And we'll take this response and send it up to there. And let's just make sure we do a console.log in case any errors occur. And I don't know if, okay, we did create a delete restaurant request. So here we're going to change this to, let's get a restaurant that still exists. So we'll just do an ID of 7. Okay, so we've got a 204, no content, which means it looks like it deleted it. No errors printed out in the console. And if we do another query, we should see that the ID of 7 is gone. So there you go, guys. That's pretty much all we have to do for our backend. So our API is done for the most part. Well, it's done until we start implementing the reviews aspect of our project. But for now, this is all we need to do. So in the next upcoming section, we're going to start working on the front end, and we're going to start playing around with React. And that's probably going to be the most complex part of this application. I put a lot into the React side of things. And so it's going to be a lot of fun. We're going to learn a lot about React. So anyways, I'll see you guys there. Now that we're done with our backend, it's time to move on to our front end. So let's set up our React application. And our React app is going to be stored on our client directory. And so what we want to do is, first of all, we want to navigate outside of the server directory and into the client directory. And here, if you've never used React before, you're going to want to do npm install and then create React app and then -g. So this is going to install create React app, which is what we use to initialize a new React application. It's going to install it globally so that we have access to the create React app command. So after you install it, we can now use the command create React-app. And then what I want you to do is just do a dot. So that's going to create our new React application within the client directory. Okay, so our the create React app has completed, and if we take a look at our directory, we should now see a whole bunch of files. And so let's go into our source folder, and let's see that create React app actually creates a example application. So what we can do is just go ahead and just delete all those files. We're going to start everything from scratch. And so within the source directory, we're going to create a file, and it's going to be called index.js. And we're also going to create a new file, and that's going to be called app.jsx. Now within index.js, we want to import React. So we'll do imr. Oh, sorry. I guess I didn't show you guys this, but I have an extension installed within VS Code. And this extension, I think, is called ES7 React Redux GraphQL. So it's this one right here. And it basically gives you little shorthand snippets. So if I type in imr, it's going to type in import React from React. So I highly recommend you install it. However, if you want to type things out, then feel free to do that as well. So we want to import two things. We want to import React, and we also want to import React Router DOM. So I can do imrd with that extension, and that's going to import React DOM from React DOM. Now, before moving forward, let's define our app component. So we're going to have to import React into here as well. And we'll do const app equals. And then we can just return, let's just say we return a div that just says app. And then we need to export our app. And once we've exported this app, we can then go back to our index.js. We will import app from app. And then we can render this app onto the screen. So we'll do React DOM.render, and we'll render our app component. And we'll render it to the document.element, get element by ID, and then root. So what we're doing is, this is our parent app component. So this is going to wrap our entire application. And we're basically saying that we're going to render it onto an element called root within our index.html file. So if we go to our index.html file right here, you'll see that there is a div with an ID of root. So we're going to insert it right in between the opening and closing tags of that div. So let's do a save all. And while we're still in the client directory, you want to do an npm start. And it's going to start up the React application. And it's basically throwing a warning right now because apparently some other application is using port 3000. So if you do see that error, just hit yes, and React is just going to pick the next available port. So probably like 3001 or something. So this is going to open up in a new window. And so there you go. So if you see app getting rendered out onto the screen, that means your React application has been set up properly. And let's actually go to the inspect and go to our console. Let's just make sure there's no errors, and it doesn't look like there's any errors. So at this point, it looks like everything is good to go. However, before I wrap up this video, there's two things I want to do. I want to add Bootstrap into our React application, and that's just going to be for styling to make our application look a little nicer without us having to spend hours on CSS configs. And then we'll also add Font Awesome so that we can get the star icon for the star rating component that we're going to build out. Okay, so to get Bootstrap, just search for get Bootstrap. And it's going to take us to the documentation page. And if we go to documentation, all you have to do is under CSS, just copy this. And then if we go back to our code, I've got so many windows open. Under index.html, what you just copied, just go right below this link and just paste it in. And then finally, the last thing we need to do is we need to get Font Awesome. So go to cdn.js, and here just search for Font Awesome. So the first result should be the one that you want, so just copy this. And then we're going to just create a new link tag. So we'll do link, and then we want CSS. And under href, we want to paste in the link that we just copied. Okay, and so at this point, we now have Bootstrap and Font Awesome incorporated into our application. And so I'm going to stop this video for now. In the next video, we'll get started on building out the routing in the front end side. Now, for our React application, the first thing that I always like to do is set up the routing on the front end. And keep in mind that the routing on the front end has nothing to do with how we set up routes on the back end. These are two completely separate things. We were doing the back end before, now we're doing the front end. And once again, we get the flexibility of setting up the routes in any way that we want to. So what I've chosen for our application is that there's going to be 3 total pages. So we've got the home page. And so that's going to list out a list of the different restaurants in our database. And we can access this page by going to the /URL. So this is a common homepage is just the /URL. The next page that we have is the details page. And so when we click on one of these restaurants, it's going to take us to a page that looks like this. And it's going to have the different reviews as well. This is the ability to add a review. And the URL for this page is going to be /restaurants/ and then :ID, right? And you guys should already be familiar with this. So this is the URL parameter that we used in the back end. And we can do we can make use of the same concept in the front end as well. So, if we click on this Cheesecake Factory, the actual URL is going to be /restaurants and then the ID of the Cheesecake Factory. And so that way it kind of gives each restaurant their own page. And then finally, we've got the update restaurant page. And the update restaurant page, the URL is going to be /restaurants, right? So it's very similar to this, and then :ID, and then update. Okay, so it's exactly the same as the detailed restaurant page, except we just add in /update at the end. And, we can actually take a look at this in action. So right now we're at the home page. So the URL right? Localhost colon 3000. This is the same thing as just adding a slash at the end, right? It's just the home page. And if we click on one of these restaurants, it's going to take us to the detailed page. And if you recall, the URL is going to be /restaurants and then the ID of this restaurant. So the ID of the Cheesecake Factory is 5. And if we go to the update page, it's going to take us to /restaurants/5/update. So that's a run through of how we're going to set up the routing. Now with React, what we have to do is we have to install an extra library to be able to set up routing like this. And we're going to be using React Router to handle that. Now let's get started on getting React Router set up. So the first thing that we have to do is install the package for that. And we can do npm install React Router DOM. And make sure you get the React Router DOM and not just React Router. Those are two separate packages. All right, and once that's installed, what I want to do is I want to create a new folder. And this folder is going to hold all of our routes. So this folder will hold the components that represent the 3 different pages that I mentioned in the previous video. And so we're going to have a component for the home page, and I'm just going to call that home.jsx. And I'm also going to have a new page for restaurant detail, and I'm going to call that restaurant detail page. And then lastly, we're going to have one for updating a restaurant. So we'll call this update page.jsx. And so we've got our three routes essentially, and I'm just going to do RAFCE. So this is one of the snippets, and this is just going to set up the bare minimum that you need for a React functional component. And it's automatically going to pull the name from the name of the file. But if you guys don't have the snippets installed, just type this out manually. It's going to take a little while. And I'm just going to make this say home. So it's just going to print out the word home. And I'm going to do the same thing for the restaurant detail page. And lastly, we'll do the same thing for the update page. Okay, let's save all. And now we want to set up the routes within app.jsx. So what we need to do is we need to import a few things from React Router DOM. So we want to import browser router. And we'll save that as router. And we also need to import switch and route. And these are all coming from the React-router-DOM library. Now I'm going to remove just the word app from here. We don't need that. So now I'm going to set up the routing. So what we have to do is we have to wrap our whole application in the router tag. And so now we can actually define our routes. And we're going to do, our first route is going to be for the home page. So we'll do route. And then we'll do exact path equals homepage, right? So this is going to be the homepage. You just have to navigate to the /URL. And the component that we want to load when someone navigates to the /URL is our home component, right? And that's going to reference this component right here. Okay, and I'm going to copy this and do that 3 times because we're going to have 3 different routes. The next one is going to be for the update page. So we'll do /restaurants /:ID and then update. And this is going to load up the update page component. And by the way, guys, that's how routing works within React. It's just that, you know, we specify a route, and then all it does is just load a component that we designate as our specific page. So this component homepage, this component home is going to reference all of the components that make up our home page. And this component restaurant detail is going to have all of the code that represents our detailed page, right? It's as simple as just loading different components. That's all React Router does. And then finally, for the detail page, we want to go to restaurants, ID. And this is going to load up the restaurant detail component. And it's best practice to wrap this in a switch statement. That's why I imported that as well. And that's just so that if we match a route, it's going to tell React Router to stop looking down the list of the different routes, right? The first route it matches, it's going to stop and return that. And this is to prevent React Router from loading multiple components. So let's do an npm start. Yep. And if you didn't realize, guys, I actually forgot to import these 3 routes. So we'll import home from, and then you want to go to // so that's going to be the current directory. And then within the current directory of our app component, we want to go into the routes folder. And then within routes, we want to import home. And we're going to do that 3 times for the 3 different components. Update page, as well as restaurant detail page. Okay, so now save that. And yep, I forgot to change these as well. And it looks like I forgot to capitalize this. So let me rename this to detail with the capital D. And within here, we're going to have to change this to a capital D. And let's do save all. All right, and so now it compiled successfully. If we go back to Chrome, you can see that when we go to the /URL, we load up home. And hopefully that's big enough for you guys. I'll make this a little bigger just in case. Now, if we go into /restaurants and then just give it some random ID of like 1, it should load up the detail page. Great. And then if we go into update, it should now load up the update component. All right, there you go, guys. That's all the routing that we have to set up for this application. Let's get started on building out the home page. If we take a look at the completed application, there's going to be 3 different components that we're going to have. We're going to have this header component that just prints out restaurant finder. We're going to have this add restaurant component. And then we're going to have this list component right here that's going to list out all of the restaurants. So let's create a components folder and let's create those components real quick. And so in here, we'll have a header.jsx. We'll also have a restaurant list. And we'll also have, what was the last one? I think it was add restaurant. All right, so we've got our 3 components, and now let's work on styling them or setting them up, I guess. Now our header component is going to be very easy. Let's just set up the boilerplate for the component. And within here, we're just going to render out an h1 tag. So we'll do h1, and we're going to add a few classes. So we'll do class name equals, and remember, these are all bootstrap classes. So, you can always take a look at the documentation to see what these do, but we want font -weight -light, and then we want display -1, and it's going to make it a little bigger, and then we want to center it. So we'll do text center, and our app is called Restaurant Finder. And that's it. That's all we need to do for the header component. And let's render that out onto the home page. So we'll go to our home component. And I'm going to pass in the header component. And remember, we have to import it. I'm going to let VS Code do that for me by clicking that. And that's going to import header from component/header. I'll save that and let's take a look. And let's go back to the home page, of course. There you go. All right, so we've got our header component. Let's go and move on to the add restaurant component. And we're not going to implement all of the logic. I'm just trying to set up the structure for now. And if we go back to the completed application, there's going to be three fields. So we've got 2 input text boxes and then this 1 drop down and then an add button. And so what we'll do here is this div, we're going to give it a class. We're going to give it a class of mb-4. So this is going to just give a little bit of margin at the bottom. And then we have to define our form. And in the form, we're first going to create a row. So we'll do .form-row. And guys, this is a little shorthand that we can do using VS Code. So if you do just a dot and then a form-row, what it's going to do is if I hit tab, oh, it didn't do that. Now if I hit tab, it's going to create a div with a class of form-row. So it's just a little shorthand notation so I don't have to write it all out. Hopefully it doesn't confuse you guys. All right, and so under there, we're going to create a column. So this is going to be the first column. So this is going to be one column. This is going to be another column. This is going to be another column. So we'll create a class of call. And within there, we want a input field. And the type is going to be text. And we're going to give it a few classes. So we'll do just one. It's going to be form-control. And then under this div, we're going to put another div with a class of call. And this is also going to be another input field. And we're going to give this a class name of form-control as well. And let's also give these placeholders. So the first one's going to be for the name, and this one's going to be for the location, so you can see the placeholders in there. So we can do placeholder equals, and this one's going to be name, and then placeholder here, and it's going to be location. And then we're going to add another column. And so now instead of an input field, we're going to do a select field. That's what's going to give us this nice drop down. We'll do select. I'm going to just remove the name and ID for now. Well, we can leave the, let's remove that. So class name, we're going to do custom-select my-1 and mr-sm-2. And within the select tags, we're going to define the different options. So we'll do option. And this first one's going to be disabled. And that's just going to be the price range, right? You shouldn't be able to select price range. Be price range. And then now we can define our actual options. So value, the first one is going to be 1. And that's because it's $1 or $1 sign. I'm going to just do that 5 times. So this one is going to give a value of 2 if it's selected. It's going to be $2 signs. This one's going to be 3. I think Yelp only goes up to $4 signs, but I'm not positive. And then, but we'll go up to 5. Okay, and then outside of that div, we're going to add a button. So we'll do button.btn.btn-primary. That's going to add those 2 classes, and this is going to say add. And I think that should be it for our form. Let's go to our home component and render that out. So we'll do /add restaurant. And remember, we have to import it. So we'll import it like that. Let's save that and let's take a look. That looks almost perfect. I couldn't figure out why there's this little space in between the top, but that must be something related to Bootstrap. So don't worry about that. It's not going to affect the actual functionality of our website. And now the final component, which is this list, the restaurant list. And so this is going to be the most complex component on the home page, especially when we start implementing all of the logic. But even just doing just the layout takes a little bit of time. And so if we go to our React documentation and go to components, I think, and then let's look for table. It doesn't look like, search for table. And so we're going to see the code to create a table. And I think I used this one, the dark one right here. And so, you could pretty much just copy this, but I'll type it out. So if you ever wonder where I'm getting all of the HTML for this, it's coming straight from Bootstrap. So let's do restaurant list. I'm going to just create a bare bones component. And I'm going to give this a class of list group. So once again, coming straight from Bootstrap. And then we're going to create a table component with a class of table, and then a class of table-hover, and a class of table-dark. Okay, so if you don't know what those classes do, if you take a look at our final application, so dark is just going to give us that dark background instead of making a white table. And then you notice how when I hover it, it turns that to that nicer, lighter gray color. So that's what the table-hover class is going to add. It's going to add that functionality. Okay, and so now let's define our header. So we have 1, 2, 3, 4, 5, 6 entries in our header. So we'll do th. Well, first of all, we have to create a row. So we do tr. Nope, I lied. We have to create our header. So we do thead. And we do a class. Well, there's going to be no classes, so we can just do. Okay, and then, oh, the spacing got messed up. Okay, and then within our thead, we need to create a tr, and that's going to have a class of bg-primary. That's going to turn it blue. And then here we're going to have 5 entries here. So we'll do th. And we have to specify a scope equals call, and then the name. So the first one is going to be restaurant. And I'm going to copy this 5 times. The second one is going to be location. The third one is going to be price range. The next one is going to be ratings. The next one was going to be edit. And we actually need one more for delete. Okay, and our head should be done. Let's now create the body. And we can just create a couple rows. So we'll do tr, and then within here, we're going to have td, and then this is going to have the restaurant name. So we're just going to hard code some values for now, just to make sure that our layout looks okay. So we'll call this, McDonald's. And we're going to need this a couple times. Location, this is going to be New York. And then the price range is going to have a couple of dollar signs. So I'm just going to hard code 3 in there, or 2. Then rating, this is going to be empty, so I'm just going to put the word rating in there because we haven't implemented that feature yet. And then lastly, we need a couple of buttons. So we'll do button .btn.btn-warning. So that's going to be the one for editing. So we'll change that to edit or update. And then finally, the last one's going to be the delete button. So we'll do button.btn.btn-warning. That's going to turn it red. And this is going to be delete. So let's take a look, and let's load up our restaurant component on our home page. And so here we'll do, what is it? Restaurant list. Make sure to import that. So let's see. Okay. Well, what happened there? Why are they both yellow? This should be delete or primary. No, danger. Okay, so we've got our component. And if we go back to restaurant list, and we just copy this entire row and just paste it again, just so we can see what it looks like with 2 rows. You should see that we got 2 rows. So we've got the structure of our of all of our components, and so now we actually need to, well, before we do anything, first of all, in our app component, let's just add a class right here. And I'm going to make this container. Because if you notice, it's going all the way to the edges. I don't like that. I want a little gap. When I add container, I'm going to add that nice gap. All right, so I think that's a good stopping point. So in the next video, we'll work on constructing the API to actually retrieve the list of restaurants in our application. Before we actually start coding out the restaurant list component and fetching data from our backend server, what we want to do is we want to find a place to actually store the results. And I actually want to store this in a context API. And the benefits of storing something or storing data within a context API instead of in a local state is that all of the components in our application can automatically retrieve that data. So we don't have to worry about passing that data down as props or lifting state or doing anything like that because every component already has access to the context API. So let's set up our context API to store the list of restaurants in our application. So what I'm going to do is under source, we're going to create a new folder. This is going to contain all of our context APIs. We're just going to have one for our application, but it's always good to structure it out so that you have a dedicated folder for that. I'm going to call this context, and then we need to create a file for that. So we'll call this context API restaurants context.js. And here we want to import a couple things. So we want to import React, and we want to import useState, as well as create context. And these are all coming from the React library. And so now let's create our context. So we'll do export const restaurants context. And we'll say create context. So this is going to create our context. And now we have to create our context provider component. So this is what we're going to wrap our entire application so that they all have access to our state. And so what we have to return with our restaurants context provider is we take our restaurants context and then grab the .provider component. And then now we have to pass in props.children. And so we've got our context set up. However, we're not actually passing any data or storing any data in our context at the moment. So what I'm going to do is I'm going to use the useState hook to store the list of restaurants. So we'll do const and then restaurants. So this is going to be an array that stores a list of all of the restaurants that we fetched from our backend server. We do set restaurants, and that's going to be the function to update that list or that array. And then we do useState, and the default value is just going to be an empty array. So before we fetch anything, it's just going to be an empty array. And now to actually pass restaurants down, what we have to do is do value equals, and I'm going to pass an object. And so I can do restaurants. And actually what I want to do instead is I want to actually pass an object. And so the first property on that object will be restaurants. And I'm going to pass down restaurants. And if you guys are familiar with JavaScript shorthand syntax, whenever you have the key and the value set to the same thing, you can just remove the colon and the value, and that's going to do the same thing. All right, so we're passing the value of restaurants down to every component. However, there's one more thing I want to pass down. I also want to pass down set restaurants so that our components can also update our state. So we'll do set restaurants. And save that and go back to your app component. And now we want to wrap our entire app component with our context API. And so we need to import our context provider component. So I'm going to let VS Code do that for me. And that's going to be this guy right here. So I'll click that. It imported that. Hit enter, and we want to take everything that we had already created and move it in between. All right, and I think that should be it. So if we go to, well, we can go to any component, but let's do an inspect. And if you guys don't have, oh, it doesn't look like, let me copy this for a second and go to my regular Chrome because I'm viewing it as a guest, and I guess you don't have access to extensions when you're a guest. So let's see. I don't want to be a guest. Okay, and so now if I do an inspect, and we go to our components, you need to make sure that you actually have the React Developer Tools extension installed if you want to see this. But if we go here, you can see that now we're wrapping our entire app with the context provider, and our current state is empty. So everything's looking good with our context so far. And we can close these out. I actually don't need these anymore, and I'll just use this page. Okay, so now that we've got our context API, let's take a break here, and in the next video, we'll start tackling how to actually fetch this data. All right, guys, so now this is when the fun starts. We're finally going to actually connect our front end to our back end by fetching data from our back end API. And before we actually do anything, what I want to do is set up our terminals properly. So I'm going to stop our React server. And what I want to do is actually do the split view. So this is going to create two different terminals side by side. And the one on the left, first of all, I'm going to move back to our server. I'm going to move into our server folder. If you don't know what this ... notation is, it means go up one folder. So I'm going up one folder and then down to the server folder. And then this one is going to be in the client. So this one's going to be for our React code. And here we want to do an npm start. So we're going to start our backend. And right now I'm listening on port 3001. But keep in mind that you may have configured something else. And I know it's a little bit confusing, but throughout this video, I think I've kept switching the ports that I've used for my backend. So just pick one value and make sure you remember that, because we're going to have to use that in the URL when we send our API request to our backend server. And we need to make sure that this is always running. And then let's start up our front end server. And it's just saying that, you know, once again, another application is using port 3000. So let's just pick another port. And it shows port 3002. Makes sense because our backend is using 3001. All right, so we've started that up. I know we just started this up, but we're going to have to stop it again. And we're going to have to do an npm install Axios. So I'm going to use Axios to make API requests to our backend server. Keep in mind that this is strictly optional. If you want to use the fetch API, feel free to use that, but I just think it makes it so much easier when you use Axios because it just kind of formats everything nicely for us. And once Axios has finished installing, we can start up our front-end server again. All right, so let's set up our API now. And what I like to do is I like to configure my API in a directory called APIs. And that way, if you have an application with multiple APIs, you can kind of have all of them in one folder so that you know if you need to update anything, it's all going to be in that one directory. So we'll do APIs. And then within here, we're going to define our one API that we're using. And you can give it whatever name you want. I couldn't think of a good one, so I'm just going to call it restaurant finder.js. And within this file, we're going to import Axios. So we'll do import Axios from Axios. And then let's export default. And then we'll do an Axios.create. So this is creating an Axios instance. And we're going to specify our, we have to pass in an object, and we're going to specify just one parameter. That's the base URL. So we'll do base URL. And remember, the URL is all capital. And I'm going to set this to the URL of our backend server. So we do http://localhost, right? Because we're running on a local machine. And then the port it's running on. So mine's running on port 3001. If yours is using another port, then just update that accordingly. Okay, and then if we look back at all of our routes, you'll see that every route always starts with API /v1/restaurants. Some have the extra :ID, some don't, but they all have API v1 restaurants. So let's set that to be our base URL. So we can do /API /v1/restaurants. And make sure not to put a backslash here, okay? So now that we've got our API defined, let's go back to our restaurant list. And let's actually tell this component to fetch the data from our backend server. And so we want it to fetch that data as soon as the component mounts onto the screen. And the way you do that is by using the useEffect hook. So let's import useEffect hook from the React library. This is useEffect. And we can do useEffect. And we pass an arrow function. And there's two things that are getting passed in. There's first the arrow function, which is going to contain all the things that we want to do. And then we have to pass in the dependency array. So we're going to pass in an empty dependency array. And the reason for this is when you pass an empty dependency array, that means the useEffect function or hook will only run when the component mounts, and that's it. It will not run ever again. If you don't pass this in, right, if we remove that, then what would happen is it would run when the component mounts, and it would also run every time the component re-renders. And that is not what we want, because that'll probably lead to a loop. So we're just going to run the hook only when we mount the component. And let's import our API. So we're going to do import restaurant. Did I capitalize it? Yeah, well, it doesn't really matter actually. So we'll just do restaurant finder from, and then we need to go up a directory. And then we want to go into APIs and then restaurant finder. And I misspelled that. Okay, and so now within this useEffect hook, we're going to make an API call to our backend. So since we are going to be dealing with asynchronous code, we want to make sure that we use the async await. So you're probably thinking first of all, we want to put it inside a try catch block. So we'll do try and then catch. And this is exactly like we did with the backend. And within here, we're going to say const. Well, instead, I'm going to do restaurant finder. So this is going to reference the API that we defined. So this is an Axios instance. And so what we can do is we can do restaurant finder and then specify the method. So we want a get method. And then we have to specify the URL that we want to go to. And so if you look at the base URL, it's already going to go to this. So to retrieve all of the restaurants, this is the exact URL that we need to go to. So we don't need to change anything. So we can just pass in a slash. Okay. And what this really is doing is that it takes whatever URL I have right here and it's jamming it to the end of this URL. So what the final URL is going to be is it's going to be this full URL. And then it's going to add whatever I just configured here, which is just a slash. So then we just add a slash. Okay. Hopefully that made sense. It was a little confusing the first time I saw that. But it allows us to just not have to retype this whole URL every single time. If we did change this to like a, like a update and then like a restaurant 1, then what would happen is that the final URL would look like this. It would be update and then restaurant 1. So all it's doing is just adding it to the end of this base URL. But let's change that back to just a slash. And we want to store this value or the result inside a value or a variable. So we'll do const response equals restaurant.finder.get. And remember, this is going to return a promise. So we want to use the async await syntax. So we'll do await. And if this is an await, we need to make sure that this arrow function is asynchronous. And let's do a console.log response. And hopefully this works. And you'll see that we got a warning, and I'll explain that in a second. It looks like it printed out something. First of all, we need to stop console.logging on our server. So let's go back there. Let's clean up some of the unnecessary console.logs. And so under this one, we can just remove that. But let's go to our front end. And let's inspect. And you'll notice that, well, first of all, it's basically, we get an error. It's saying that it's being blocked due to CORS. And so this CORS error, what's happening is that by default, when we set up an Express API, our Express server will only accept requests from the same domain. And if you're wondering what a domain name is, think of it as, google.com. So Google is a domain. And then, let's say CNN.com, that's also a domain. So CNN cannot by default send a API request to google.com because they are in two different domains. And they're going to get that same exact error that we're getting here where it says, it's been blocked by cores. And so there's an easy way to get around this. Well, first of all, let me explain why our domain is different. If you look at our server, that's going to be running on localhost :3001. However, our front end is running on localhost :3002. So those are seen as two different domains, right? That's just the same thing as YouTube and Yahoo, or YouTube and eBay, right? Or Google and Firefox.com, right? Those are both domains, so they can't send each other requests by default. So what we have to do is we have to set up a policy within Express to allow requests coming in from other domains, or then we're going to keep getting this error and our application's not going to work. And that's pretty easy to do. So if we go back to our Express server, we can go in right above this middleware, we can add another middleware, and we can do app.use cores. And we actually have to install cores as well. So let's stop our server and let's do an npm install cores. All right, and so now if we start back up our server, then npm start, we also have to import cores. So we'll do right up here, we'll do const cores equals require cores. So we're going to import that library. And now if we refresh this page, the error is gone. And we can actually see the data that we got back. All right, so I definitely recommend that you guys do a little bit of reading on cores. Just know that by default, two different domains can't really talk to each other. Okay, so we've got our data now, and we can see that the way that Axios is going to structure is that it's going to put all the information that we retrieved from our backend within the data property. So under data, there's another data, but that's because we set up our API, right? We set up our API to send it as a property it's a property of data. So we have data. Oh, where'd it go? So we've got data. Then within here, we've got the 6 different restaurants that we have. So things look like they're working now. However, there's one little error that I'm getting and I don't like it. And this warning is saying that an effect function must not return anything besides a function, which is used for cleanup. And so basically the use effect hook that we've defined in our restaurant list component, this use effect hook does not like it when we return anything. Okay. However, if you're looking at our code, you may notice that, we're not actually returning anything. So why is it throwing that error? Well, since we're using the async await syntax, what happens is that we are kind of implicitly returning a promise, and use effect does not like that at all. It does not want you to return a promise. And there's an easier way around that warning. And what we can do is we can define a separate function. And we're going to call this function fetch data. So we'll do const fetch data. And this is going to be an asynchronous function. And all this function is going to do is it's going to take all of this code, and we're just going to put it right in there. Okay. And so now we have to explicitly call fetch data to run that code. So now if we hit save, and it looks like it's still giving me an error. Oh, let me change this async. We need to remove that from the parent arrow function. Okay, and you'll notice that now we don't get an error. And that's because the use effect hook isn't returning anything. Instead, this function that we defined is returning something. And that's perfectly okay. It's okay if our specific function returns something as long as the use effect hook doesn't return anything. So that's a neat little shortcut. So always define a function that then sends all of the API calls, and then just call that function in the use effect hook. And so now that we've got our data, and you can see that here, we need to actually save it someplace. And so we set up our context API for that. We want to store it within the restaurants value. We want to store it right in there. Okay. So let's use the use context hook to be able to do that. And we'll import the use context. So we'll do const. Wait, first let's do use context. And we want to import that. That did not work. Import. There we go. So it imported. And then we have to import our actual context, right? And that's going to be this context right here, restaurant context. And we can import that automatically through VS Code. And that didn't seem to work. I don't know why VS Code is doing that lately. There we go. So we've now imported the context. And now let's store, or let's destructure out the two properties that we want, which is restaurants and set restaurants. All right, and if you guys forgot, that comes from the value that we're passing down. So we're passing down an object that has a restaurants and a set restaurants property. So we're just grabbing those and destructuring them out. Let's also make sure we get our props. And so now after we actually make our API call, instead of just console.logging it, we're going to call the set restaurants so that we can set our state and store our restaurants within our state. So now we can do response.data.data.restaurants. Right? And if you forgot why I'm doing it like that, just take a look at the output. So it's, remember, if we get the response, we want to go into data, and then into data, and then we want to grab restaurants. Okay, let's save that. And so now it should have retrieved that data. To verify if that worked, we can go into components, and let's go into restaurant list, and we can check our hooks right here. So we've got our context hook, and you can see that we are now storing restaurants into there. So so far everything's looking pretty good. In the next video, what we're going to do is we're going to start rendering out the data that we retrieve from our backend server so that we're not hard-coding our tables. So we've successfully stored all of the restaurants that we've retrieved from our backend inside this restaurants state that's part of our use context hook. And so now that we have that data, we can actually go about rendering it into our table so that we don't have to hard code this data. And so what we can do is I'm going to comment out everything in our body. The head is obviously just going to be the header. We don't need to touch that. So I'm going to just take this and I'm just going to comment it out for now. And let's start rendering out that data. So we're going to do a restaurants, which is the array that stores all of our restaurants, and just do a map property. And on this map property, we've got our element that we're iterating over at the moment. And each element's going to represent whatever restaurant that we are iterating over. Or you know what? It may be easier to understand if we call this restaurant. And so we're going to return a TR. And within this TR, we're going to have a couple of TDs. So we'll do TD. And I think there's going to be 6 of them. And so the first one, right, if you just recall, it's going to be the name. The second one's the location, then the price, then the rating, then the 2 buttons. So let's render out the name. So we can do that by doing restaurant, which is referencing this guy right here, and just calling the name property. Then the next one can be the location. So we'll do restaurant.location. Now the price, or the price range. So this is going to be a little bit trickier, right? Because the price range is just a number. But if we go back to my working application, which I closed out, unfortunately, or did I? No, here it is. We actually have to print out $sign. So if it's, if it's, if it has a price range of 2, there should be $2 signs. If there's a price range of 3, there should be $3 signs. So what's the easiest way of doing that? Well, I actually had to Google this. I didn't know this off the top of my head, but what we can do is we can pass a string that has a $, and this should all be wrapped inside curly braces. And so we'll do $, and then what we can do is we can call the repeat method and then pass in how many times we want to repeat. So if we want $3 signs, we could just type in 3. And so instead of actually hard coding a value, we can just reference restaurant.price_range. And I hit save and it looks like I threw an error. I'm wondering what happened here. Line 33. But we'll come back to that. Let's finish writing out the rest of our table. And so after the price range, we're going to have the reviews, which I'm just going to write the word reviews because we haven't implemented that feature. And then let's copy the code for the button. And then the delete button as well. And I just now figured out what was wrong. So remember, when you're doing the map function, we actually have to return JSX. So I'm not actually returning anything. So we'll do return. And we want to take all of this and put it into there. And I clearly messed something up. There we go. All right. And let's go back to our app and see what that looks like. And it looks like it's working already, right? So you can see that, it retrieved that data and it already rendered it out on the screen. However, there's one thing I don't like, and that is there's a chance that we aren't able to retrieve the data quick enough, and it's going to try to render out a restaurant, which doesn't exist. And so if that's ever the case for you, what we can easily do is we can say, if restaurants doesn't exist, if restaurants exist, should we then run the rest of this code? And there's an easy way to do that. We can just type in restaurants and then just do an and. So what this means is that if restaurants exist, which means if we've successfully fetched our data and stored it into our context, we will then run the rest of this code. However, if restaurants is undefined, we will not run the rest of this code. All right, and so everything's looking good. Let's check our console to see if there's any errors. And yep, we always have to pass in a key. So let's get on that. And so within this tr, I can say key equals, and we can pass in restaurant.id because that's a perfect key for it because we just need it to be unique. Okay, and so all warnings are gone. We've now successfully rendered our data onto the screen. So guys, I think we've made decent progress with the restaurant list component. And I want to take a break from here because the last two things that we have to implement is the update and delete. And I want to come back to that. So what I want to focus on now is the add restaurant component. So let's go to our add restaurant component. And the first thing that we have to do is we want to make sure that all of the inputs that we have, right? We've got, 1, 2, 3 inputs. We want those to be controlled inputs because by default, HTML manages the state of a form. However, React wants to maintain all of the state in the application. So we're going to make these controlled inputs, and it's really easy to do. We're going to just use a couple of use state hooks. So first of all, we have to import use state. So we'll let VS Code do that. And it keeps messing up. It's not doing it. There we go. Use state. And I'm going to set this to an empty array. An empty string. And so we're going to do const. And then this is going to represent the name or the name input field. I'm going to do set name. We're going to set that equal to use state. So that state is going to manage the state of this input text field. They're going to do one for location and then one for price range. So let's copy that, paste it down. It's going to be for location and set location. And then finally, we're going to have one last one for price range. So we'll do price range and then set price range. All right, and to make these controlled inputs, let's go to our input and let's say the value equals the value. This one is going to be for the name. So we're going to set it to name. And we're also going to set an on change event handler. And we're going to say the event. We're going to then set name to e.target.value. And we're going to do the same thing for pretty much all the other two components or the other two input fields. So let's go down to the location one. Paste the same thing in, except just change this to location. And change this to set location. And then finally, we're going to do the same thing for the price range. So let's go to this select component. Value is going to be price range. And we're going to change this to set price range. All right, so let's take a look and see if we broke anything. So if I start typing something, okay, things are looking good. And we can actually go to our React developer tools, go to add restaurant, and you should see the state get updated accordingly with what you inputted there. Let's go to location and just type in. Yeah, that's not working. Oh, it's just my keyboard being slow. So New Haven, okay, that gets updated accordingly. And you'll see that it's picking this $1 sign as a default, but I wanted to say price range. I don't want it to start out with the $1. So what we can do is change this to price range. And I think that should set the default value. Yep, so now it starts out saying price range, but it's still disabled, so you can't select it. So now then we can then go in and select it. But everything else looks good. Our form looks good. It is now time to actually implement the logic of basically sending a post method back to our backend. And so what we want to do is let's go to our button, and we want to set a on-click event handler. So first of all, this button's going to be a type of submit, so it's going to submit the form. And we're going to set an on-click. You could do an on-click event handler on the button, or you can go to the form and then do an odd submit, but both are going to do the same thing. And we're going to define a function called handle submit, and we'll define that right above here. We'll do const handle submit equals, and there's going to be the event object that gets passed into this function. And the first thing that we want to do is anytime we submit a form, the default behavior in HTML is to reload the page. And you'll know that with React, you never ever want to reload the page. Reloading the page will lead us to losing our state. So instead we want to do e.prevent default. So this is going to prevent us from reloading the page. And then we can now just put in the logic to handle submitting this form. So we want to import our restaurant finder API. So let's do that, and that's going to be import restaurant finder equals, or not equals, from ... then go into APIs and then restaurant finder. And so here we'll do a try block. And let's make a, let's do restaurant finder, except instead of a get method, we're going to do a post because we're sending data back. And if you recall, our route for creating a new restaurant is a post route. So we want to do a post method. We'll do restaurant.post. And now the URL, we want to go to slash, and then yeah, just slash, right? Because if we go once again back to this server.js page, it's just API v1/restaurants. And if we take a look at our restaurant finder, that's already there, API v1 restaurants. So we're just going to send a post to the same exact URL, and that should allow us to add a restaurant. And now for Axios, we have to pass in some more data, right? We want to pass in the data that's in our body, which in Postman, right, we were able to just go into the body field. Let me find our post, yeah, and then add that data. So we actually have to do the same thing here. And so we're going to take an object. This is going to represent our body. And we're going to say we're going to give the name property, and that's going to be set to this name, which is going to hold the value of that input field. We can do name, then we do location, and then price underscore range is going to be set to price range, right? Because our backend is expecting us to be calling it price underscore range. However, we're storing it as price range up here. But for these first two, it's name, location. So we can shorten it to just that and that. So let's do well, first of all, we have to save the response. So we'll do const response equals, And since we're returning a promise, we want to use async await. And we want to make this an asynchronous function. So let's do console.log and then response. Hit save. And let's give this the test. So we'll call this Hardee's. And this is in Tampa. Price range $3. Add. And we got a response back. We got 201, which means it was successful. And if we go to data, restaurants, you can see it was given an ID of 9, Tampa, Hardee's, 3. Awesome. So we've now created, or we've now added an entry into our database, and we can actually verify that. Always good to check yourself. And so now we can see that new entry. All right. And so once we add, or once we've created, or sorry, once we've added that new restaurant, we need to update the UI accordingly, because if you look at our UI, there's no Hardee's here. And so there's a couple ways of doing this. I think the easiest way is to go back to our context API and define a function for adding a restaurant. And so we'll say const add restaurants, and we'll pass in the newly created restaurant. And we'll just say set restaurants. And basically what we're going to do is we're going to take the current, all the current entries in our restaurants array and copy it over to this new array. And then we're just going to add the new restaurant. And we want to make sure we pass this down so our components can use this add restaurant function. And now let's go back to our add restaurant component, and we can do a, well, we have to import that from the context API. So we'll do, we have to import a few things actually. We'll do const, and then we want to destructure out add restaurant. We want to use context, make sure that gets imported. And then we have to import the restaurants context. All right, and so now we can do a add restaurants because we have access to that function, and then just pass in response.data.data. Hopefully you guys understand why. I don't have an example, but that's where we store our new restaurant that we retrieved back from our API. So let's give this a shot. I'm gonna add a new restaurant. We'll call this Chipotle. And this is going to be in Virginia. I know that's not a city. And then $1. And it looks like there was so it looked like that didn't seem to work because we didn't actually add it in there, and it should have added it in there. So let's take a look at what may have happened. And I already know what went wrong. So if we go back to add that, yep. I'm going to take that out for a second. Let's just save that and just make sure we understand what this response looks like. And we don't want response.data.data. We want response.data.data.restaurant. So we forgot to add the .restaurant. Now we'll add that. I mean, you'll see we have a couple of extra restaurants, so we can, we'll leave those in there for now, but let's create a new restaurant, and we'll call this California Pizza Kitchen. And this is going to be in Vegas. $1. And I'm going to close out my console for now. Hit add. And once again, it doesn't look like it seemed to work. And I forgot to do a save all. I think that's what broke it. I didn't do a save all. So now let's do an add. Let me refresh the page. just going to type in some dummy data. I'm tired of typing in things. To add. Still not working. Let's see what may be causing this. And it looks like I found out where I messed up. Under the add restaurants function within our restaurants context, this should be there should be an S, so it should be restaurants. And I think that's what was breaking our application. So now, I mean, we've got a ton of restaurants, but let's just add a new one. Call this Burger King. Location, Santa Clara. Price range, $1. Let's hit add. And looks like there's an error. So let's take a look and see what may have happened. Okay, guys, so I see our mistake. If you take a look at the data that's being returned from our server, you'll see that it's returning a property of restaurant. So I forgot to put an S in our API response. So let's go back to server.js, find our post, and just change this to restaurant. That little typo was causing all sorts of issues. There goes 10 minutes of my life. So I think if we save that now and do a refresh, this should work, hopefully. I mean, now I've got a ton of restaurants, but let's just type in just whatever. I don't care anymore. And there we go. Add. So let's see if that last one, perfect. So we've got the new restaurant that we just added at the bottom. All right, so we've now successfully implemented the add restaurant finder or the add restaurant functionality. I know it took a little while because I kept, fat fingering a whole bunch of things, but I think we're good to go on that end. So in the next video, we'll start implementing the update and delete functionality. Okay, so now it's time to work on implementing the delete functionality. So let's make it so that when we click on this red button, we can delete a restaurant. And this is fairly easy to do. If we go down to our restaurant list component, we want to find our delete button right here. Okay. So we're rendering out a delete button on each row, and we want to put a onClick event handler. So this function is going to be responsible for handling the logic for deleting a restaurant. And so I'm going to call this handle delete. And we can define this right below the use effect hook. So we'll do const handle delete equals. And we need to actually pass a variable up to this function, right? We need to know what's the ID of the restaurant we're trying to delete. So we have access to that by calling restaurant.id. So we can do ID, whoops, not ID, restaurant.id. So we're going to pass that into the function. However, if you're going to pass an argument into the function, you have to make sure that you do this, okay? And so that way we pass a arrow function into the onClick event handler. Because if we just leave it like this, what it thinks is happening is that you want to run this code right away. And we don't actually want to run the handle delete function. We only want to run it once the button's actually clicked. So we have to pass a reference to a function and not the function itself. And so we can just do that by just passing that arrow function. All right, and so now we pass in the ID, and we can now handle the logic for deleting a restaurant. So we're going to do a try-catch block as usual. And this function is going to have to be asynchronous because we're going to have to make a call back to our backend server. And let's import our restaurant finder. So I'm going to see if VS Code will do that for me. So restaurant finder. And now if we go up, we should have restaurant finder. Or I guess that was already imported, so we didn't have to do that. And we're going to call the delete method, right? And what's the URL that we want to go to? Well, the only way to verify that is going back to our server.js and going to delete. So we want to go to /API/v1/restaurants and then colon and then the ID. Moving back to our list component, we can then just do slash and then, well, we have to do a template string so we can pass in the ID. So we'll do slash and then $ID. Okay, and the reason we only have to do slash and ID is because once again, the restaurant finder API goes all the way up to restaurant. So we're just doing slash and then ID. And we're going to do await, and we're going to store that into a variable called response. Let's save that. And let's do a console.log response real quick. So let's delete Wendy's, or let's delete one of these unnecessary ones like this one. Okay, and so we've got a status code of 204, which means it most likely worked, and there should be no data that get returned because we're deleting something. However, our UI has not been updated though, because the restaurant that we deleted is still exists within our restaurants array. So we have to remove it from our restaurants array. And that's actually fairly simple to do. So we can just call the setRestaurants function to update that array. And what we're going to do is we're going to call the filter method on the restaurants state. So restaurants.filter. And then we'll pass in restaurant as we're iterating over it. And we're going to say that we're going to return restaurant.id does not equal ID. Okay, and so looks like I've got an error. Just need one more closing brace. So let me explain what the filter method does. When we return something, if this equals to true, we're going to add that restaurant that we iterated over back to the restaurants array. So what we're saying is that when the restaurant ID does not equal the ID that we're trying to delete, we're going to add that to the array. And when they do match, we're going to make sure that we leave it out. So that's how we delete a specific restaurant with a specific ID. Okay, so let's give this a shot. I'm going to try to delete burger. Let's delete this one with the numbers. Delete. And it seems to be gone. Let's delete this one. Looks like it's working. Let's delete Burger King. Sure. Let's delete this one. I'm just going to keep deleting that. We just have too many entries, so I'm going to delete this ASDF. And yep, things look good. Let's go back to our database. Let's just make sure it's actually deleting them. And we should have about 1, 2, 3. Yeah, it looks about right. Yep, sounds good. So we've got the delete functionality in place. I think that's all we should have to do for deletion. One other thing that we can add is let's just do a console.log here just to print out any errors just in case. All right, and so in the next video, we'll start implementing the update logic, the update restaurant logic. Well, we actually won't implement the logic for updating. We're just going to handle the routing because if we go back to our original application, right, when you update, it doesn't actually update immediately. Instead, it takes you to this new page. So what we have to do is actually set up the routing to route towards the update page, and then we can start implementing the logic for that. Now, looking back at the completed project, when the user hits the update button, it's going to take him to a new page. It's going to take him to the specific URL of restaurants, then the ID of the restaurant he selected, and then update. And so we need to set up the routing in our app so that it routes it to this specific URL when the user hits the update button. And the way to do that is we have to first grab, and the way to do that is by accessing the history API, which is part of React Router. And we can do that by using one of the hooks that comes with the React Router DOM library. And so we can do let history, and we got to use let because we're going to be modifying the history. And we use the use history component. So let's import that. And so this history this history object represents the history of our browser. And so now if we go down to our update component, which is right here, which is this button, we can set an on-click event handler. And this is going to look fairly similar to the on-click event handler for the delete restaurant. And so we'll pass an arrow function and then say handle update. and we need to pass in the restaurant.id because we need to know the restaurant, or we need to know the ID of the restaurant so that we can add it to the URL. And we can define our event handler down here. We'll do const handle update. I'm going to pass in an ID. And here, what we need to do is we need to tell React Router to navigate to the /restaurants/ID/update URL. How do we do that? It's pretty simple, actually. So we just do history.push. So we're adding this URL into the history stack. And we just do, well, we're going to have to do some string interpolation. So we'll do /restaurants/ and then $, and then ID. So we got to pass in the ID and then update. So let's hit save and, oh, what happened? Rest or line 61. What did I mess up? Oh, restaurant. Okay, and let's go to our completed app, which is right here. I don't need this window anymore. Or this is our current app. So let's just refresh just in case. And if we click on Wendy's and hit update, there you go. So it went to the URL of restaurants and then the ID of Wendy's, which is 1, hopefully, and then update. And you see it says update, and that's because if we go back to our app component, right? If you look at our router, we have a route for /restaurants ID and then update, and it's going to load the update page component, which at the moment is fairly empty. So let's start styling our update page. And we're going to create a separate component for this update page called update restaurant. But first, we're going to render out an H1. And this is going to have a class of text center, just to center the text. And this is just going to say update restaurant. Okay, so let's hit save. And so now it says update restaurant. And let's create our new component. And I'm going to call this update restaurant. And so the first thing that we need to do within this component is actually figure out what restaurant we're trying to update. And we can easily grab that information from the URL because we've embedded the ID into the URL. And so that's really why we did it. And React Router has a hook for that, and it's called the use params hook. So we do use params. And make sure you import that. And let's just do const test. I'm going to store it in a variable called test, and let's just do a console.log of test. Okay. So if I hit refresh, the console.log did not work. There we go. And it's still not printing, so let's see what we broke. Oh, that's right. We actually have to load the, where is it? The update restaurant component within our update page. So I'll just load that right here. Update restaurant, import that. Now, if I hit save, it should print out the parameter. So here, React Router is going to pass in all of the parameters that are in the URL. And so now we can access that fairly easily just by calling use params. And we're going to destructure out ID because there's only one, but if we do have more in the future, all we really care about here is just ID. So let's destructure that out. And also make sure you pass in props as well. And so we're going to destructure out ID. So now we have access to the ID. And within this component, if we look at the final app, we're going to have 3 fields, one for the name, location, and price range. This should have been a dropdown, but I think I got a little lazy, so we'll just keep it like that. But in an application, you probably want this to be a dropdown as well, so that a user doesn't type in some characters or anything like that. Anyways, let's go set up this form real quick. And here we'll do a form, and then, whoops. In the form, we'll have a div with a class of form-group. And then here we're going to have a label, and that's going to be for name, and it's going to be called name. And then we have our input. And the ID for this is going to be name. And classes that are going to get added are form-control. And we're going to copy this whole thing from form-group and just paste in for the next one. This one's going to be for location. And just make sure we update everything else accordingly. And let's copy this one more time. And we'll change this to price range. And let's change this to a number. Oh, that's a little bit better. What happened here? Test is not defined. No, we gotta delete that. So this is a number, not a big deal. And I think there's going to be one more thing that we have to add, which is the button. So outside of that last div, we want to add a button. And this is going to say submit. And let's add the usual buttons, or the usual classes for button, which is going to be btn and btn-primary. Okay, so we've got our form. The next thing that we have to do anytime we work with forms within React is make this a controlled form, make all the inputs controlled. So we're going to have to define state for each of the inputs. We'll do const name and then set name, which equals use state. Don't forget to import that. And now for these input fields, we'll set the value equal to name here. And we want to set an on change event handler. Okay, and so everything's working. If we check our components, and go to update restaurant, we should see these states get updated accordingly, and it looks like they are. Now, when we go to the update page, if we go to the final application, you'll see that it loads in the data already. So if we click on like Red Lobster, hit update, it already loads the name, the location, and the price range, which is good for user experience. And so I think we should do the same thing with our application so that the user can just change whichever specific field he's interested in updating. And so now we actually have to retrieve that data. So technically we have that data stored in our context, right? So we've got it stored in our context API, and we can use the use context to retrieve that data. However, that's going to create one problem, and I'll show you why. And what I'm going to do is in this div, I'm going to just pass in an h1 tag, and I'm going to call the use context hook. So we'll do const restaurants. And then set that equal to use context. Import that, and then we'll do restaurant context. And let's just grab restaurants. And let's just grab the first restaurant in the array. And then we'll grab the name. And we gotta make sure we wrap these in curly braces. Okay. And so let's go back to the list, our homepage, and let's click on update on Wendy's. And you'll see that it says Wendy's. So it looks like it's working, and so we could technically use the use context because we already have all the data for all of the restaurants. But I want to show you why this is bad. And that's because let's say a user bookmarks this page, the update page, right? And so if we open a new tab and navigate directly to there, look what happens. We get an error. And that's because the list, the homepage with this restaurant list is what's responsible for fetching the data from the API. So if we go directly to this page, we never had that restaurant list component fetch the data from our API. And so there is no restaurants. So it's just basically saying, oh, you can't access a name property on what's, is undefined at the moment. And so that's why I don't want to use the context API in this case. Instead, what I want this component to do is fetch the data for that specific restaurant so that even if the user navigates directly to this URL, where'd it go? To this URL, to the update URL, it should automatically fetch the data so that we aren't reliant on having to go to the home page first and then clicking update. So once again, we're going to use the use effect hook to retrieve that data. Go to use effect. Let's import that. And just like before, we're going to define a function called fetch data. It's going to be an asynchronous function. Going to move a little bit quicker on this one. And we're going to do const response equals await. And we need to import restaurant finder. So I'm going to let VS Code import it for me. And then we'll do a .get. And the URL that we want to get is going to be / and then ID. Right, so we're going to navigate to restaurants /1, right? So that's going to give us information about that specific restaurant. And let's do a console.log and then response.data.data. Okay, so let's go here. Let's select update and let's do a console. Nothing printed out. That's no bueno. Let's try that again. Oh, we got an error. What happened here? Cannot read. Okay, same error. Let's remove this line right here. And I realized we're not actually calling the fetch data function, so that's why it's not actually trying to retrieve that data. So we do fetch data. And don't forget to pass in the empty dependency array so that we only run this when the component mounts. And so now you can see that we get the restaurant. Perfect. And so with this data, what we can do now is instead of just console.logging it, I'm going to set the values of our input fields to the values that we just retrieved. So we can say set name, and that's going to equal response.data.data.restaurant.name. Right, and so that's coming from here. And then we're going to do the same thing for location. And then finally for price range. And I think it's going to be called price underscore range, but we can just double check here. So it's price underscore range. Yep. And it looks like it's going to throw an error, cannot read property of name. And I wonder why. Let's run this again and see what the output looks like. And once again, if you guys didn't notice, I misspelled restaurant on our API. So we're going to have to go to our server.js and go to, let's see, where is get a restaurant, and then just change this to restaurant. And now if we go back up to our update restaurant, hit save, so we refresh. And so now look at that. It loads up Wendy's, New York, and 4. And so even if we go directly to this link, it should work. If we go to, I need to get an ID of another one. Looks like we've got one with an ID of 14. So if I just change this to 14, this should load up California Pizza Kitchen, and it did. Okay, so we've loaded up that data. Now we actually have to implement the logic for submitting the data. So let's go to our button and let's do a on-click event handler. We'll do handle submit. And as usual, this button is going to have to be a type of submit. And when we submit something in React, remember we want to do the e.prevent.default. So e.prevent default so that we don't accidentally reload the page. And make sure we pass in the event object into that function. And so now we need to make an API call. And so this is going to have to be an asynchronous function. And we can do const updated restaurant equals await, and then we'll call our API object, so restaurant finder.put, right? Because now we're updating and we have to pass in a put method, and we'll do string interpolation, and we'll do ID. So remember, we have the ID stored right up here from use params. And let's do a console.log of updated restaurant to see what that looks like. And one mistake, we actually have to pass the data back to our API. So we'll do that. And then here we're going to pass in the name, which is going to reference this value, which is whatever value is stored in our text input. And we're going to pass in location. And then finally, price underscore range is going to be set to price range. Okay, so now let's just change the city from Vegas to New Orleans, and let's change the price range to 2. So let's hit submit. And so we've got a status code back, status of 200. So it looks like it worked. And let's see if it gave back the new restaurant. So same ID, New Orleans, price range of 2. And we can just double check by going into Postgres and checking that as well. And yep, there you go. The city got updated to New Orleans. So our update functionality worked. However, after we update a restaurant, it just doesn't really make sense to stay on this page. Instead, it probably makes sense to send the user back to the home page. And that's pretty easy to do. So we already worked with the history API to send us to this page. We can use it to send us back. So let's import history. So let history equals use history. And once again, make sure you import it, right? And now we can just do a history.push. And send it back to slash. So let's go back to the home page and let's see the entire workflow. So we'll go to update. We'll update Wendy's, and this is going to be what's the city? Lincoln. So let's hit submit, and it takes us back. And so let's check Wendy's, and it got updated to Lincoln. And that's perfect. And the great part about the history API is it gives us the we can basically use our back button like we normally would on any website. So if I wanted to go back, it's going to take me back to the update page for Wendy's. And if I go back again, it's going to take me back to the original page. So that's what the history API allows us to do. We get, the forward and back functionality as well. So it's going to make our single page app operate a little bit more like a traditional multi-page application. And so that's going to wrap up the update restaurant portion of this app. And I think we're almost done with the first half or the first 3 quarters. The last thing I want to do is implement the detailed page. So if you click on, this link, it should take us to the detailed page. And right now, I guess 90% of this page we aren't going to be able to implement yet because we have to implement the rating system. But for now, we'll just load up the name of the restaurant. So to wrap up the first half of this course, the last thing we need to do is implement the detail page. So when the user clicks on the detailed page, or let me go to the finished app, of course. So when the user clicks on one of the restaurants, it's going to take us to a detailed page about the restaurant. It's going to include all the information about the reviews and also give us the ability to create new reviews. We haven't implemented a review or rating system yet, so we won't be able to render out any of that data, but we will be able to, for now, handle the routing so that when the user clicks on a restaurant, it's going to navigate to the URL of restaurants and then 5. And what's more important is that if we copy this URL and go directly there without selecting, without actually going through the list page and then selecting it, it should be able to fetch the necessary data. So just like the update component, we want to make sure this component or this page is independent of the list page. So we don't always have to go to the list page first and then select it. A user can bookmark this page, and then when he navigates to this page, this component will then fetch the necessary data based off the ID that's assigned in the URL. And so that's going to make each page completely independent of one another, and that's good practice when building a React application. And so, let's get started on setting up that on-click event handler. And we're going to set that on, if you go to restaurant list, we want to do it on the table row. So we'll do on-click equals, and then we're going to call this, first of all, we're going to have to pass an arrow function and then do handle, I think it's restaurant select, and then we want to pass in restaurant.id. And then we can define our route handler or our event handler. So const handle restaurant select, pass in the ID. And here we can just do a history.push like we've done before to send it to the new URL. We already have access to the history object. So history.push, and then what's the URL we're going to send it to? Well, we need a template literal. We're going to send it to restaurants / and then we're going to pass in the ID. So let's give that a test. And so now if we select Taco Bell, it should take us to the detail page, which is exactly what we want. Now, before moving any further, by doing what we just did, we have effectively broken the update and delete functionality of our application. And so if we hit update, check what happens. It takes us to the detailed page. And that's because the on-click event handler is assigned to the entire row. So when you put it on the entire row, it doesn't care if we, sent it to, if we selected the update or the delete button, it just thinks we clicked on the row and it's going to take us to the detailed page. However, if you hit back it then takes us to this list page. So it's essentially ignoring these buttons. And there's an easy way to fix this. So if we go back to our restaurant list and go to handle update and handle delete, all we want to do is when the user clicks on either the row or the update button or the delete button, it's going to trigger an event, an on-click event. And so when we click the update, it's going to trigger a on-click event on the button. But what's going to happen is that event is going to get propagated up from the button all the way to the table row. And we want to prevent that. So when the user clicks handle update, all we have to do is, well, we have to pass in a couple of things. First of all, we have to pass in the event object. So we pass in E for the event object. And when we actually go to handle update, we also have to pass in E as well. We do E. I know it's a little confusing. And we want to do the same thing for the delete. We're going to pass in E as well. So E is our event object, and we're going to pass in E there. And so for both the update and the delete, we're going to do E dot stop propagation. All right, and so that way, when we click on the update button, we're not going to send that event up to the table row. So it's never going to actually hit the history.push function. And we're going to copy this and make sure we put it on our handle update as well. Okay, and so now looks like we broke something. Let's just hit save again. What did we break? Okay, I don't know what just happened there. That was weird. But if we click on, Hardee's, it's going to take us to the detailed page. If we click on update, it takes us to the update page. And if we click on delete, it should delete it. All right, so that fixed that issue. So now the last thing that we have to do is under the detailed page, let's fetch the data for the restaurant and just load up the name for now, because that's the only data that we care about at the moment, because we haven't set up the reviews yet. All right, so just to wrap up this detailed page, let's fetch the data for the restaurant and render it out onto the screen. So the logic for this is going to be fairly simple to what we did with the update restaurant. We're going to have a use effect hook to retrieve that data. And so let's go to our, where is it? Restaurant detail page. And I'm not going to create a separate component. I'm just going to put all of the logic, within the route or this detailed page just to keep things simple. And so just like we did before, we need to get access to the ID. So we'll do const destructure out the ID and use the use params hook from the React Router library. And what I want to do is actually, when the user selects a restaurant that he wants to see information for, I want to create a new state in our context called selected restaurant, so that the rest of our application knows what the user has selected. So let's add that in here. I'm going to call this selected restaurant. And then we do set selected restaurant. And the default value can be anything. I can just put an array. It doesn't really matter for now. The only thing that matters is that we pass down both selected restaurant as well as set selected restaurant. And so moving back to our restaurant detail page, we want to use the use context hook. We'll do const, and then let's destructure out all of the properties that we want. So we want selected restaurant as well as set selected restaurant. And then we want use context. And then let's import our context, which is called restaurant context. And yeah, make sure to import it. I'm automatically importing it through VS Code. Okay, and so now we can define our use effect hook. So we'll do use effect, pass an arrow function, and we're going to define a function called fetch data. Could be an asynchronous function. And we'll do const response equals await. Now we got to import our API. And this is going to be a get method. And we're going to send this to, let's do a template literal. So this is going to be slash, and then we want API, we want just $, and then ID. Okay, so we're just going to go to slash ID. And we're going to then call set selected restaurant. So we're going to update our global state so that we can tell the rest of our application what was the selected restaurant. And we're going to say this is set to response.data.data. Actually, before we do that, let's actually take a look at the response first. And that did not do anything. So what happened? Oh, we never called fetch data. I always make that mistake. So fetch data. And don't forget to pass in the empty dependency array. So our response is going to be data, data, and then we want to grab restaurant. We'll uncomment that and do .data.data.restaurant. Let me make sure I spelled restaurant correctly this time. Yep. And with any API call, we want to wrap this in a try-catch block. So we'll move all of these up there. And we can remove the console.log and console.log any errors. And so basically the purpose of this was to retrieve the data of the restaurant and then store it inside this, this state variable. And once we do that, we can render it out. So for now, let's just render out the name. So we can do, what is it? Selected restaurant dot name, which is all we really care about. So I'll hit save. And you can see it says Taco Bell. But remember, what I like to do is, just in case, we haven't retrieved the name yet, we don't want the application to throw an error. Instead, we just want to wait for it to load. So we can do selected restaurant and that. So that way, only when selected restaurant is defined will we then render out the name. And I realized I'm going to change this to a null. The default value is going to be a null. And that actually broke our application. Why did I do that? Let's see. Yep, I just forgot to hit save all. All right, guys, so that's going to wrap up our detailed component for now. And so in the next section, we'll start tackling the ratings and review system. All right, guys, so now it's time to get started on building out the review and rating component of our application. And if we take a look at our completed app, we can see what the requirements are for the reviews and ratings. And under the restaurant list component on our homepage, you'll see that we list out what the average ratings is for each restaurant. And we also have the total number of reviews for the restaurant. And keep in mind, the way that the average rating works is that, if it's 2 stars, it's just going to color in 2 stars. But if it's anywhere between like 2 and 3, we're going to just fill in half a star. So this could be anywhere from 2.1 through 2.9. And if we click on the restaurant, we're going to see the detailed page. And once again, we're going to have that same star component right here. And that's going to show us the average rating and the total number of reviews again. And then within each review, we've got this nice little card that we're going to use from Bootstrap. And a review is going to contain 3 properties. It's going to contain the name of the user that wrote the review, what their rating was, and we're going to use a star component again. So this component we're using 3 times in our application. So this is going to be a good example of how we can reuse components within a React application. And then finally, we've got what their actual review was. And the last thing that we need to do to implement the review and rating system is being able to add a review. So we've got this add review component, and this is just a simple form where the user puts his name in, his rating, and then what his review was, and then submit it, and then that should be it. All right, so that's all we have to do for the review and rating system. It looks fairly simple, but there's actually a lot of work that we need to do. So in the next video, we'll get started on updating our database to accommodate the reviews. So now that we're implementing the reviews feature, we basically have a new subject or entity within our application. Till now, all we were working with was restaurants, but now we have reviews. And just like we did with restaurants, we have to create a separate table in our Postgres database to represent or model the reviews in our application. So let's get started on that. And I'm going to pull up our command line again. So if you already closed this out, just connect back to your SQL database or your Postgres database. And let's figure out what are the different columns we'll need for our review component, right? And so, like I said before in the previous video, there's three main properties for a review. We've got the name, we've got the rating, and we've got their review. So, this is going to be a text. We're probably going to do a varchar with a max limit of certain characters because a name should only be so long. Probably just do 50 like I normally do for everything else. The rating, that's going to be a number. And since the rating can only be between 1 and 5, we're going to want to put a constraint to check and make sure that it's always between 1 and 5. It's always good to add these extra constraints into Postgres so that we get some safety in our application so that, if for some reason the user was able to submit a value of 7 or something, we're always going to reject it. And then finally, we've got the review. And the review can be as long as you want it to be. And I'm sure you guys have seen some Yelp reviews that look like Harry Potter novels. So we're going to allow unlimited characters for our review. And so we're going to use a type of text, which is going to allow us to have as many characters as we want. So let's create a new table. And hopefully you guys haven't forgotten how to do that. It's very simple. It's create table. And we're going to call this table reviews. And I'm actually going to write this out on a file so that if we need to make changes, I can just copy and paste it. So we'll do create table and then reviews. And the first thing is we need to have that ID, right? That unique ID that's going to be generated by the Postgres database. So we're going to do ID. And this is going to be big serial, so it's going to automatically increment. And remember, this needs to be, this is a required field, so we're going to do not null. And this is also going to be our primary key once again. And so this is what we're going to use to uniquely identify any review. That's what the primary key does. Now going to the second column, we need a name. So this could be the name of the user that's submitting the review. And this is going to be a varchar of 50 characters. And this is going to be not null as well, so it's required. Then we get the body of the review. So I'm just going to call this review. It may make sense to call it like body or content, but I'm just going to call it review for now. And this is going to be a type of text, so we get unlimited characters, and this is going to be not null as well. And then finally, we have a rating. The rating is going to be an int. And we want to put in a constraint to make sure that this integer is between 1 and 5. So we can do check, and we can say rating is greater than or equal to 1, and rating is less than or equal to 5. And then we'll put a semicolon and copy this and paste it into our terminal. And let me make sure I delete all of that. And it looks like, oh, it says that I already have a table called reviews, and that's because I was doing a dry run before I started recording this video. So let me drop that table and paste that in again. It looks like it's giving me an error, so let me check on that. Let me drop this table real quick. And actually, I just realized, guys, I actually forgot to make this not null. And so now I think if we try this now, it should work. There we go. And let's do a /d And let's see all of our tables. So we've got restaurants and we got reviews. And if we do a /d for reviews, we should see that we've got our 4 different fields. And we've also got our constraints. So let's add a review into our table just as a test. We'll do insert into reviews, and we're going to pass in the name, the review, and the rating. Okay, so we've inserted that, and we can do a select star from reviews, and we can see we have our entry. Now, I'm sure while you're looking at this, you probably see an issue, right? Because right now, this review, it doesn't seem to be associated with an actual restaurant, right? How do we specify a review is associated with a restaurant? Because when we go to our application and we click on a restaurant, we should see the reviews just for that restaurant and not all reviews for all restaurants. So there needs to be a way for us to say that this review is associated with a restaurant that exists within our restaurant table. And so to explain that, I'm going to pull up my slide deck real quick. And so right now, this is what we have. We have 2 separate tables in our Postgres database. We've got our restaurants table. It's got its ID field, which is the primary key. So this is what's going to make it so that each restaurant is truly unique. And then it's got the name, location, price range, yada, yada, yada. Then we've created our new table, which is going to be our reviews table. And you'll see that once again, this one also has a ID field. And this is going to ensure that each review has a unique ID, and so that's going to be the primary key. So now we need to find a way to associate a review with a restaurant. And to do that, we're going to use something called foreign keys. And the way that foreign keys works is that we create a new column in our reviews table, and we're going to call that restaurant ID. And this is going to represent the ID of the restaurant that it's associated with. And so when we set the foreign key, we then have to specify what table we want the foreign key to be associated with. So we specify restaurants, and then what column it should be associated with. So the ID. So this column here is going to have a foreign key of the ID column within the restaurants table. And so this review with an ID of 11 that was written by Karen is going to be for the restaurant that has an ID of 101. So this 101 is going to match up with the ID that's listed here. So she wrote a review for this McDonald's. And then Jim, he wrote a review for the restaurant with the ID of 212. And so this ID, if you just take a look at the restaurant table, is this restaurant right here, which is for the Pizza Hut. It's a very simple concept. And, this is going to allow us to create a one-to-many relationship so that, one restaurant can have hundreds of reviews, right? So all we have to do is just, if someone wants to write a review for Pizza Hut, we just add a new review, and that's going to get a new unique ID, but the restaurant ID is going to be 212 for that entry. And so that's how we establish a relationship between 2 different tables in a Postgres database. So for now, what we're going to do is I'm going to drop our review table so that we can make a few changes. We could modify the table or alter it, but I don't want to confuse you guys, so let's just delete it for now and just create a brand new table. So we've dropped that table, and if you want to learn about foreign keys or anything about Postgres, always go back to this site. So if you go to the home page, what I want you to do is just do a Control F and just search for foreign keys. And we're going to scroll down. It's going to give you a nice example. And you'll see that this is kind of how you define a foreign key. So you specify the table and the ID, but I'll walk you through this. But if you do want to read up on it, feel free to just go to this page right here, and it's going to explain everything with a nice example. So now what we're going to do is we're going to modify this just a little bit, and we're going to add the restaurant ID, restaurant underscore ID column. Okay, and so this is going to be a integer or a big int because that is what the column for the restaurants table is. So if we do a /d restaurants, you'll see that the ID is a big integer. So we're going to want to match that. So we'll do big int. And then now we have to specify the foreign key. And to do that, we just type in references. So this is going to basically tell Postgres that this column references a column in another table. And so we have to specify what that table is now. So we do restaurants, and then we have to specify what column we want to reference. And so once again, right, we care about the ID column in the restaurants table. But technically we can reference any column in the table, but usually you want to reference the primary key of that table because that's what's going to make sure that it's a unique entry. So here we'll then pass in ID. And now I'm going to copy this. And actually one more thing, guys, this is an absolute requirement. We need to have a restaurant ID associated with this review. So we want to make sure we do not null. All right, let's paste that in. That was not what I copied. I don't know what just happened there. Ugh. And I made a mistake. This not null should be after the type. So big int not null then references restaurants ID. And I made another mistake, guys. I'm sorry about this. We want to add the comma at the end. There we go. We've got our table. So let's do a /d reviews. And we can see we've got the new column. We can see it's a not null. And then if you go down here, you'll see the constraint that we added, the foreign key restraint. And it's basically saying there's a foreign key on the restaurant ID, which points to restaurants and then the ID column. So now let's try inserting something into our reviews table. So let's do an insert into. And now we also have to pass in the restaurant ID, the name, the review, and the rating. And for values, we have to pass in an ID of a restaurant. So as a test, I'm just going to put 9,000 because I know there isn't a restaurant with an ID of that, but I want to show you guys that Postgres is going to throw an error if we don't specify a valid restaurant ID. Name, Joanne, look, review, I think, yeah, review's next, so bad restaurant. And then finally, we've got the price, or not the price, the rating. So let's try this out. And I messed that up. We need I forget to specify the tables at the beginning. So now, let's go to the end, add the semicolon. And you'll see that we get an error. And so it's saying that the insert into the reviews table violates the foreign key constraint. And it's saying that a restaurant with an ID of 9,000 is not present in the table of restaurants. So if we do a select star from restaurants, you'll see that there's no restaurant with an ID of 9,000. So that's why it's throwing an error. Okay, so now Postgres is actually checking for us to see if that's a valid ID. So that once again, Postgres is there to help us out. It's going to make sure that we're actually passing in a valid ID. And if we don't, it's going to throw an error. So let's run that same command, but this time let's pass in an ID that's valid. So we're going to pass in, we'll just do 1. And now we've added into the table. And so now we can do a select star from restaurants. Sorry, not restaurants, reviews. And you'll see that it's got a unique ID of 1. And then we're going to reference restaurant ID 1. So this review is for Wendy's. And it's written by Joanne, bad restaurant, rating of 4. So let's add a couple more reviews to this restaurant. And this is made by Mike. And Denise. Okay, so now if we do a select star from reviews, we should see all of the extra reviews. And let's add a couple of reviews for a different restaurant. So let's get Taco Bell. So all we have to do is just change that to a 2. I'm just going to copy the same one over and over again. And then let's change the name Steve. And then finally, Mike. All right, so now if we do a select star from reviews, we should have reviews for 2 different restaurants. So we've got 3 for restaurant 1 and 3 for restaurant 2. And so now, when we go to the detail page and we want to fetch all of the reviews for a restaurant, what we can do is we can do select star from reviews, and we can just say where restaurant underscore ID equals the restaurant that you're interested in. So if we want to see the reviews for Wendy's, which has an ID of 1, we're going to pass a value of 1, hit enter, and you can see the 3 reviews that are associated with the Wendy's restaurant. And so from a Postgres standpoint, when it comes to adding a table or modifying or making any changes for our review functionality, this is all that we have to do. You'll see that we will have to spend some time explaining how certain queries work to get the data that we want, but we don't actually have to make any more modifications to Postgres itself. Okay, guys, so now that we've got our Postgres database set up, I think it's time that we start working on our React components. So there's going to be 3 components that we need to add to handle the reviews and rating system. So if we go to the completed app, you can see that first of all, we're going to have this star rating component. And then if you go to the detail page, we're going to have a review component. So this is going to be a bootstrap card. And this component is going to have a username, the star rating component, as well as the review. And then finally, we need to have a add review component as well. All right, so we're going to start off by tackling the star rating component. It's not too bad, but it's not too bad, and it's going to be a component that we're reusing 3 times in our application. So this is a good example of how we can reuse React components within a application. And so let's go to components, and let's create a new file. I'm going to call this star rating component. And let's just set up the boilerplate. All right, and this component, it's going to receive a prop that's going to represent the rating. Okay, so we're going to pass down whether it's 4 stars or 3 stars or 2.5 stars. So it's going to receive that as a prop, and we're going to destructure that out. And I'm going to call it rating. And within our star rating component, I'm going to define an array. So this array is going to store all of the individual stars. So if you take a look at a rating component, right, there's technically 3 different stars that we can push to this array. We can have a filled in star, we can have a half a star, and we can have an empty star. And if you go to Font Awesome Documentation and just search for star, you'll see how we can create either one of these. So we've got star, we've got the empty star, and then we've got this half-filled star. And so what we're going to do is I'm going to delete the divs. We don't need those anymore. I'm going to do React fragments because we don't want any divs. And then here we just need a simple if statement that's going to have just a couple of checks. So we're going to say if I is less than or equal to rating, we're going to do something. And so when I is less than, oh, sorry, I realized I forgot to create the for loop that we need. So I'm going to create a for loop just to iterate from 1 through 5, or just to iterate 5 times. So we'll do for let I equals 1, and then I is less than or equal to 5, and then I plus plus. Okay. And guys, by the way I'm implementing the star rating system, it probably is not the best way to do it. I am sure there's 100 different ways that are much more efficient to do it, but this is the first way that came to my head, and I didn't want to spend too much time, and I also wanted to make sure that it was simple as possible. All right, so this for loop is just going to iterate from 1 through 5, and what we want to do is we want to set an if statement and say when I is less than or equal to a rating, we want to do a stars.push. So we're going to add a star into our stars array. And the star that we want to push is going to be a full star. So let's grab the full star and let's copy this. And all we have to do is just take that and copy that. Okay, and hopefully you guys understand what's happening. So if we pass a rating of, let's say, rating equals 4, so when I is 1, so the first run through the loop, I is going to be less than rating. So yeah, we want to push in 1 star. So then when we go to 2, we want to then push in another star. When we go to 3, we want to push in another star. Once we get to 4, 4 is less than or equal to rating. So then we want to push in another star. So that's going to push in 4 stars. And then once I is 5, this statement's no longer going to be true, and we're no longer going to push in a full star. And when I is greater than rating, we want to do an else statement. And we'll say we want to do a stars.push. We want to push an empty star. So let's grab our empty star. Push that in. And for now, I think that's good. You'll see that this won't handle fractional numbers yet, but we'll implement that in a sec. And then what we're going to do is just render out stars. And let's go to our restaurant detail page, and let's render that out. So I'm going to remove this line right here and do a star rating. So let's import that. And that actually has to be a component. And then we're going to pass in a rating, which is going to be, let's just start out with 3. Okay, so let's take a look at that. We click on Taco Bell. You can see that now we have 3 filled stars, 2 empty stars. That's exactly what we want. Let's try 1 star. Great. Let's try 5 stars. Great. So it looks like our component's working. However, like I said before, if we try to do 2.3, right, it's just going to display 2 stars. So we need one more if-else statement so that we can put in a half a star. So let's go back to our star rating component. I'm going to move this down. And we'll do else if. And this one's going to look a little bit goofy, but we're going to do when I equals math.ceiling rating. So basically, this is going to take our rating, and if it's a decimal, it's going to just raise it to the highest number. So if it's 2.3, it's going to go to 3. If it's 3.7, it's going to go to 4. If it's 4.1, it's going to go to 5. So it's going to compare the ceiling of that, and then it's also going to check if the number is a decimal. So to check if a number is a decimal, we can do not, or actually before I confuse you guys, we'll do number.is integer rating. We're going to pass in rating. This is going to evaluate to true if this rating number is a whole number or an integer, but we want to see if it's a decimal. So we'll do not. All right, so there's 2 checks. We check to see if I equals the ceiling of that value and if it's a decimal. And in that case, we want to do a stars.push, and we're going to push in a half a star. So where's our half star? This guy. Copy that. Push that in there. Let's save that. And now if we go back to our restaurant detail page, we're passing in 2.3 still. So let's take a look. And so now we've got 2.5 stars. That looks good. Let's try 3.7. That looks good too. Let's try 1.2. That looks great as well. So that's our star rating component. And so in the next video, we're going to work on building out our review cards. Okay, so now it's time to work on our reviews component. So we're going to have a reviews component that's going to encompass all of the reviews. And a review is going to be made up of this nice little card. And we're going to have 3 cards per row. And as we add more reviews, it should automatically add in another, as we add in more reviews, it should automatically add a new row. So if I just type something in and just do that, you should see that it automatically creates that new row and it's going to fill it in accordingly. All right, so let's create a new component. This is going to be called reviews. Now, for now, we're just going to hard code some values. So we're just going to get the HTML and CSS out of the way. So we want a div with a class of card, a class of text-white, and a class of bg-primary, and a class of mb-3, and a class of mr-4. All right, and if you guys are wondering where I'm getting these classes, always just go to Bootstrap. Always go to the Bootstrap documentation. And so here in the documentation, there should be under components, we should look for something called card. And they're going to give you a lot of example cards. I'm trying to remember which one I used. I think it's somewhere at the bottom. Yeah, so I think I used this card right here. So it's pretty much this, except I added the rating at the bottom. So they have an example, and it's pretty much this first card right here. So you could just copy that and just make the same adjustments that I made. And we're also going to have to do an inline style. And I'm going to set the max width to be 30%. So we get about 3 columns. And within this div, actually, we need to remove the outer div. Actually, no, we don't. We want that outer div. So this outer div is going to be, it's going to have a class of row dash calls dash 3, and then mb dash 2. And within this div, we're going to create another div. And this is going to be the header. So we're going to give it a class of card dash header, a class of d dash flex, and a class of justify dash content dash between. And then we're going to have a span tag, which is going to be the name of the reviewer. So we'll just put in something like Joanne for now. And then we're going to have another span tag. And this span tag is going to have our ratings component. So we have to import our ratings component. So we'll do star rating and let VS Code import that for us. And then we'll give a rating equal to, I don't know, it doesn't really matter, 3 stars. And then outside of this div, we're going to create another div with a class of card-body. And we're going to have a p tag with a class of card-text. And this is going to have the review. So this is going to say something like, this restaurant was awesome. Let's save that. And we're going to render out the reviews component within our restaurant detail page. And we're going to remove this right here. We don't need this star rating component. That was just for testing. And I'm going to do a multi-line JSX expression. And we're going to do a couple fragments as well. And here we're going to create another div with a class of mt-3. And within here, we're going to add our reviews component. So let's import that. And let's save that, and let's see what that looks like. Okay, so this is what our ratings component looks like, and it looks pretty much spot on. The only other thing I want to do real quick is go to reviews, and let's copy from this div up to this div, so everything except for that outer div. And let's just paste it a couple of times so that we can see what it looks like when we have multiple reviews. Let's get at least 4 so we can see it wrapped to the new line. And yep, everything looks perfect. One other thing though is I don't like the color. The star rating component should actually be yellow, and that's an easy fix. So for each one of these stars.push under the I, just add an extra class and make it text-warning. So that'll turn it yellow. All right, and so now we've got the yellow star component. Okay, now let's move on to implementing our add review component. So this is just going to be a basic form with 3 input fields. And we're not going to actually implement the logic. I just want to set up the layout of the form and make sure that all of the input fields are controlled inputs. So for this div, let's give it a class of mb-2. And we want to define our form. And then a class of form-row. And then another div with a class of form-group and call-8. And here we're going to have a label And this is going to be for name, and it's going to say name. And then we're going to have an input with the class of form-control. And let's give this an ID of name and a placeholder of name as well. Then outside of this div, we want a new div, and this is going to be a div with the class of form-group and a class of call-for. And we're going to do a label here as well. And this is going to be for the rating. It's going to say rating, and then we want a now instead of a input field, we want a select. So we'll do select with a class of custom-select. ID is going to be rating, and we can remove the name for now. And so now we're going to define our options. The first one's going to be disabled, so this is just going to be like the header. It's just going to say rating. And then now we get our first option, which is going to have a value of 1. So this is going to represent when the review is a 1-star review. And there's going to be 5 of them. And we'll have one for 2, 3, 4, and 5. And outside of this div, we want to make a new div. Actually, no, we want to go outside of this div. And we're going to have another label and input field. So this one's going to be for review. And instead of a text field, or instead of an input field, we're going to have a text area. And then finally, we're going to have a button to submit. It's going to have a class of btn and a class of btn-primary. It's going to say submit. So let's save that and let's render that out onto the restaurant detail page right under reviews. Okay, and so now we've got our add review component. However, it's still not a controlled component, so we want to go back into that and change that real quick. So we're going to have to use the useState hook 3 times for each one of the input fields. We'll have const and then name and then set name. There's going to be one for review or to review text. And now for the input fields, we just have to set the value equal to its respective state. And we also have to set a onChange event handler. Yep, so that should make our form fully controlled. And what did I mess up? Use state is not defined, so let's import that. All right, and if we go to our detailed page and then go into our components and select our add review, we should see that when we start typing in things, our state should update accordingly. Yep. Yep, and yep. All right. So now that we've got our base styling for our reviews, what we need to do is actually fetch the reviews from our backend database. And if you take a look at how we've set up our detailed page, right now you can see with the use effect hook, we're fetching the data. And once we retrieve the data for the specific restaurant that we selected, we're going to set that into our context state for set selected restaurant. And the data that we get back from the backend server, if we go to our server.js, you'll see that under get a restaurant, right, we send a get method with a specific ID. And then from the Postgres database, we're just going to do a select star from restaurants where ID equals, and then whatever the ID is, and then return it as a property called restaurant. And so there's a couple of ways to tackle how we can retrieve the data from the backend, right? So we could set up a new route, like we could call this, app.get, and then we could specify the URL as something like API/v1/restaurants, then /ID, and then /reviews or something, and then pass a callback function, and then basically fetch the data for the reviews for this specific restaurant and then return it. And that would make our front end have to make two calls to our backend server. So instead of doing that, what I'm going to do is within the get restaurant API call, we're going to retrieve the data for the reviews within this route handler and then return it to our front end. So our front end only has to make one API call to our back end. And the way I'm going to do this is we're just going to do another call right here. So under this try block, we're going to just copy this and just paste it down here. And what we want to do now is we do select star from reviews where ID equals 1, and then we're going to pass the rec.params.id. And we're going to save this in, we'll call this reviews, and we'll call this restaurant. Okay, so this route handler is going to handle getting all of the data for the restaurant as well as the reviews. And then now we're going to send that data back to our front end, but we have to structure it a little bit different because right now we just have restaurant and then the data for the individual restaurant. But what we want to do is change that a bit. So this is no longer called results. This is going to be called restaurant. And then we want to append the reviews. So we'll do reviews and store that in reviews.rows. Okay, and so that should be all that we have to do. The only other change that we have to make is we have to update our front end because now we're getting our data in a slightly different format. And let's go to our restaurant detail page. And where we store the data for our selected restaurant, you'll see that we're doing response.data.data.restaurant. However, since we've changed up our data and we are also appending the reviews data, we want to store the reviews also in here as well. So let's just quickly do a console.log on this response. and I'll show you what that looks like. So we're on a detailed page. So when we see the output, our output's going to look like this. So this is the response we get from our backend server. So under data, then data, we've got two objects. We've got restaurant, or we've got two properties on the data object. We've got restaurant, which is going to contain the information of the restaurant that we selected. And then we've got the reviews, which is going to be an array of reviews. So we want to store both of these. So we're just going to do response.data.data instead of response.data.data.restaurant, because we want both the restaurant and the review data. So let's remove that console.log. Okay, and for reviews, we want to pass a drop down called reviews, and this is going to contain selected restaurant. Okay, so now reviews has access to the restaurant and all of the reviews. And now if we go to our review component, we can then update that accordingly. So let's change up a few things. And first of all, I'm going to take all of these cards that we created, and I'm just going to comment them out for now. And so we just have this one parent div. And within here, we'll do, well, first of all, let's destructure out reviews. And we'll say reviews.map, and then review. And now we can just copy these lines. So let's see if I can, probably shouldn't have commented it out, but I think up to here is all we want. So this is going to be one card. And it looks like I got an error where it happened expected an assignment or function call instead of an expression. And yeah, I already see the error. So we want to wrap this. Actually, hold on. Let's undo this for a second, just so I can explain what we need to do. First of all, we need to do a return, because remember, we need to return something. And we're going to return a multi-line JSX expression. So now we can paste that in there. And now if we hit save, we still get an error. Let's see, reviews.map is not a function. And what did we pass down? Oh, so we passed down selected restaurant, but we want selected restaurant.reviews. Okay, so that's better. And now let's go back to reviews, and let's render out the specific data. So under the name section, we want to render out reviews.name. Under the rating, this is going to be reviews.rating. Sorry, this should not be reviews with an S. This should be review, which is the current review that we're iterating over. And then finally, the p tags. This is going to contain the body of the review. So we'll do review.review, I believe. And we're getting a warning, invalid property class. So I must be giving somebody just a class. Where is it? It should tell us the line. This is under star rating component. So let's go to our star rating component and just fix up these errors. So yeah, these should all be class names, by the way. Okay, and yeah, so the only warning we should ever get is just this warning that we're not passing a key into the prop for the star rating. However, for reviews, we already have a good prop that we can pass in. So if we go down to reviews again, and when we return this parent div, we can pass in a key. Key equals review.id. So that message should go away. And if you want, did it help? I spelled it wrong. There we go. So we just have one left for the star rating, and we don't really have a good key for the star rating, so we can just, under this push statement, we can just add a key here. We'll just say key equals I. I know it's not really a valid key, but I'm tired of looking at that error. Okay, and so no more warnings. That's good. And if we check our review, I believe this is coming from our backend server. So let's just double check. The restaurant ID is 2. So if we do select star reviews, where ID equals 2, select star from reviews. So it's Joanne Bad Restaurant 4. Do we get that? Yep, perfect. And if we go back to, I think one of these has a lot more reviews. Let's do a select star from reviews. So one, whatever restaurant that is. With an ID of 2. Oh, whoops. Let's do a select star from restaurants. Let's see who has an ID of 2. So whatever Taco Bell. So one of the Taco Bells should have, and it's only rendering one of these for some reason. So there must be an error. Let's take a look at the output. Under our restaurant detail page, after we get our response back, let's do a const or console.log and see what the response is. So we should be getting multiple reviews. And under reviews, we just get one review. And I think I already know what the error is. So if we go back to our server.js, let's see, select star from reviews where ID equals that. So that should work, but let's do a console.log for reviews and see what that looks like. Hit refresh here. And let's see what this looks like. It says that there's only one review for that restaurant. Interesting. Oh, I see my mistake. Okay, so this should be select star from reviews where restaurant underscore ID is equal to rec.params.id because we want to search based off of the restaurant ID. So now this should retrieve all 3 reviews. Now if we hit refresh, we get all 3 reviews. Great. Looking at the final app, we do have a header as well as this rating component right here. So let's quickly add that in as well. And so going back to our restaurant detail page, we can define the header right above here. Actually, we'll do it right here. And we'll do H1. And now remember our restaurant is being stored in set selected restaurant. So we'll do, or it's stored in selected restaurants. Selected restaurant dot restaurant, right? Dot name. Right. And if you're confused by this, remember, just go take a look at the way we stored our data. And if we go into our components and take a look at our context provider, right, our state is going to look like this. Where is it? Yeah, so here. So we're going to have a restaurant and then reviews. So we want selected restaurant dot restaurant and then dot name. And now we get Taco Bell. That's good. We're going to probably have to add a few classes. So we'll do class name equals text dash center and display dash 1. It's going to center it and make it a little bigger. There we go. And we still have to do this part, but we'll come back to that in the next video because this gets a little bit tricky because now we have to average out all of our data, and that takes some time, and I have to explain a few things with regards to Postgres. A couple sections ago, we implemented the add review component, However, right now it's not actually doing anything. So it's not actually going to add a review to the database. It's just right now just a dummy component. And so in this video, I want to tackle implementing the logic for adding a review. And there's two things that we have to do. The first thing is we have to implement that in our backend first. So we have to set up a new route on our backend so that we can add a review to our Postgres database. And then on the front end, when the user hits the submit button, we have to call or send an API request to that new route that we created so that we can add that review to our Postgres database. So let's first set up our backend server, and we're going to have to define a new route for that. And I'm just going to go to the bottom right here, so right above the app.listen. And we're going to do app. And this is going to be a post because we're going to add a review. And the route that I'm going to use is going to be API/v1/restaurants/:ID. So whatever restaurant we want to add a review to, and then add review. And once again, we're going to have access to request and response. And here we're going to need a try catch block. And we already know that this function is going to have to be an asynchronous function. And so we want to do a db.query. And what's the query we want to do? Well, let's go back to our PSQL and let's just insert a new entry into our database. So we're going to have to do insert into reviews. And then we're going to have to pass in the restaurant ID. We're going to have to pass in the name, the review, as well as the rating. And so the values for that, we'll just do some, we'll pass it into, let's say, Cheesecake Factory. So an ID of 4. The name is going to be Mark. And the rating or the review is going to be restaurant sucked. Oh no, I messed that up. Ugh. And then finally, the rating is going to be a 2. Okay, let's try that. And so now we have inserted a review into the database, and we can do a select star from reviews to see that review. And that last review right here is the one that we entered. So this is the query that we have to make to insert a new review. And so let's just do the same thing on our Express server. So we want insert into reviews. And we're going to do restaurant ID, name, review, and rating. And the values, these are going to be, and remember, we're going to have to do the parameterized query. So we're going to do $1, and then $2, and then $3, and $4. And in our array, let's first pass in what's going to replace $1, which is going to be the restaurant ID. And we have access to the restaurant ID from the parameter, right? So we can do rec.params.id. Okay, and then all these other fields are going to get passed in from the body. So they're going to get assigned to rec.body, and then we're going to do name for the first one, rec.body.review, and then rec.body.rating. And here we'll just do a console.log error. And after we insert that, well, first of all, we're going to want to do await. And we want to store, we'll just call this const new rating or new review. And then we want to do a res.status. And this is going to be a 201. And we're going to do a .json. And we're going to send back the new review. So first of all, we're going to send a status of success. And the data, we're going to send back review, which is going to be new review. And then we want dot rows and 0. So now that we have this in place, the first thing I like to do is just test it out in Postman before we proceed to actually implementing it in our front end. So I'm going to do a new request. We'll call this add review. And this is going to be a post. And the URL that we're going to go to is this. So we want HTTP localhost. What port were we running on? I can't remember. 3001. Let me check the environment variable. 3001. Okay. And so the ID, we'll just do an ID of, what was the last one that we did? An ID of restaurant ID 4. We'll do 4, and then now we have to pass in the data for the review. So we'll do JSON, and we just need 3 things. So we need name, it's going to be Charlie, review, and then finally we're going to have the rating, and this is going to be a 1 star. Yep, so let's give that a shot. And something happened, so let's see what happened. We broke something. Cannot read property of 0 of undefined. Interesting, I've never seen that error before. Let's do a console.log of new review. Let's try that again. Okay, so I see the error. We're not actually returning something even though we successfully inserted it. And I think you guys know why. That's because we have to do star or returning star so that we actually return the review that we just created. Okay, so now let's try it. And still broken. We got rows. Oh, it's rows with an S. There we go. So now it worked. We got the new review that we just created. And so our backend is complete. And now let's move on to working and setting up the front end. All right, so now that we've completed the backend and implemented the logic for adding a review on the server side, let's do the same thing on the client side. So we want to go to the add review component. And if you guys already forgot what that looks like, let me pull that up. So got our add review component, and basically once the user hits submit, we need to add a review. So we'll hit that API endpoint. And let's go to our button at the bottom of our add review component and set up an on-click event handler. And this will be handle submit review, handle submit review. And we'll do const handle submit review. And so remember, when you submit something, well, first of all, let's make sure this button is a type of submit, which I believe is the default, so we shouldn't have to do it, but just in case, we'll do submit. And anytime we submit something, remember, we want to pass in the event, and we want to do an e.prevent default to prevent the page from reloading. And with this component, what we need to do is we need to import our API, our Restaurant Finder API. So let's do that. And so now we can make an API call to our backend. And so this is going to be a .post. And we're going to send this to, well, what's the route that we need to send it to? Well, let's go back to our server and see. So we have to send it to API v1 restaurants and then :ID and then add review. So we need to get the ID of the restaurant that we're concerned with. So under add review, let's comment this out for now, just so we don't get any errors. And I'm going to import location or use location from the React router library. So if I do const location equals use location, and then just do a console.log underneath that, this is going to give us access to the specific ID that we have right here. So this location hook actually just gives us access to our entire URL. And we can do use location. Oh, sorry, not use location. Do location. And we have to import use location, of course. So we'll let VS Code do that for us. So now if we open this up, you can see the URL. However, I realized maybe location is not the best one. Instead, we could just do the same thing that we did with restaurant detail page. And we can say, where is it? Use params. So we can just destructure that out again. So I'm going to go back up to add review, change this to use params. Make sure you import use params. Okay, so we've imported that. And let's just make sure we have access to ID now. So let's check that. Unexpected use of location where? Oh, here. And now we should get a 2. Okay, so we now have the access to the ID. So we can now go into our API request and do a templates literal and say we want ID and then /add view. And then the second argument is going to be the body. So we're going to pass in the name, which is storing the value of the input text field for the name. We got the review text as well as the rating. So we'll do name review, which is going to be set to review text, and then rating. And we have to do an await. We don't really need to store the data, but for now, let's just store it, and we'll call this new review equals. Actually, we'll call this response because that's what we've been doing for the rest of the project. And let's just do a console.log response. And I got an error, so this needs to be an asynchronous function. Okay, and let's minimize this, and we're going to set this to test, submit. Okay, so we got a 201 back, which means it worked, and we should see the new review. And so this is our new review. However, we don't actually see it on our page because we haven't implemented any logic to actually re-render the screen. But we'll do that in a second. But let's just double check and make sure that it's actually in our Postgres database. So let's do a select star from reviews. And we've got the test. Great. Now, how do you guys want to set up the kind of the refreshing of the page? There's a couple of ways we can do this, right? We could take the review and add it into our where is it? I think it's, yeah, our selected restaurant. We can add it into that and just store the reviews in there. However, that's going to create a problem because let's say in the front end, we just add the new review that we create. Well, the problem is that this won't get updated. So our average ratings won't get updated and the number of ratings that we have won't get updated because that comes from another call to our back end. So instead, what I'm going to do is I want to essentially refresh the page. So we're going to refresh the page, which should trigger this new use effect hook. It should fetch the data again from our backend server. And that fresh data will then have it'll have the new review already in there, and it should be able to calculate what the average review is and what's the average rating. And I was looking for a way on how to actually refresh the page in React Router, and there doesn't seem to be a convenient or a nice way of doing it. And the only examples I could find on how to implement this on Stack Overflow was it didn't really seem like the best way to do it, but it seems to work. So I'll show you guys what I did. So under add review, after this works, we probably should put this in a try catch block first. And basically, after this happens, what we want to do is, ideally, we should just be able to import our history. So we do const history equals use history. Make sure you import that. And, originally I thought just doing a history.push and then importing, we just want to push the same exact URL that we are at. So this exact URL. And we can get our URL by importing that use location. So we'll do const location equals use location. Right, and just to remind you guys what that looks like, let's just do a console.log of location. And so we can see that if we do location path name, that's going to give our full URL. So let's try doing a history.push with location.pathname. All right, and now if I add a review, so once again, I'll do test and then test, hit submit. You see that new test doesn't come up. And just to make sure, I'm going to do 1, 2, 3, 4 so we don't mix it up with that. Submit, nothing happens. So this history.push doesn't seem to do anything. And I guess that's expected behavior. So what we need to do is we need to route to another page and then route back to this page. And that's going to trigger a refresh. So we can do history.push and then we go to /. So we're going to go back to the home page and then quickly navigate back to this page, which should trigger a refresh. And I'll show you an example. So I'm going to do one, my name, and then food was good. So now if I hit submit, it now loads up. So what happened was that we actually navigated to the home page and then quickly came back really quickly. And so that triggered a refresh. But notice that, we have the back button, which takes us back to the home page, which does confirm that we are navigating to 2 different URLs to accomplish this. So I'm sure there's a better way of doing this. If you guys know, let me know. But this is all I could find from my research online. But anyways, guys, so that's the add review functionality. We're almost done with our application. There's really only 1/2 things that we need to implement. There's the average rating and the number of ratings that we have for a restaurant. And this exact component is going to be used also here as well. So we've got the average review as well as the number of reviews. Although I guess now that I think about it, we probably should have made what the average rating is right here, but I kind of like having the number of reviews here. So in the next video, we'll start implementing that. There's going to be a lot of things that I'm going to have to explain to actually accomplish that. So it's going to start diving a little bit deeper into Postgres, and we're probably going to have to cover some advanced topics. So if it confuses you a bit, just know that we're starting to get into some more advanced topics in Postgres, and it may take a couple of times of either watching this video or doing some reading on your own to really start to grasp all of the concepts I'm going to cover in that video. All right, guys, so in this section, we're going to learn about aggregate functions within Postgres. And there's a couple of different aggregate functions. We've got average, which, it's going to be exactly what you think it is. It's going to calculate the average of something. We can get the count, so the number of certain instances. We can get the max value, the min value, and the sum of a bunch of values. And I'm going to show you how to use that because we will eventually need to use these when we create a couple more complex SQL queries to get the data that we want. And this is all really just building up to being able to grab what the average rating is. So we have to calculate the average rating for a restaurant, as well as the number of reviews that a restaurant has. Okay, so let's do a select star from restaurant. Actually, from review. Let's do from reviews real quick. And let's count the total number of entries we have in this reviews table. Obviously, we've got 17 right here, but I want to show you how to use the count aggregate function. So we can do a select, then count. So we do count, and then we specify the column we want to count on. So if you don't really care, we can just do a star, and then from reviews, and it should return 17. Now, if we put in a column like a rating or something, right, we're going to get the same number because there are 17 total ratings because each one of these entries has a rating. However, if there was a couple of entries in here that didn't have a rating, then we would get a different number. So that would be the use case of passing in a column. Now, let's say we want to find what the minimum rating is. We can do a select min and then pass in the column that we want to find the minimum of, which is rating in this case. And we can do from reviews, and it should return a 1, right? And that's just because we do have one entry with a 1, so that's going to give us the minimum value. We can get the max value, which is going to be a 4 in this case because there are no 5s at this point. And if we want to get the average rating across every single review, we can change this to an average. And we can see that the average is 2.88235, right? And obviously this number is kind of ugly. So with Postgres, we get some extra tools to make that a little cleaner, and we can change that to a trunk. We can do trunk, wrap that in there, and trunk takes 2 arguments, right? First, the number that you want to truncate, and then how many decimal places you want to give it. So let's say we only want to get data up to 1. Let's do 2 decimal points. So we pass in a 2. Okay. I forgot the C in trunk. Right now we get up to 2 decimal points. If we do 3, we'll get 1 more decimal point. Fairly simple. However, one thing I don't like is that when we run this SQL query, you'll see that the column name changes to trunk. And even if we didn't do trunk, you'll see that the column name is a max in this example. So certain times Postgres will return just max or min or trunk depending on what your aggregate function or method was. And that's kind of annoying when you want to, make a call to your, and that's kind of annoying because, from Node, when we actually make our query, we don't want to get a column back with max because we may not know what that actually represents. So in our query, what we can do is we can always pass in as and then give it the name. So this is going to be average review. So now the column gets changed to average review. And you can do this really anytime you want. So it doesn't just have to be with aggregate function. So let's say we just did a standard select, and then we did a name and then rating from reviews, right? This is just going to give us the name and the rating for a review, and we can rename both of those. So if I wanted to change name to as username and rating to as, we'll call it restaurant_rating, right? Now you can see that the columns get updated accordingly. All right, and so so far that's all cool and well, but we want to eventually get to the point where we can calculate the average reviews for a restaurant, right? And the way to do that is, we can do select, and then we want average, and we want to average the restaurant rating. So we'll do rating. We're going to do an average on that column, and this is going to be from reviews, but we can say where restaurant_ID equals something. So we need to grab a restaurant ID. So let's see if I can find that. And we'll grab let's grab 2. Okay. So we'll grab restaurant equals to 2. And so now we can get the average value of all of the ratings for restaurant 2. And we probably want to change that. We want to truncate that just so we can get a cleaner number. And we'll go to 2 decimal places. And so there's our average, and we can rename that column to be, we'll call it average_rating. Okay, and so there you go. That's going to be one of the queries that we need to make because now we can get the average rating for a restaurant. Now, how do we count the total number of ratings that a restaurant has? Well, we're going to have to use the count aggregate. So we do select count. And then we want to count on, it doesn't really matter. We can just do a star, but if you wanted to, you can always just do rating. because that is the column that we're concerned with, and we want to count the ratings, and we want to do it from reviews, where restaurant underscore ID equals 2 again. So this is going to give us the total number of reviews, or the number of ratings, I guess, for restaurant 2 specifically. And so you can see that we got 7, and let's just double check and make sure that that is correct. So we'll do select star from reviews. And if we go to a restaurant ID of 2, we've got 1, 2, 3, 4, 5, 6, 7. So that looks good. Now there's another feature that I want to show you guys in Postgres, and that is the group by feature. So we can kind of group output based off a certain criteria. So let's say we want to find the total, let's say we want to count the number of restaurants in a specific location. And we can do that by doing a select. And then we want to select the location because that's what we're concerned with. And then we want to count. So we want to count the locations, and you can do location or star, doesn't really matter. And we can do this from the restaurants table, and we can group by, we want to group by the location. Hit enter, and so now it's going to list out each location and the total number of restaurants in that location. So there's going to be 2 in Dallas, 2 in Virginia. We got the A in that, but everything else has 1, and we can just double check. So there's 2 here, and there's 2 Dallas, and everything else is 1. So that's how we can use the group by method to group certain data together. And so, let's say we want to count the number of ratings for each restaurant. Instead of just getting the ratings for one individual restaurant, let's see if we can get it for all restaurants. So let's do a select star from reviews. And let's try that same thing. So we'll do select, and then we want to grab the restaurant ID. And we want to say we want to count on the restaurant ID column. And we want to do this from the reviews table, and we want to group by restaurant underscore ID. And so now you can see that for a restaurant ID of 4, we've got 5 reviews, and let's just double check if that's the case. So restaurant ID of 4, there's 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Okay, that's good. For a restaurant ID of 10, there's 2 of reviews, so 1, 2. So that looks like that works. And so I think that's enough Postgres for this video. In the next video, we're going to go over how to join data from 2 different tables. And so this is an important topic. It's a little complex, but hopefully it's not too bad. And even if you guys don't end up kind of understanding what we're doing, the purpose of this whole course of this video was to just show you how to build a full stack application. So I don't want to do a deep dive into any one component within our full stack app. So I don't want to focus too much on Postgres or too much on Node or too much on React. I just want to show you guys how all of the pieces really interact with one another. All right, guys. So, we're in the final home stretch. The last thing we need to do is implement this average rating and count. So every time we fetch data for the list of restaurants, it should give us what the average rating is for each restaurant, as well as the number of total reviews for that restaurant. And if we go into the detailed page, we should see the same thing. So for the Cheesecake Factory, it's going to give us the average rating and the total number of reviews. And there's a couple of ways of doing this. The easiest way would be, well, I don't know if this is the easiest way, but the easiest way for you guys so far would be that when we go to do a GET request to retrieve our restaurants, we could send one more query to get that information. So when we are trying to get the average rating for an individual restaurant, we could always do a select star. And then actually we can do select average of the rating column of the reviews table from reviews where, and then we just pass in the ID of the restaurant that we're concerned with, right? So we can just do that, and that's going to give us the average rating for an individual restaurant. And we can also do the same thing for, we can also do group by restaurant, restaurant underscore ID, and grab that. And so that's going to give us all of that data. So we could technically, under the get all restaurants, make that same exact query to get all of the average as well as the count data. Remember, the count would just be, we could just do count rating. It doesn't really matter which column we put in, right? So now we got the count and the average, and we could just do another query, right? So right after this, and then just kind of do a little bit of JavaScript magic and join the data all into one array. However, with SQL or Postgres, we can actually get all of this information out in one table. However, it's a little bit complicated. And so I won't go too much in depth into how we actually get to the final query to get all that information. But I do want to explain just a couple things. So there's this thing called joins in SQL. And a join allows you to get data from two different tables at once. So if we have the data from the restaurants table, we can do that. And then if we want the data from the reviews table, we've got that. But till now, there's been no way of actually getting the information from both tables. And so what we can do is actually do a join. And the way that a join works is pretty simple. However, there's a couple of different types of joins, and they all behave a little bit differently. And we can do nested joins, and they start to get really complicated. But here's an example of a join. So we're going to grab everything from the restaurants table, and we're going to do a inner join. And we want to join it on the reviews table. That's the only other table that we have. But we want to then specify a column that we want to join things on. So we want to say that, let's say we want to get all the reviews for each restaurant and kind of join them together. So we want to match whenever under the restaurants table, the ID equals the restaurant ID from the reviews table. So if it's a 2 here, we want that to line up with a restaurant ID of 2 here so that we can see each review next to each restaurant. And to do that, we can do restaurants, actually reviews, and then specify on. So we're going to join on restaurants.id equals reviews.restaurant underscore ID. And what did I mess up? Restaurants. And I forgot my from. Wait, what is happening here? And this should be no S. There we go. Okay. And so now if you take a look at the output, you can see that we've got the restaurants all on the left side. And this is for a restaurant with an ID of 1. And then you'll see that if you keep scrolling to the right, we then get to the review that's associated with a restaurant of ID of 1. So we are joining on the restaurant ID and the ID of the restaurant. So this column comes from the review. This column comes from the restaurant. So we're joining it together. So you see 3 entries for Wendy's, and that's because there's 3 reviews for Wendy's. Same thing with Taco Bell. So we've got 3 reviews for Taco Bell, and these are the 3 reviews. However, we can do other types of joins. So these are going to look a little different. Notice how we don't actually have all of our restaurants. Instead, we have 17 lines because we have 17 reviews. However, not all of the restaurants have a review. So we don't see any restaurants that don't have reviews. Now, if we do a left join, we're going to see a slightly different output. So now we see all of the restaurants, even the restaurants that don't have reviews. And so those are just a couple of joins. We've got a couple of other joins as well. Like there's right join, there's a full outer, I believe, and they all kind of display data a little bit differently. And so I recommend you guys play around with it just to get a little familiar. But what we're going to do is I'm going to give you this absolute monstrosity of a query. So look at this. So we're going to do select star from restaurants, left join, and then we want select and then restaurant underscore ID. Then we want the count. And then we want trunk. I'm going to grab the average. It's going to be rating, comma 1, and then as, and I'm going to rename that column to average underscore rating from reviews, and then we're going to group by restaurant underscore ID, and then we do reviews on restaurants dot ID equals reviews dot restaurant underscore ID, right? Pretty big SQL query. So now if we hit enter, what did I do? I spelled reviews wrong. And so look at this chart. So now we get a output of all 10 restaurants, and you'll see that we get the restaurant ID. Oh, sorry, that's not what we can. We get all the information about the restaurant, and then we also get how many reviews there were and what was the average rating. So we get all of the data that we need with just this one SQL query, so that we don't have to make multiple queries in our backend and then kind of like jam the data that we get from those two queries into one array. So this should make our life a little bit easier. We're going to copy all of this. I'm going to copy this whole query. And we should just be able to swap things out without an issue. So I should just be able to paste this into here. And this shouldn't, I believe it shouldn't break anything. Actually, let me undo that for a sec. I'm actually going to have to do two queries now that I think about it. So we're going to do, we'll do select star from restaurants here. And then what I want to do is we're going to do const restaurant ratings data. So we'll do another query for the data, and we'll do await db.query and then pass that query in. And so now let's do a console.log of results. And then we're going to actually do results. And this is going to be the results that we get back. And then we're going to do a console.log of restaurant. And I realize I spelled that wrong right there. Restaurant. Okay, so let's hit save and make this a little bigger for us. And I'm going to just hit that API endpoint with the get all restaurants. Hopefully I don't get an error. I don't. So far so good. I forget where this starts, so I'm going to just hit enter a few times. And now we'll do a send again. Okay, so the first one, this should be the, if we go to our console.log, we're going to print out the results. So this is going to be our array of restaurants. Great. And then down here, this is going to be our new restaurant ratings data. So we can see the difference is that we get the same information about the restaurants, but we also get the count and the average. So that should be all that we need. And once again, I realized I messed up. We don't actually need the results moving forward. So we'll comment that out, and we'll comment this out. Comment both of these. Actually, let's just delete our console.logs. And let's send the data back as restaurants. So we're going to send this as restaurant ratings data dot rows. And then this is going to be the same thing. We're going to change this to restaurant ratings data dot rows. So that's going to use this new query that's going to include the extra data. Let's save that. And let's send a request. And so now when we send a request, we get count and average rating. So this shouldn't change anything from a front end perspective so far, because we have the same exact data that we did before. We just have a few extra properties on each object. So we should still be able to use ID, name, and location like we did before. And the last thing that we have to do is we have to do the same thing for get an individual restaurant. It's because, when we go to the detailed page, we should also print out that data. However, the query is going to be a little different because we want to match on a specific restaurant. So in this scenario, we're going to have to actually make two queries. We already do that right now, right? One query to get the reviews and the other query to get some information about the restaurant. So the only thing we'll have to update is this line right here. And I'm going to show you guys how we can run this same exact query except for just one restaurant. So we can just do an up arrow, and then we can just say where, and then ID, equals, and then we pick the ID of a restaurant. So let's just say we want 2, and then hit enter. And so there you go. So that's just going to give us the information for one restaurant. So now we can just copy this query and paste it into here. And we want to make sure we swap out this ID with the $1. And we're already going to swap it in with the rec.params.id. So there's nothing else we actually have to change. So all of that information can stay the same. We're going to pass through restaurant as well as reviews, and it shouldn't break our front end in any way, shape, or form. So let's just double check on that. So let's hit save or refresh. So if we check our restaurant list, things are looking good. If we go to Taco Bell, we're loading up the reviews. If we go to Cheesecake Factory, we'll load up those reviews. Chipotle, no reviews. All right, great. So everything's still working fine. We just need to render out that data. And so let's go to our restaurant list. And here, when we render out the data, we want to find the reviews section. So we want to render this data out, and that's going to be under restaurant. We've got, well, we're going to have to do a console.log because I already forgot what the data looks like. So right here, where is it? Let's do a console.log. Actually, no, we don't need to do that here. Right after we fetch the data, let's do a console.log on that response. We'll do response.data.data. Okay, so this is what our data is going to look like. So within each restaurant object, we can reference the count and the average rating. Okay, so we do restaurant.average rating and restaurant.count. Okay, so let's go down to our reviews, and let's actually define a function for rendering out the data. So we'll call this render rating, and we're going to pass in the restaurant object. And those need to be wrapped in curly braces. And let's define our render rating function. And here, what we want to do is we want to spit out the star rating. So we have to import that into this document. And we're going to give it a rating prop of whatever restaurant.id is. And then we want to do a span tag with a class of, oops, not class, a span with a class of text-warning and a ML-1. And we want to pass in restaurant.count. So let's take a look at that. And what did I mess up? Oh yeah, I have to actually return something. So we'll return I'm going to use fragments. Okay, so let's see what that looks like. All right, things are starting to look good, but I want to wrap this number in parentheses. So we'll do parentheses out here. Let's save that. And notice how whenever we have a restaurant that doesn't have any reviews, right, we get this empty, oops, we get this empty parentheses, and then for some reason it lights up all of the stars. So what I want to do is we want to make it so that it just says 0 reviews. So let's put a little if statement in here. And we'll say if there is a restaurant.count, or if there isn't a restaurant.count, we want to return a simple span with a class of text-warning, and we want it to say 0 reviews. All right, so hopefully you guys followed along. That means if there is no count, which means there's no review, then we're just going to say 0 reviews. However, if there is any reviews, then we're going to print out the star rating and this span. And so now we get exactly what we wanted to see. All right, and the last thing we have to do is implement the same thing in the detail page. So we should see that entry right up here, just like we do in the final application. So let's go to our restaurant detail page. And under the h1 tag, we're going to pass in a div with a class of text-center. And here we're going to pass in the star rating component. So remember to import it in if you haven't already done so. And we're going to give this a rating equal to, remember we have the restaurant under selected restaurant. So we can do selected restaurant, and that's our context API. Selected restaurant dot, and then what do we want? Average underscore rating. That's what we wanted. So let's see that. And so final app, we now see that taco. Oh, that's not correct. Doesn't look like it took the average rating. Let's do a save all just in case. All right, so let's refresh that and let's see what that restaurant looks like. So restaurants, I don't know, let's go to this page here. Now we can see our individual restaurant. And we do have an average underscore rating, so that should work. Let's see what we broke. Oh, I see what we did wrong. This should be restaurant dot average rating. There we go. So now we got it colored in. And the last thing that we have to do is put that span tag in. And so here, what we're going to do is we're going to say if selected restaurant dot count exists, which means there are some reviews, we're going to do the ternary operator. And this all needs to be wrapped in curly braces. And we're going to say that if there is a count, we're going to render out this template string. This is going to be selected restaurant dot count. And if it doesn't exist, we're just going to render out 0. Okay, so let's see if that worked. That did not work. What happened here? And I put it in the wrong place. So this does not go here. This goes under the star rating. And there we go. So we got 7. Let's find a one with 0 reviews. Yep, and this shows us exactly what we want. So this has 0. This goes to 3. Perfect. And now let's, we're almost done, I think, but we just got to make sure that everything works fine. So let's add a review here. I'm going to just call this test review, and we're going to give it a rating of just 1. And let's just put some dummy data. So we should see it get added, and we should see this get updated automatically. So it should go to 4, and by dropping it down, it should go down just a little bit. Yep, there we go. So it went to 4, and now it's at 3.5 stars. All right, so let's just do a final spot check just to make sure the rest of our application works. And I'm just going to do a file save just to make sure everything's good. We'll refresh the page. And so let's, well, first of all, let's add a restaurant. So we'll call this Denny's, location Carlsbad, price range 2. So let's add that. here we've got that. And let's try deleting it. Great. Let's try to update California Pizza Kitchen. And the city is going to be in New Mexico City, price range 3. Let's hit submit and let's check that. So here we go, New Mexico City, whoops, 3. So delete, update works. Let's go to the detailed page for this. There's 0 reviews. Let's add a review. We add the review. We got the review. This updated. We go back. We now have that review that updates as well. So going back and forth, it's going to update that. And what other? Yeah, that's about it, guys. So that's our entire application. You've now finished a full stack application. And I don't know if you guys would be interested in this or not, but this video has kind of gotten long enough, so I'll definitely put in another video if you guys are interested. But if you guys want to do a video on how to deploy this on either like a DigitalOcean droplet or maybe AWS, I'm happy to do a video on that. So just let me know if you're interested, and I'll get started on that. But hopefully you guys enjoyed this video, and you can get all of the code from the GitHub repository, which I will put in the link in the description down below.